those don't have audio. They're just coding screens stuff. Okay. Well, there's audio line here if we need it. I'm just going to get an extender for that. Oh, extension.
Josh. So when I'm giving a small, when I'm using this SDI, the out to the in here, is directly coming on that TV. Okay? But then this not happening, even with the provide different
Okay, yeah. Let's see how it works. That's the camera. Perfect. Is it working? No. Where's the audio? The audio is coming from becoming that. That's why I was looking at the headphones. Yeah. I can run the check. Yeah.
Check 1 2. Check. Check. Check 1 2. Yeah. Check 1 2. Check. Check 1 2. 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 Check. 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 Check 1 2. Yeah. Check 1 2. Check. Check 1 2. Are you taking the stream out of this desk? Are you taking the stream out? Yeah. Yeah. And are we running? You have
Is it all good? Should we test the other one as well? The other microphone? Testing microphone number 2. I don't hear it when I speak so much. Does it work? Does it work? Can you hear it? I'm not sure if the other one is catching the audio. I'm trying to hold it away. This one works? Yeah, okay. This is the second one. So I'll just put it on the side. Okay, both. Sounds good? I be able to see, like in the Zoom call, is it just...
Okay, well, welcome to Flower AI Summit 2025. My name is Nicholas Lane, and I'll keep the introduction here brief, but I want to really thank you all for coming. This is fast becoming the central place to meet and network and innovate in a really growing area that's so important to where AI is headed. We have folks here who are, fascinated by what federated learning can do. We have people looking at decentralized AI. We have people who believe strongly on migrating things like LLMs onto laptops, devices to maintain ownership and control of what these things can do. And it's wonderful to have all the key people under one umbrella for 2 days to see what can be accomplished. I wanted to just say a few words, and that is, wow. We have got to 2,123 registrations. There's a capacity here of about 240 people in this building. We have spillover space to use as it becomes necessary. And more importantly, because this is a global phenomena, we have a lot of people online watching. This represents around 120% increase from last year. This rate of growth is something that we've been seeing year on year on year, and it's frankly necessary if we're going to accomplish our mission of migrating from cloud-only thinking to a much more flat, decentralized destination for AI. Because of this registration, this summit, again, is the largest conference of its kind. It's the second time that we've reached this milestone, and it's wonderful to see everything growing. It would not be possible, and this is all just a simple function of the rapidly, growing and powerful flower community that you see represented here. We have folks all around the world using flower on a daily basis, training their models under this new paradigm. And so you can see here that, for example, there are 2,000 strong, active projects and solutions for AI built straight on top of Flower. And that's just one of the number of stats here that is just critical for a healthy open source community. I wanted to also say a little bit about the program. As I mentioned earlier, it's 2 days. We hope it can become almost a historic event in the sense of what we can accomplish in these 2 days. There's 4 things I wanted to direct your attention to. The first of these is that later in the day, we will be kicking things off after the break with the Flower Keynote. And so this is going to talk about where Flower is going. It's going to talk about how the ecosystem is growing. It's going to discuss some of the technical milestones that have been achieved and sort of point out where we think decentralized, federated, and on-device AI can get to in the next 12 months. So don't miss that. It's at 2 p.m. local time, or you can see all those other times globally. We also understand that because there are so many people who have registered and are going to experience this online, we wanted to direct careful attention of energy onto that online experience. And so there is a number of ways where we have a powerful online experience for you. We have, for example, online-only interviews that will be going on, rewards and exclusive talks for the folks who are dialing in from all around the world, so you will not be neglected. If you ask us a question, we'll make sure it's reflected in the room and you can have your voice heard. There are more than 70 events happening. I mean talks, panels, demos, fireside chats, a variety of different types of events happening over these next 2 days, so really enjoy those. And then finally, for those who are on site, after the proceedings today, at 6 p.m., we'll be going across the road to the Big Chill, where we will have the Flower After Hours event, where we can sort of network and digest what has actually happened over the last part of the day. So with that, again, welcome to the Flower AI Summit 2025, and I'm going to hand over to Charles, and he can tell you what's happening next. So thank you.
All right. Thank you, Nick. All right, so I'm very excited to see everyone here, some new faces, some Some of those were already there last year, so this is great. We'll start off the first session with Lorenzo Carnevale. You can come here. Yeah. There you go. And Lorenzo is going to talk to us about some climate change related issues and how federated learning and drones can help solve those. So I'm very excited about this. Thank you.
Thank you to the Wallflower team, and thank you, Nick. Good morning, everybody. My name is Lorenzo Carnevale. I'm assistant professor at the University of Messina and part of the Future Computing Research Laboratory, where I operate at the cross between distributed system and artificial intelligence. The lab participates in European project, and the talk of today is related to the TEMA project, where we work on natural disaster management, and we have the opportunity to talk with stakeholders and first responders, mostly in fire and flood management. In this case, there are a couple of limitations because first responders often involve a fleet of drones, but these drones are used only for data source, while the drones today are able to make computation because the power is growing day by day. The computation and the communication is often centralized in a standard legacy cloud solution, and there are issues related with the latency when we talk about these scenarios because they have urgent scenarios, and the lack of privacy when we migrate sensitive data. So we see a clear opportunity to move the decision-making computation to the fleet of drones. So we set up the problem as a cloud edge solution where we can run artificial intelligence task, and we give also the opportunity to models to be fine-tuned on the fly, while the drone can fly using federated learning. And so the drone that are the mobile nodes that are deployed in large geographical regions needs a structure like a hierarchical federated learning, because these are organized in multiple levels of aggregations, in multiple servers, edge and cloud servers, and they are forming clusters. So we created a new algorithm, is a novel drone hierarchical federated learning, where we take care of the dynamicity of doing clustering, and we try to optimize according to the need of the drones. So take care of the accuracy, but minimizing energy, training time, and the number of communication. So this is the structure where from the top we have the drones. They train for K1 epoch. They create a cluster with the local edge server that aggregates K2 times, so these are the rounds. And there are multiple of these clusters that every K2 times can have a second aggregation on a cloud base, so in the global server. So we set up the test using MNized in non-ED way, convolutional neural network, and the federated learning configuration as fixed global rounds in the number of 25, 30 clients, 5 base stations, 1 global server. The nice thing is that the system is dynamic, and these drones in the simulation fly from one edge base station to the other one, so changing the clusters. The FedWG is the aggregation strategy, and we used Flower for the implementation. We can see in the picture here on the right that fixing the global rounds to 25, while we increase K2, so the number of rounds, we have an improvement in accuracy. At the same time, we reduce the number of epochs until a saturation point, which is around 90%. From this graph, we try to simulate also the energy consumption to compute the number of communication, and we can say that 5 epoch and 10 rounds, and 10 epoch and 5 rounds have the same accuracy, but the second configuration has much less energy consumed. We can say that the computation in terms of energy consumption is irrelevant. The number of communication is also reduced, but the time of computation is more or less the same. Then we set up a search problem with a partial search space, and we apply the Pareto front, and we try to maximize the accuracy while minimizing energy consumption, training time, and number of communication. According to our search space, we have K1 12, so 12 epoch and 5 rounds as the best score. At this point, we would like to compare our solution with the state of the art. And we can see from the picture here on the right that the standard federated learning is not very comparable with our solution because it's not able to reach our accuracy. While comparing with the only hierarchical federated learning present in the state of the art in the literature, they have to increase the number of rounds. So this means they will have much more energy consumed, much more communication. So this is not a good case for our drone scenarios. And these algorithms, the one in the state of the art, they are static. They don't take care of mobile devices. So there are no drones. They cannot move from one cluster to the other cluster, while our solution can do it. So we can say that our drone hierarchical federated learning application is good in terms of performance because we have low cost comparing with the state of the art. So going to conclusion, we can also say that this is really effective in terms of applying in complex scenarios where natural disaster management are involved. We're aware about a couple of limitations, because when we talk about training pictures, I mean, based on a data set of pictures in drones, a supervised learning is maybe not the best case, because we should label the pictures online. So this is very complex, because while the drone sample, somebody should label, and then the drone should train. So we are aware that this is a limitation, so we are looking for unsupervised learning approaches. And we would like also to test with use case algorithms, or based on fire detection or flood detection. So just to give some credits, this work is in collaboration with the Western Sydney University and the Swinburne University of Technology. The paper was discussed in UCC 2024 in December about the urgent computing and the management of cloud edge. We collaborate with the University of Utah and with INRIA. That's it. Thank you.
All right. Thanks a lot, Lorenzo. I think we should have time for a few questions. So yes, Jan is going to go through the room. You can start there. Yeah.
Thanks.
It's on. It's on. Yeah.
Thanks very much for the interesting talk. So my question is about the security assumption, because this is totally different, to some extent, different setting than computers where you can kind of understand the attacks you apply to different devices. So in my opinion, you have got wider or larger attack vector in that setting. So have you considered different attacks or subset of attacks that can be applied to your federated learning?
Yeah, not specifically in this work, but we are working also in security aspect of federated learnings, specifically in homomorphic encryption. We have some solution to encrypt also the communication of the weights during the federated learning process. And we are thinking also to make trustedness in the drones, because we can never be sure that one single mobile device, that in this case is a drone, is a trusted device that cannot modify the training or inject some poisoning attack or something like this. So we are thinking about it, and we can also discuss later the details. You're welcome.
Hello, thank you for the presentation. I would like to know, how did you evaluate the level of non-IDness on your system or your simulation? How did you evaluate it?
Is a pathological dataset. We used Flower dataset for the distribution of the classes.
Yeah.
All right. Thank you. I think we only have time for those questions.
Thank you.
All right. So our next speaker is joining us from Oxford, where he's working on his PhD, and he will be talking to us about medical image analysis, and especially tackling some real-world issues related to federated learning. Please welcome Pramitsa.
Thank you so much. Hello, everyone. I am Pramit. I am a final year PhD student in the Department of Engineering Science at the University of Oxford. And I'm just going to submit my thesis on federated learning next week. So wish me luck. So today I thought I'll talk about like a brief overview of what we are doing with federated learning for medical image analysis at the Oxford Biomedical Image Analysis Cluster. Instead of going deeper into one particular project, I'll just give you an overview of different tasks that we are trying to solve. So I'll talk about three main topics. First of all, our real-world collaborations, international collaborations with different countries using federated learning, then tackling a few practical problems in medical image analysis using federated learning, and then federated learning in the age of foundation models. The first work we have is a collaboration between the UK and Indian sites, hospitals, where you'll see we are working on a fetal ultrasound video anatomy detection task. And we have 2 clients in Indian site and 2 clients in UK site. And we are working on detection of anatomy. So you can see there are some anatomies which are quite rare, and it leads to some class imbalance, some data heterogeneity, as a result of which we are trying to come up with some ways to tackle data heterogeneity. So we propose a client-level class imbalance mitigation technique where we sort of get the data distribution of a client and get the difficulty metric of a given client, based on which we guide a focal loss function that deals with the class imbalance. And as you can see, it can locate the anatomies quite well. The second work we had is a one-shot federated learning where we were trying to tackle congenital heart disease detection with Australian and UK sites. And as you can see, there's quite a bit of domain gap between different sites. And so if you train your model individually on individual sites and you test on your external sites, you'll see that the models 1, 2, and 3, which are individual site-specific models, don't really work that well. You have to generalize. So we do federated learning using a one-round or one-shot aggregation for this. Moving on to some practical problems, we dealt with missing labels problem. So we deal with clients where we have labeled clients and we have some clients with unlabeled data, and how do we train supervised and unsupervised models together in a collaborative fashion. We proposed a very simple technique where we say, how about we isolate the aggregation of the labeled clients and unlabeled clients so that there's no mismatch in gradients. And we add another extra step of a client-based self-supervised pre-training before we run the training every time. That helps us to adapt the models. Now, what if we have already trained our models and now a new client joins in, right? So we have client-specific personalized models and now a new client joins in, and we want to tune these personalized models to our new client as a sort of test time adaptation. So we are trying to align the gradients of these different client-specific models to my target model so that I can adapt this or align this source models to my target models for federated learning. Now, what if not just one client? What if clients keep joining in an incremental fashion? Our task is to keep learning from the new clients, as well as we need to preserve information from the previous clients, right? So for that, we use a knowledge distillation-based method in the server, where you can, as you can see, if clients start joining in, our client 1 and client 2 are specialized in segmenting pancreas and spleen, and then new clients that are specialized in kidney segmentation and liver segmentation joins in. We are trying to keep up with the new segmentation that the expertise is brought by the new clients, but we also try to preserve the information that we learned from the previous clients. We're looking at a similar segmentation problem where we work on this brain tumor segmentation or brain stroke lesion segmentation from different types of modalities in brain MRI, because you can have T1, T2, FLAIR, etc., different types of MRIs present. And so we have to generalize across different modalities and different pathologies across different clients. So we propose a sort of random modality drop during training so that the model becomes robust during the collaborative training and can generalize during testing. As you can see, for example, our method that we call Fed UniBrain has better performance, and it performs closer to ground truth with respect to the models that are trained individually in different clients. A similar problem on multimodal federated learning where we deal with language and vision. But in some clients, you have language missing. That is, you have chest x-rays in some clients, there is some hospitals, and you have reports and chest x-rays in some hospitals. So this is a problem of modality heterogeneity. How do you deal with this kind of heterogeneity? So we tackle this in different aspects. So we try to play with the self-attention, controlling the interaction of language and vision. We try to generate text whenever text is not present in a sort of generative way. We try to constrain the federated learning setup in the client level or the server level by adding some regularizers so that the models come closer to each other, even though you have modality heterogeneity in the input. Now, using foundation models, we try to fine-tune foundation models in a federated learning setup. And so what we look at is how do we use adapters, which are one of the main ways of fine-tuning foundation models. We find that if we have different clients that specialize in different modalities and tasks, that's a problem because your adapters learn different information. So what we propose is to reduce the oscillation that you can see here with the adapters, we propose to align the adapters first before aggregation. So first you adapt the adapters, or you align the adapters from different clients, and then do the aggregation. So just an alignment before Fed average helps us a lot. The last work that we have here is basically respecting the client-specific resource constraints of different clients for fine-tuning foundation models. And we select the layers. So it's a selective fine-tuning where we select layers based on the client-specific resources. And we do that in a client level using neural tangent kernel eigenvalues to select which parameters are more important. And we also do it on the server level to select how can we diversify the layer selection to have more information. That's it from my side. Thank you. So I talked about the real-world collaborations that we are having, enabled by federated learning and Flower framework, and also the main practical problems that we deal with in federated learning. I just wanted to give you an overview of the works that we have been doing in our biomedia cluster. Thank you so much.
Thanks a lot, Pramit. Do you have any questions? Yes. Oh. Oh, we also have one here, maybe. Oh. Yeah.
Thank you. Thank you so much for your talk. It was really interesting to see. I'm also working in medical imaging, so I was just wondering, how did you go about really, sorry, I think this is better. Yeah. How do you go about setting up the real-world network? Because we also had a lot of problems actually in setting it up real-world to go actually from a simulated setting to a real-world setting. I was just wondering, like, how did you deal with the communication layer, the hardware, and making sure that actually the clients have sufficient hardware, and also to have someone maybe in place that can restart your computer or stuff like that?
We had to go through all of those. We had to have data scientists in the different clients who could set up we connected via VPNs and stuff. We had servers, so we had to do all those. And then we use the Flower framework to sort of do the federated learning stuff.
Okay. Super interesting. Congrats.
Thank you.
Yeah, thank you for the great presentation. Really awesome to see that you got the real-world use case working. So about the combination of supervised and unsupervised training. So how do you deal sort of with data poisoning situations? Because if it's unsupervised, I mean, any person in any hospital could inadvertently upload the wrong scan or upload a picture of the beach rather than the medical image.
Yeah, thankfully we worked on pre-processed data where we had people who went through the data and made sure this is clean data. And so we did go through a quality assurance program to make sure that the data we have doesn't poison the results. But that would be a different scenario where we can deal with it. But thankfully for this one, we didn't go to that. We just assume that the data we have is not noisy or is not poisoned.
Okay, thanks. Yeah, congrats on the project.
We only have time for one short question. Yeah.
One quick question. I just checked your work just to testify your approach based on the medical X-ray images. Have you tried to fit other types of medical images, such as the medical patch image, or mix different types of medical images put into the same model? Is it possible to give a same result, same accuracy to your model?
Doing what? Sorry, what is the alternative?
Yeah, my question is just I just see you utilize the X-ray image of lung disease into your model. Have you tried other types of medical images to testify your research?
No. That's primarily because we have lack of vision language data sets in medical area. There are a few CT images that I've seen recently, CT datasets that have language and vision, but we are still about to try. I haven't tried it. I've just tried with the chest X-rays.
Okay, I also checked you have to test the video, medical video. So how to process the video? Do you need to select some specific frame of the video or other processing steps?
No, we work on normality prediction. So we first do a self-supervised training of different videos at different clients. And so we have only normal cases during training. So we do a self-supervised training. And then during testing, we do a zero-shot classification of normal versus abnormal.
Okay, thanks.
Thank you.
All right. Thanks a lot. And good luck for your defense.
Thank you.
All right, so our next speaker is joining us from Fontes University. He will be talking about autonomous driving and methods to mitigate adversarial conditions. Please welcome Kirill Smirnov.
Okay. Thank you everyone for coming here. I am quite a beginner in federated machine learning. I only started a year ago, and this is basically the project I have been working for my graduation, and I would like to discuss a bit about it. So the title is Federated Learning and Edge Devices and Strengthening Data Privacy and Security, and the whole project has been sponsored by the Interreg and the ART-IE project. So what are edge devices? I think all of you know by now. It's basically similar to IoT devices. It's the devices on the edge of a network, and it can range from cars, sensors, watches, and everything you can think of. And what is federated machine learning? Well, everybody here is aware of it. It allows us to have a decentralized approach in training models across multiple devices. And of course, the benefits are privacy, data transfer bandwidth usage, and enables collaboration between those many devices. So for the research domain, there were quite a few options, be it medical, but the focus was on autonomous vehicles. And why autonomous vehicles? Well, because they have a lot of benefits, such as real-time data obtained. They basically obtain data while driving. They improve the model, and they have very diverse and distributed data because the different vehicles are located in different locations, different time of day, and so forth. So what constraints does federated machine learning have? Well, the initial constraint is the resource. So some CPUs are just unable to process data quickly enough. Then data diversity and distribution. So non-IT data is quite popular in vehicle settings, and it's caused by factors by weather and traffic patterns, quantity of data available, and so forth. And of course, the highlight is a security vulnerability. So adversarial attacks such as data poisoning, as some have previously mentioned, degrade global model performance. So for my project, I decided to use clustering, weights-based clustering and accuracy-based clustering. I did a bit of switching in the project. And it would basically group clients with similar models to optimize the training efficiency. So for my experiment, I had 4 client clusters with an adversarial attacker, which would poison a different amount of them, and then they would aggregate the model and send it back. So in the latest version of my project, the clustering has been done based on the accuracy. So only one thing to measure, which is very easy, and the clustering itself has been done using k-means. So first we had the accuracy scores for the round, and then they would get clustered. So for this project, Flower Framework played the biggest role, so I could easily customize the clients themselves and the strategy to cluster them. For the model, I used the MobileNet v3. It is pretty lightweight and efficient for edge devices. And for the dataset, I chose to do something out of the ordinary, and it's a dataset from Kaggle with over 8,000 images. They are a bit blurry because they're only 480 by 300 pixels with 5 labels each, well, with 5 labels total. And they were recorded from the dashcam of the vehicle. So I experimented with multiple scenarios, such as the baseline experiment without any data poisoning conducted, and affected the number of poisoned clients with a fixed poisoning percentage, and so on and so forth. And in total, 24 tests have been conducted. So from the results of my experiments, the base model, basically without the clustering, so I still had a federated machine learning setup, was 60% accuracy, and with clustering it jumped to 72% accuracy. So on average the difference was, well, nearly 18%, and the best was 18%. So on the bottom left graph you can see that it was tests 1 and 2, basically the baseline with and without clustering, but with no data poisoning, and they performed quite similarly. Then as the number of poisoned clients increased, it basically improved the clustering, and when I introduced non-IID data and data poisoning at the same time, the improvements, well, were way more noticeable. So for some of my conclusions that I have found from my experiment is that dynamic clustering is able to successfully mitigate data poisoning depending on the number of clients. MobileNet v3 is a lightweight model enough to train all of the clients. And the approach, I first also wanted to find out if it's feasible to do the training on the autonomous vehicles, and it consumed about 15 to 20% of the CPU. So that was still making it possible to train while utilizing it. So for the future of this project, at least my recommendations were refining the clustering techniques by enhancing the adaptability, by dynamically adjusting the number of clusters, because mine was hard set at 4. Then improved model selection. It is because each cluster provides a different model, aggregating all of them, even with the poisoned ones, is not the best idea. So you want to specifically select which clusters are contributing. And then expand the applications. Test the methodology in diverse real-world scenarios to improve scalability and robustness across edge environments. Because currently it has been only tested on driving datasets and everything such as that. So thank you everybody for listening. If you are interested in the code that I wrote, please check it out. It's currently on GitHub and public. I will be uploading the research paper to it soon after today.
All right, thank you so much.
Yes, we have a question.
Perfect.
Yeah, thank you again for this nice job, and welcome to this Federated Learning Award. No? So I wanted to know if you managed to somehow evaluate the quality of the cluster that you were creating or not, or if you thought about doing it later. The quality of the cluster.
The quality of the cluster. I haven't measured individually quality of the clusters themselves, but more of the performance of the clients. But to calculate the performance of the cluster, you can maybe probably just combine the total and have a specific formula for that.
Yeah, or for example, I was thinking about the silhouette score, something like that, because you have used k-means, so probably you can see how good it is based on the silhouette score. I don't know, something that
yeah,
out of okay.
It's just I had quite limited of time, about 4 months to complete this project, so there's definitely a lot to improve.
Okay, thank you.
Thank you for your question. Anyone else has anything to say?
We have a question here.
There it is.
And also, if you're joining us on the live stream, feel free to send the questions through Slack. We'll also be watching out for those. Good.
Hello, thank you so much.
So.
Hello, thank you so much for the talk. I was wondering, you're clustering based on the performance, right?
Yes.
So, and then because you're also using it on edge devices, have you encountered a problem that you're over estimating some of the edge devices because some edge devices may just have limited capability, which yields a bad performance, and then you accidentally thought that they are poison models?
So you mean I might have accidentally thought that they were poison models because they're poorly performing?
Yeah.
Well, in my simulation, basically, I artificially made the poisoning. So we have a normal data set, then I do some label flipping, and it goes from 10% of the clients poisoned or 10% of the data poisoned to up to 100 for both of them.
I see. Thank you.
So you can adjust it. I also have a user interface in the code if anyone is curious, where you can adjust the number of clients poisoned, the number of clients used, and the poisoning percentage.
Perfect. Thank you.
All right. Thanks a lot, Kirill.
Thank you for your time.
All right, so our next speaker joining us from the Air Force Institute of Technology. He will present this newly introduced FL aggregation technique, Fed ICP, aiming to offer versatile, uncertainty-aware solutions. Please welcome Gregory. Go ahead.
Great.
Sorry.
There we go. Good morning. I'm Greg. I'm a PhD student at the Air Force Institute of Technology under the advisement of Dr. Ga and Dr. Johnstone that are virtual. And I'd quickly like to thank Chung Shen with Flower for the continued collaboration and help with this. So why may the Air Force be interested in federated learning? Similar to a lot of the solutions or necessary applications in industry, we look at standard AI failing in dynamic, distributed, or secure environments, things that are rapidly changing, things that require privacy. And so lots of these applications, again, akin to industry, benefit when federated and decentralized, whether it's security, whether it's data size, lots of things like that. So specifically, I think I'd like to contend that within this broad, acceptance of AI within our lives, these scalar model predictions, whether it's a class label or a regressed value, it's no longer sufficient for us to use it for its full benefit. We want our models to be interpretable, we want to be able to use them, but we need to be aware of what's going on behind the scenes. And so within the conversation growing of responsible and ethical AI, we look at what other models, problems plague our models, and that's a lot of the uncertainty. So, how can we come around that? Well, let's quantify and then use that uncertainty surrounding our model predictions to be more aware instead of a one-depth analysis of our model. So I'd like to quickly walk you through inductive conformal prediction. That is our chosen uncertainty quantification technique. It has probabilistic backing and no data or model assumptions, so it's really applicable to us. And so we want to use a pre-trained model, no extra training time is necessary, and a calibration data set to produce these valid prediction intervals to then wrap around our future predictions. And so quickly, we take our learning data, or what, in a federated sense, the data that our client may have, and we split it into our training and calibration data. Now, that might be the one downside of inductive conformal prediction here is we may want to use the most of our data for training, but we require a larger calibration data set to make sure that we're appropriately calibrating our uncertainty. With that, we plug in our training model and our untrained model with our training data and produce our trained model. And then we look at how can we use our calibration data. Well, we can predict on our calibration data and then produce our set of nonconformity scores. These nonconformity scores are just about the predicted versus actual and what that means. So is it a distribution of the absolute residuals, the squared residuals, or some type of indication of the true class probability and how far off those predictions are. And now once we have that set, we can find phi, which is just our quantile. We use our alpha for our uncertainty. And we can find phi, which is just that quantile within our nonconformity scores. And that is now our calibrated uncertainty. So how do we apply that to our new data? Well, we can then predict on our test data, our new data that's coming in, and we can then wrap around that uncertainty quantification with a prediction interval. If it's the absolute residual for regression, it's plus or minus that phi. Or if we're looking at a classification, we may look at the probability of the associated classes and accept those that meet a certain threshold. So now, how do we integrate ICP into federated learning throughout training rather than just a post hoc wrapper? Well, we want to use our clients' scores, privatized, every communication round to guide that weighted model aggregation. So similar to any federated setup that we've seen, we have our initial model from our server that they broadcast to the clients. Well, the clients are then required to train their own models, take the steps necessary, and then they also are going to calibrate their own distribution of nonconformity scores with each of their own calibration data sets, along with their own fee. But this is federated learning, and privacy is a big word that we use. So it may not be in the client's best interest, given the data or the nature, to communicate that entire distribution of nonconformity scores, or let alone fee, and what it may be able to show if reverse engineered. So we have our clients each with their own privatizing masking function. We go ahead and mask our fee, and then we can communicate that back up. And just for this example, we say that fee, the uncertainty of client 3 is the lowest. So maybe that has the most confidence in its predictions. The smaller intervals, the smaller sets, still with the same probability associated to it. So now back at the server, we want to normalize these private ICP scores, and we want to turn them into weights. So we saw that client 3 had the lowest uncertainty, therefore it should have the highest weight. If we were doing Fed average, we may see an aggregation where the model may be directly in the middle, but given that the uncertainty within client 3 was the lowest, we see an aggregation skewing a little closer to client 3's model. Now, we can also perform client selection, given a low number of clients where, based off the uncertainty values, we elect to choose and follow one client, kind of passing it around each time as well, and that's a hyperparameter that can be tuned. Optionally, we can also add a momentum-informed step using the pseudo-gradient. This is a pseudo-gradient that's following aggregation and updates from uncertainty, not necessarily the loss itself. So performance is inherently tied to following uncertainty. So if we can use that momentum-informed step, perhaps there's more efficiency, more to learn from the uncertainty of our clients as we aggregate. And then we can begin the next round. So we see that conformal prediction has been used functionally within our training. Now, many data sets have been used on this, but the one I'd like to speak to is the Cogpilot data set, produced by a partnership between the Massachusetts Institute of Technology and the United States Air Force. The goal here is how do we use physiological signals within a simulator to then evaluate pilots. And so it's only about using physiological signals. This is a published data set if you guys would like to look at it. And so within that data set, we're looking at privatizing the physiological data. We want to decentralize because it may be too much. But then within this data set, only 12 samples per participant. So probably not enough for a client. So we then simulate a federated deployment of combining multiple participants to emulate a student pilot and the physiological collection from their training. And so quickly looking to the results, we have 100% participation given the low number of clients as well as samples. But we strongly see that variants of Fed ICP meet or outperform the performance of Fed average as well as centralized. So that means better performance and lower uncertainty at the same level of confidence. And then we repeat this for statistical testing. So concluding, we see at least one variant of Fed ICP equals or beats Fed average. And so it's really important that we can maintain the performance but also improve upon the uncertainty, lowering it. And then we see a faster convergence, but that fine-tuning momentum, similar to many adaptive optimizers, needs further work. And then continued research, we're looking at the optimal thresholds for convergence. How do we determine our client participation of a larger number of clients? How do we integrate heterogeneity into this? And then also we have work with MNIST and a Parkinson's telemonitoring data set. So I'm open to questions, and again, any future collaboration, I'll have a poster up as well as code to talk about too. Thank you.
All right, thanks a lot, Greg. Do we have any questions? All right, yeah.
Hey, and thank you very much for what you showed. One question, how do you decide what is the optimal size for the calibration part? How can you decide it?
Right, so currently we're doing a 70-30 split just as a baseline, but that's definitely a hyperparameter that can be explored given the size of the data allowed.
So you do it randomly right now?
Correct, yeah.
Okay, thank you.
All right. Do we have any other questions? All right.
Too much math, yeah.
Perfect. Well, thank you again. All right, so our next speaker is Flower AI Summit regular, and he will be talking about a subject that we probably all have had to deal with at some point, that heterogeneity. Please welcome Dennis Greenwald.
Thanks a lot. Thank you for inviting me and being able to give this talk. Actually, I will be speaking about a project that I've been presenting last year at the Flower Summit in form of a poster. And back then, we submitted it to a conference. It didn't get through, but we got a lot of nice feedback during the conference, incorporated all of it, and finally we could make it to submit it to NeurIPS, and it was accepted last year. So yeah, thanks for being able to talk about this again. So what is federated learning? We all know it. We train a collaborative, a common model on a decentralized data set, and this process comes with a lot of challenges, one of which is the challenge of statistical heterogeneity, which I will be focusing mostly in this talk. So as we know, for statistical heterogeneity, the problem is that when we have very different data distributions on the clients, the optimal models diverge quite a lot from each other, which means that also the averaged model will be far away from the global optimum as well as the local minimum. One way to tackle this is personalized FL, where besides just having a shared global model, we also train and train local models on each client for the local data sets. And this also comes with a challenge that is, which is that usually these personalized models will be very dependent on the global model. So if the global model quality is really bad, then the personalized models will also fail. So ideally, we would want to not have just a single global model, but instead incorporate more degrees of freedom either within a model or maybe a group of models, and allow clients with greater similarity train more similar models that are more aligned to each other. Before diving into this, let's quickly recap the topic of mode connectivity, which is the observation that was made by Garipov et al. In 2018, that if you have a set of randomly initialized neural networks and you all train them independently until convergence, there exist very simple paths in the parameter space that connect each of these models. And if you sample models along this path, each of these models will exhibit very low loss. And example paths could be a simple quadratic curve as the middle plot here, or piecewise linear functions. Interestingly, if you sample models along these paths, which you can see on the right, they all exhibit or they all result in different functions that are represented by these parameters, as shown by in the plot on the left. The works by Wartzman et al. Go a step further, and they try to enforce linear paths along different models. And they do so by, instead of just initializing a single parameter value, you instead initialize a whole simplex of values, and you train the simplex during training. So what you do during training is that for each mini batch that you sample, you also sample a point within the simplex and minimize the loss on it. This is very cheap because once you've sampled the model, you just compute the loss on it, compute backpropagation, and in the end apply the gradients to each of the endpoints scaled by the coefficients that you used to sample the point from the simplex in the first place. So of course you have to store 3 times the number of values, as in this case it's 3, it could be more or less, but computationally it's almost the same as just computing spare fed average, but it gives us this exactly these degrees of freedom that we want, because basically instead of just training a single model, we have a full space of models that we can train here. We use these ideas in our method that's called Floco. So in Floco, instead of training a single deterministic model, we train a simplex of models across the clients. First, until a certain communication round tau is reached, we train the simplex in a uniform manner. So each client receives the simplex, samples uniformly from it for each batch, and optimizes the simplex. Once the simplex has been trained for tau rounds, we now proceed and project the clients into the simplex in such a way that similar clients end up in similar regions, meaning with similar clients, meaning they have similar data distributions. We do so by taking their gradients as a proxy value and employ a novelly developed projection algorithm that does exactly that. It groups our clients in different subregions of the simplex. So from now on, from communication around tau on, each client will only sample from the specific region that it was assigned to. And we know that clients that were assigned in the same region also exhibit the same data distributions or similar data distributions in the end. What this results in is a trained simplex that performs uniformly well on the global data distribution, so the concatenation of all the local client distributions. And we have specialized regions. For example, client 1 that belongs to one group with a particular data distribution now really specializes in a certain region of the simplex, and client 2 in a different region. This plot is just, or this table is just to show that we have compared and evaluated our method with several different state-of-the-art personalized FL baselines on many different data sets, many different non-IID splits with pre-trained as well as models that we trained from scratch. To wrap up, our method Floco beats state-of-the-art PFL baselines on local and global test accuracy and expected calibration error up to 10%. It's applicable to both randomly initialized as well as pre-trained models. It has a very small computationally overhead as compared to Fed average. Of course, the storage overhead is still there since we have to store multiple versions of the model. And promising future directions are the cross-device FL setting, because so far we have just applied it to cross-silo. And we want to see how this approach with training a simplex also applies to a different field of research, which is the field of model merging. Thank you so much.
Thank you, Dennis. We already have a question.
Very interesting crossover of optimization and federated learning. Does your methodology account for a distributional shift of your clients, of how to potentially change over to a different area of the simplex or using a different model later on?
Yes, so in this work we didn't do that, but it's a follow-up thing that we are working on right now. Also, not only for clients that maybe change their distributions throughout their lifetime, but also new clients joining that lies somewhere in between clients that we haven't seen so far, but we think we could assign them the perfect spot in the simplex and adapt it accordingly. Yeah, great question.
All right, we also have a question here.
Thanks for the interesting talk. So I realized that you are grouping different clients, right?
Yeah.
So who does it? And also based on what information?
Yeah.
My point is, do they need to reveal some information to that party?
No. So that's a great question. The only information that we use from the clients are the pseudo gradients. So basically the difference of the model that the clients sent us back after training and before training. This difference we consider as a direction, right? It gives us a gradient direction, basically, pseudo gradient direction. And we use this information solely to project the clients and group them in similar regions.
Thanks. Just to clarify, so you're revealing a little bit more information that you would do in standard federated learning?
No, actually not, because in standard federated learning, we send a model, we receive the trained model, right? And we use just that information. Taking the difference gives us a direction of optimization that this client has undertaken, so it's the same as Fed average. Yeah.
All right. I think
there's
sorry. Oh, good, good. I can pass the mic directly, I think.
Yeah, great. Thanks for the talk, and congrats on getting published in NeurIPS. That's cool. So the question was related to the previous question. So how do you deal with the sort of cycle? I mean, I think at some point, if gradients are similar and you go to update them together, they become more similar. So it seems like there could be a collapsing effect.
Yeah, we haven't we haven't realized this collapsing effect because do I have training curves here somewhere? Maybe. Oops. Yeah, so here it seems like the effect is quite stable. So you can see a jump here. This is where we actually start a subregion assignment. Sorry for the small image here. Never mind. But in the end, we didn't notice any kind of collapse. I guess it could happen, But then what we also could do there, we didn't research this, but what we do is we sample for each client. We not only sample the single point that this client was projected on, but actually we parameterize an L1 ball around the client projected point that we use as a region to sample models from. And we could probably play with this radius more if we have such a collapsing effect. Yeah.
Cool. Thank you.
Yeah.
All right, that will be it for questions. Oh, all right, one last one.
Hey, thanks for the presentation. It was more out of curiosity, like when you present the idea, it reminds me of how the GPS localization works. I don't know if you got some inspiration from that, but I think it's a really nice comparison from the technologies.
Okay.
More of just a comment, not a question, actually.
Yeah, I haven't thought of this. This wasn't an inspiration, but interesting connection.
All right, thanks a lot.
Thank you.
All right, so our next speaker is Flower Lab's very own Yan Gao, and he will be talking about the FlowerTune LM leaderboard.
Okay. Yeah, so thanks, Charles. So hello, everyone. I'm Yan, a research scientist at Flower Labs. So today I'm going to talk about one of the active initiatives, FlowerTune and leaderboard. So before diving into that, so let's just briefly revisit what FlowerTune is. So FlowerTune is a tool that enables the efficient federated LM fine-tuning powered by Flower. So specifically, it integrates a band of techniques, including the Flower datasets, easy pre-trained LM adaptation, the PEFT, quantization, and Flower simulation engine. So all come together, FlowerTune allows the federated LM fine-tuning to be done with just a single GPU. So to use FlowerTune, we just need a single command, the Flower new, with the framework set to FlowerTune, where we have provided a ready-to-use template for you to get started with. So building on top of these usable tools and templates, we launched FlowerTune LM leaderboard end of last year, aiming to establish baselines across various domains and also promote the real-world reproducible federated LM fine-tuning. So in this leaderboard, we include 4 challenges: the general NLP, finance, medical, and coding. And all domains involve the private or sensitive data. Since launch, it has gained a strong momentum from the Flower community. So with the 18 members in the leaderboard Slack channel. So they have been quite active by asking questions, exchanging ideas, and also working together to push the boundaries of federated LM fine-tuning. So thanks to this community effort, we have tested with many types of base models, including like the Llama, Gamma, the DeepSeek, and so on. So let's see what we have achieved so far. Yeah, so this leaderboard got a huge gain across all the challenges if you compare to the original baseline in terms of both the evaluation performance and also the communication cost. So there's 2 highlights. So if you see the general NLP challenge, we have got 5.4 times increase in the accuracy. And for the finance challenge, we got around 100 reduction in the communication cost. So these are incredible results. And this also showcases the open source AI as its best. So now I'm thrilled to announce the top 3 performed submissions across the challenges which ranked by the average performance. So for general NLP task, the winners are the Gaussian Cognitive Computing Lab and the team from UNL. Thank you. And for the finance challenge, the winners are Massimo and Nat. Yeah. And for the medical challenge, the winners are Gaussian Cognitive Computing Lab and AI for EOSC team. And for the coding, finally the coding challenge, we have a sole winner of the top 3 performed submissions, which is Massimo. Yeah, thank you very much for all the contributors. And I'd like to also give a special recognition to our top contributing team, the Gaussian Cognitive Computing Lab, with the most number of top 3 submissions. And also a big shout out to our a top individual contributor, Massimo, who has made 10 plus submissions to the leaderboard. And in addition to the submissions to the existing challenge, we also welcome the new datasets and settings as an alternative contribution. So a big thank you to Daniel from the Barcelona Supercomputing Center for proposing the CARE QA as a new medical evaluation dataset. Yeah, so let's just give another round of applause to them and to everyone who participated in the leaderboard. Thank you. All right, so the leaderboard is ongoing and we are still open to more submissions, and we also keeping improving the leaderboard with more scenarios, more modalities, and more realistic FL settings. So please stay tuned. And last but not least, we are trying to wrap up this leaderboard as a NeurIPS dataset and benchmark submission. And still, we are trying to have a community effort to achieve this goal. So we will organizing special online events this afternoon, this Friday afternoon. And so if you are interested in, please just scan this code to join Flav Slack and jump to FlavTune LM leaderboard channel. We will share the meeting link there and keep you updated. Yeah, so I feel very lucky to be the part of this amazing community, and the initiatives like the FlavTune and leaderboards only be possible because of your passion and contributions. So looking forward to your participation, and let's work together to push the boundary of federated LM fine-tuning. Thank you.
Thank you, Jan. Very exciting. And congrats again to all the participants of the FlavTune LM leaderboard. Do we have any questions? Yes.
Just a question regarding if there's been many considerations of expanding FlavTune beyond the LLMs, maybe into vision language models or other domains.
Yeah, so currently it's just support pure test LLMs, but I think in the future we will support more modalities.
Thank you.
Thank you.
We have a question over there.
Hi, thank you for your introduction for FlavTune. I'm very excited about it because I'm working on PAFT with federated learning. So is there possible for FlavTune work with PAFT library in Hugging Face? Or because, you know, for PAFT with federated learning research, we need to construct our own PAFT modules. So
Yeah, thanks for your question. Yeah, exactly. So we have multiple templates, and the current template supports the path, as you mentioned, like LoRa. So it's from the Hugging Face library, but you can also switch to other library very easily. So yeah, thank you.
That's great. Thank you very much.
All right, I think we have time for one more question, if there are. Yeah.
Thank you. Very interesting presentation. It's a simple question, really. Is this still only able to work in a simulated environment? Because you mentioned in the first slide that this only requires one GPU, right? So it's all running in the same machine in a simulated federation. Or is it already actually able to run on separate nodes?
Yeah, so for the leaderboards, we're only doing the simulation, but you can easily to change to the real deployment by switching to the Flower deployment runtime. So nothing to change on the on coding. So it's easy to change if you want to do that. Yeah.
Great.
All right. So I think we're done with the first session. We'll now have a quick break. I think it's 35 or 40 minutes. Feel free to roam around and check out the different posters that we have. There are a bunch downstairs as well. Yeah. Hi and welcome everyone. This is William. I'm William from the Flower team, and we're doing this live stream to also connect as much as possible with the online community, because, as you know, Flower is growing, and there's. Here we go. Okay, yeah. Flower is growing, and so is our community. So we want to make this as engaging as possible for the online community, which is why we have opened up all of these live streams, and we are also talking to you immediately, trying to bring as many presentations and different sort of initiatives to the people that are not here physically. But as Nick was saying in the beginning of this summit, we are more than 2,000 people tuning into this summit. So that's great. That's already more than doubled than last year. And we are happy to bring all the speakers. There will be speakers coming into this room, talking with me, and we'll also swap so that you will see some other members from the Flower team as well. But if you have any questions, just feel free to drop them in the chat on YouTube, on X, or in our Slack. I'll try to get back to you as soon as possible, anyone from our team. But yeah, we are very happy that you are tuning in and that you are an engaged member of the Flower community. And looking forward to see what these 2 days will bring. And maybe if you have a specific presenter or speaker or presentation that you're really excited about, feel free to share it on social media, in our Slack, on LinkedIn, or whatever you feel comfortable doing. So yeah, with that, we open up this live stream, and we'll have some guests coming down soon, I think. Trying to also check the live chat as we go, but you will actually see me talk in 1 hour or something like that. So I'll be just quickly running out of this room from where I'm sitting right now to present a bit about the Flower community and what we do, together with all the developers, researchers, innovators that are out there working with the Flower framework. But yeah, lots more to come, basically. And it's quite funny sitting here. It feels like I'm a news anchor talking to you, but this is the first time. So I hope if there's anything, just drop it in the chat, drop it in Slack. So we'll see. Right now you can see the people at lower left. It's a break. We had some great speakers earlier. We also saw Jan from our team
talk about FlowerTune LLM, which is our initiative to try to drive AI development and fine-tuning in a decentralized fashion so that you can train your large language model across the world without having to centralize the data, which is great. And if you haven't tried it out, it's super easy to get started with. You can go to our GitHub or website and you can see what benchmarks people have already submitted in terms of medical, also finance, general natural language processing, and also large language models that help you with code. So if you're interested in this, you can drop questions in the chat and I'll forward them to Jan and try to answer them here, of course. So yeah. Then after that, later today, we will see the keynote speak from Daniel, our CEO. That will be really interesting. He will announce a couple of things that I think everyone online and here as well will really enjoy. We will talk, of course, more about the latest developments and where Flower is heading in the next coming year. But yeah, stay tuned. That's going live, I think, 2 p.m. UK time. And before that, there will be some other shorter presentations. And after that, in the afternoon, we will also talk about, let me see, yeah, there will be industry partners coming and talking about how they are using Flower, partnering with Flower, and so on. So, yeah. Let me see if there are any questions in the chat already. Let's see here. We have some people talking about peer-to-peer learning, which is a very interesting case in terms of AI and how you can communicate, use federated learning without a centralized server. Basically means that you have a lot of different, let's take the example of hospitals. You could, for example, using Flower, implement a sort of communication strategy where the hospitals are privately communicating AI updates together. All of this is possible. It just requires a bit of tweaking in the framework itself, but the team, we are trying to make Flower as modular as possible, so a plug-and-play framework that you can use to implement for any sort of industry use case, different types of research and things like that. So we try to bring you the most documentation as possible, so you can go to our website, which is flower.ai, and if you want to chat with us immediately, just go to our Slack, or here during the days, if you're on YouTube or X or whatever, then you can chat with us immediately throughout these 2 days here. So looking forward to all your questions. Let's see what else we have. Decentralized federated learning. Yes, we'll try to bring some people in from the community to talk a bit more about decentralized federated learning and peer-to-peer. That seems to be one of the more prominent use cases and research areas. That's of course very, it requires that one moves away from this conventional sense of federated AI that maybe doesn't apply in every use case. But yes, we will try to bring you someone who can talk more about it. But as I said before, we try to create Flower to be a framework which is, modular, where you can implement anything yourself. And we have documentation on how to create your own strategy, so it is possible. It might be that you need to go into the communication protocols, but as I said before, you can chat with us even after this summit in Slack, reach out to us, maybe our emails or LinkedIn, and we'll try to help you in the best way possible on how you can get started. Let's see what else we got. Yes. Yeah, there will be some announcements coming up soon. Let's see what else we have. Some new researcher looking to AI. There is still research. Yeah. In the work that we do, we come from an academic background, so we try to publish everything online, make it possible so that you can access it, open research. We go to conferences and present things that we do kind of alongside the rest of maintaining the framework and improving it. But yeah, we publish regularly and try to bring Flower to the research community, make sure that we stay up to date with the latest state-of-the-art research as well, try to bring that into the framework in as quick as possible so that you can enjoy the benefits of using the most advanced framework out there for any sort of industry use case that you might be working on. Is there any research or implementation integrating blockchain into Flower? We actually had a couple of people talk to us lately about federated learning and blockchain, and it is definitely possible. It's not my area of expertise, but we have people looking into this kind of domain and combination of different technologies. So you after this or throughout, like during these 2 days, if you have specific questions, feel free to drop them here, and I'll try to connect you with the right person within the Flower team, and we can see where it goes from there. So yeah, let's see what else. I'm checking the YouTube chat. It's been a lot of questions there. Yeah. Yeah, so we will have someone on site here, always being ready to talk to you from, even though there's a break right now. So if there are, breaks throughout the day, you'll be able to still ask questions. I'll be here. There will be some other people coming in from the Flower team, and we'll try to bring some people in as well so that we can talk about their use cases. And if you have anyone in particular that you would like to see down here at the seat next to me talk about something, you can just feel free to mention someone that you would really like to see talk a bit more about their research or application, or how they bring federated AI and federated learning into their daily work. So yeah, let's see what else we got. I see that we have Massimo in the YouTube chat as well. Massimo is one of the top contributors for the FlowerTune LLM that Jan from our team was just talking about. Massimo has implemented a bunch of cool large language models that are fine-tuned in a decentralized way, in a federated way, to work for industries like finance, medical, also general coding, I think. He's a great person to work with. He is very fast on implementing all of these sort of things, so you should definitely go and check out the leaderboard. He's one of the top performers there, alongside other research labs. So it's really cool to see the open source community coming together and actually fine-tune these sort of models to bring to the open source community that you can actually use, test, benchmark on data that we provide. And you can see that on our GitHub and website on how that actually, like how you can actually do this. But yeah, that's something that really seems to be taking off. So if you're interested in this, feel free to check it out. So yeah, we have a bunch of companies using Flower, and if you're interested in connecting with any one of these companies, you can always reach out to us on LinkedIn. I think there will be a lot of people from other organizations also available. Check out LinkedIn and X, maybe also flower.ai, I would say. Follow our website there, and you can see what other companies are using Flower for their daily work if you're interested. Exactly. Let's see. What else? Yeah, and tomorrow we will also have a bunch of different presentations, industry day, a lot of cool applications where people are using Flower in, automotive, medical, finance, telecom, all of these sort of things. We'll have some online presentations that also run throughout the day, but you'll be able to tune in to the presentations that are on site. Let's see. What else? I'm just switching between the sites here. Yeah. So you probably see that's in the video to my left, down to my left. It's Nick, our co-founder. He's talking to someone there. He will have he will hold great presentations later about. Let me see what it was. Yeah, it's more about foundation models and how people can use federated AI and Flower to, the impact that it actually has on different industries, different technologies, and what it can do for your business. But that's a talk that I'm really looking forward to. I think everyone here will definitely enjoy it. There is, of course, our CEO, Daniel is speaking. That's definitely, you should tune into that, 2 p.m. UK time. I don't know where you are in the world, but hopefully you can make it. And then Nick will speak a bit later. We'll also have Charles, who is talking about Flower Intelligence. Flower Intelligence is our latest release. We just released 2 weeks ago, I think, a preview of how you can use Flower Intelligence. You might have actually seen me post about it on social media if you follow me there on LinkedIn or X. But we showed how Flower Intelligence can help you run your large language model while in offline mode, basically. So in a video that I recorded recently, I was showing that, for example, ChatGPT doesn't work when you sit in a plane and you're not connected to the internet, while Flower Intelligence can do this. So you can just run it, like you can pull whatever model that you would like to use for your application and just run it in offline mode. And even if you need a bit of extra power to run it on your device, you can connect it with Flower Confidential Remote Compute, which is one of our recent launches as well. So you can apply for this, and we'll make sure to help you if you, for example, want to run a large language model on any sort of personal device, maybe your smartphone, maybe your laptop or whatever. But if you need some extra power, you can then use Flower Confidential Remote Compute to get this extra boost, you could call it. And this is done in an encrypted way, so any query, anything you ask to the AI will not be available to anyone else. It will definitely just help you power the AI that you actually want to run. Let's see, we got some questions here about decentralized federated learning. Yes, Lars, we'll definitely try to connect you. And there are some people here talking about peer-to-peer learning and decentralized federated learning. And if there's any, specific question, you can also reach out to my LinkedIn, X. My email is william@flower.ai. So you can also drop an email if there's something, more elaborate you want to talk about. But the best way to get in touch with us is, of course, the Slack channel. So feel free, if you haven't joined already, go to flower.ai, and then you'll find the link on how to sign up for Slack. There you can chat with us at all time. Our team is available most hours of the day. So if you have any questions, you can also ask them there. Let's see what else we got. I'm trying to implement decentralized FL with multiple aggregators. Yes. That's a good question. That's definitely something that I will need to bring up with the people here today. We'll try to bring people down, see if we can talk a bit more about it. It is possible to do it theoretically, and if you just tuned in, Flower is a modular framework that you can use to plug and play, and you can implement decentralized or peer-to-peer federated learning. It is not the conventional way of doing federated AI and federated learning, but you can still do it. It might require some tweaking in the communication protocol, but if this is something that the community really wants, we will try to allocate as much resources as possible in the coming period, weeks, months, to make sure that we can bring this sort of baseline to you so that you can use it in the easiest way possible, basically. I'm curious about the differences between existing local LLM execution methods, such as Ollama and Flower Intelligence. Differences between local so you can of course run any sort of machine learning model or any large language model on your devices. Then if with Flower Intelligence, if you need extra power to run inference, and which means that you kind of want the model to give you any sort of response to what you are asking it, then you would depending on the size of the model, you might require some extra power, and that's what Flower confidential remote compute can do for you. So everything, like any input you send to the AI, would stay secure and private and so on. But then local AI or edge AI is of course a great concept. Basically means that you want to execute AI without having to send data to any sort of remote server, where you train the AI and you run inference and you make the AI respond to your questions and things like that. In the traditional way, in centralized learning, you would have to send all of your questions to it and then have the AI think about it and respond, and this server could be located anywhere in the world. Local would mean that it's only processing the data, the inputs, the text on your device, which could be your computer, your smartphone, or whatever. It's not sure if that large language model could actually fit and run on your edge device. It's possible. And also, if you want to fine-tune it, and if you want to, for example, train it further, you would need to communicate with other sort of devices that might be connected in one way or another, but then you don't want to send the data that you have collected on your smartphone to this central server. You might just want to send the updates from the new improved model that you have, let's say, on your smartphone. So we could take the case of healthcare, medicine. If you were to train an AI local on the data that one has collected on the hospital side, could be cancer images, let's say, and you do this only locally, you won't be able to access the knowledge from that much data compared to if you were in a federation of, let's say, 20 different hospitals. But at the same time, you cannot share patient records that easily, which means that you would need to find a way to communicate without, inferring any sort of patient data or patient records, and that's what federated AI does, and what Flower Intelligence can also help you with. But yeah, we can talk more about this over the next day or two. It would be interesting to learn more about Pramit's publication, particularly in interested learning and methods he used to exchange only certain layers. Yeah, that's a very interesting piece of research. We have this baseline and strategy up on our GitHub, which is called, it's an implementation of a research paper called Federated Learning Using Personalization Layers. And the basic of it would be to split, for example, a neural network that can help you do computer vision, image recognition, any sort of use case like that, or text-based, whatever you have. Imagine that you have the neural network and you split it in two parts. There would be one base layer and one head layer, or one base part and one head part, and they consist out of multiple layers. And let's say you were to transfer only the base of it, which could be the basic knowledge of something, but not the specialized details that are required for personalization. That is actually implemented in Flower. You can use it already. So what would happen is that you would only transfer the base layers to, or the updates of the base layers to the server, and keep some knowledge localized in these personalization layers. So this strategy is called FedPer, which means federated learning using personalization layers, and it's actually been shown to be quite effective in some healthcare settings. It can also be used for automotive, finance, whatever. But it's a very interesting piece of research. But yeah, it is available in Flower, so you can check it out. And if you really want to talk more about it, feel free to reach out to me. I was working on this before, so I'm happy to talk more about it if that's interesting to you. I'm also really looking forward to the open source release of Photon. Yeah, that's great. I think you will hear our co-founder Nick talk a bit more about it later. He has been working on this in the academic world in Cambridge, and yeah, he will definitely share some insights on Photon as well. And if you're interested in more strategies and baselines that you can use to, aggregate all these updates that are sent back and forth in federated learning, you can go to flower.ai or our baseline repository on GitHub. Our repository, collection of strategies that you can use, is the largest in the world, so you can see all of them there. This is for personalization, for security reasons, for all of this. There are many more that you can use for video processing, self-supervised learning, and so on. So yeah, definitely go and check it out. That's really cool. We also have examples up on our GitHub if you want to use it using PyTorch, TensorFlow, sklearn, XGBoost. I like XGBoost for tabular and structured data. So if you're a person who is working with tabular data or tree-based models in general, I find that area of research very interesting. So feel free to connect with me there as well. Let's see what else. Thanks for the answer. I would certainly connect, as I'm actively working on privacy-preserving decentralized FL. Yes, definitely. You should. I'll try to bring someone in here that we can talk a bit more about decentralized FL. That would be very interesting to have someone come in and talk a bit more about how they are using Flower for implementing this. As I said before, it's a modular framework that you can use, and it requires tweaking here and there, but we try to bring as much documentation as possible to you out there. So if there's anything missing, you can of course raise a GitHub issue on this. So you can either you implement it yourself, you do the changes, and submit a pull request on our GitHub. We will review it, and if it's good enough, if it follows all the guidelines, we'll just merge it and you'll be an active contributor to the framework. And we'd love to see more people coming and joining this open source movement and contributing to the framework. So the code is out there for you to see, and you can implement what you want, basically. See what else we got here. Thanks for the answer, but I am interested in this too. Yes. Well, as I said, decentralized federated learning seems to be it today. We'll try to bring some people in, so stay tuned. And stay tuned for all of the different presentations that are coming up. There will be some really interesting ones, including myself, but I want to promote all the other ones, basically, that come from the community, that are using Flower and actively working on state-of-the-art research and how we can bring this sort of decentralized AI, privacy-preserving yet collaborative effort to as many industries and use cases as possible. I'm sure you will see more of this throughout the days. Just need to adjust. It's more difficult than you would think to talk straight like this, so I wish someone would come in and talk with me right now. But yeah, what else? We have yeah, Flower Intelligence is up now. So if you haven't, go and check it out. That's our latest release out of many. There will be more to come, of course. Thanks for the updates, sharing. I'm a researcher in energy community. I would like to extend our work towards the privacy-preserved FL models, since households don't want to lose their data. Also very interesting use case. Definitely a good application area for where federated AI would be suitable concept. And we have the Flower framework up there. It's open source. We try to provide you with as much documentation as possible to, for you to implement this. But if there's something missing, feel free to reach out to us, and we're happy to, try to implement any sort of changes. I see that we might have our first speaker coming in. Okay, very interesting. Let me scooch over quickly. See who comes. It's a surprise. Sorry? You want to jump? No, it's fine. We can. Do you want to chat?
Yeah, jump on.
Okay, yeah, sure. Okay, team, I'll jump out for a minute. This is Shongshen. This is my colleague, and he is bringing another speaker here. Will be very interesting to see. So yeah, stay tuned.
All right. Hopefully this is clear. This is good. Excellent. Hello, test. Yeah, cool. All right. Hey, everyone. Nice to meet you. My name is Chong Shen, research engineer at Flower Labs. Just sort of hijacking the live stream from William over here. I have a pretty cool guest. Her name is Nicoletta. Oops, apologies. Come on, Nicoletta. A microphone over here. I'm just going to pass over. There you go. This is Nicoletta. She's based in Amsterdam. Am I correct? And she's here. I just wanted to grab you because you came up to me and started talking something pretty cool. There was AI for cosmetics, which is your startup. Yeah, I would just love to hear from you, like a couple of words about, how you told me a very interesting story about how you pivoted from your previous career and then moved into the federated learning space, and how you have a bit of funding to help you with the startup and work with AI for cosmetics. So I'll just could you just talk me through just briefly about your story?
Thank you. Hello, everyone. It's very nice to be back here. It's my second time. And I truly enjoy this community that you are building. Besides the most friendly framework that someone like me who has rather unconventional career path that can use and can explore federated learning in my field, which is the chemical industry. And with AI for cosmetics, one of our early case study is specifically looking at the application of federated analytics and learning using Flower for the safety assessment of chemicals, developing models for prediction of various types of toxicity, but also looking at more like also in the space of generative AI, for example, how we can identify promising candidates while optimizing for safety at the same time. Why AI for cosmetics is because we think, and our research so far showed that indeed there is a need for more data and evidence to help those people who make decisions about a chemical ingredient, either to be used in a formulation or not, and what kind of application, what kind of dose. We don't have so much information. The information is spread. We have raw materials companies, we have cosmetic companies, and then we have various sizes of companies. And not everyone affords to have huge data sets, so that information can help them to make as early as possible decisions about the selection of ingredients, but also like in terms of the final product development to put the product on the market.
Yeah.
And we were also fortunate enough to obtain a local governmental fund in Amsterdam. And in other words, we got the support from the governmental body in the north of Holland to further explore this properly and evaluate how this can be done in the real world. And that would be briefly.
Excellent. No, that's a super nice summary of your work and a lot of a nice overview of all the projects that you're involved in. I'm just curious, like, could you share a little bit with the community, in terms of how complex was it to get the data sets for you to start building this kind of FL projects with Flower, and what you had to do? Was there any interesting things that you have to process or do with the data to get it to work?
That's an excellent question, because in this space, even though the data sets aren't large, it's also how we can encode chemical information and biological information. And for example, for one ingredient, we can have lots of types of data. And with federated learning, I see how various companies might have conducted various types of tests, even for one single chemical ingredient. And I think that brings also to the topic we discussed previously about uncertainty quantification. I think that's also like an excellent case study here, because again, companies might have certain preferences for certain types of chemicals, also like in terms of active molecules, maybe some more preservatives or any types of other similar compounds. And again, that diversity can be brought together through federated learning.
Wow. Yeah, this is really cool. Has there been quite a lot of interest from companies about what you're doing as well, and what's the reception so far?
There is the little research we had so far. It does show a positive signal. Like companies do want to at least understand what federated learning can do for them. Again, for example, when we design specifically case studies where we can show how Flower can be used in practice. And going back to the topic of data, for example, we compiled the largest open source data set on skin sensitization, which is one adverse event. It is meant to be like when someone can get a skin reaction after repeated use of a product, that type of toxicity. So we simulated a case study there where we show that if there are two clients with different distributions of chemicals, then the global federated model provides a balanced performance. In other words, it combines the information on both types of data sets. There's, again, in our field, there is also the term of applicability domain, which by that is meant, again, how diverse and what kind of for what kind of chemicals a model can be used. Yeah. And if one specific company focuses mostly like on fragrance type of molecules, and another one focuses on a variety of chemicals, then with a global federated model, we are also able to provide better predictions for a completely new molecule.
That's really nice. All right. That's a super deep dive into what you're doing. Actually, it's really, really cool to hear that. And I really wish you all the best in the startup.
Thank you, Chang, very much. For this.
And if they want to look out for you, they just look out for AI for cosmetics.
Indeed, we have a LinkedIn page, AI for Cosmetics. Otherwise, they can also approach me directly.
All right, perfect. Okay, thank you very much.
Thank you too.
Enjoy the rest of the summit.
Thank you. I will do.
Cool. All right. Thanks. I got it. Yeah. So that's Nicoletta, and I think we'll hand it back over to William, who will take over from the live stream once more. All right.
There we go. Okay. Hang on. Let me just plug in. So I think we are about to start the next presentations. So if you liked what Zhongshen and the others were talking about, feel free to drop a name of a speaker that you would like to see here. And I've been interacting with the chat now for a while, and I see there's a lot of people asking about decentralized and peer-to-peer federated learning. We'll do our best to talk more about it. But now I think we're soon going over to the other presentations. So feel free to continue commenting and asking questions in the chat. I'll do my best to respond to them. Stay tuned for the next break, then we'll be back here as well. Is there a countdown?
It's probably coming soon. Okay, 1 minute left. Yeah, that's good. Yeah, so as I said, if you want to see a specific speaker coming down, chatting with us, drop the name here. We'll bring them over, and even if it is someone who talks, even if it is someone from the Flower team, feel free to drop their name here. We'll bring them in. But yeah, looking forward to talk a bit more. Now I need to drink something, but I'll stay, in the chats, answering your questions, trying to. If you have anything you want to discuss as well, feel free to, put some thoughts out there. It's very interesting for us to see what you are interested in. So yeah, just drop it in the chat, and we'll definitely look out for it. Don't forget, there will be many more speakers coming up that have really cool presentations. So stay tuned for more, and see you soon. See you soon again.
Yeah.
So I think we're going to continue. I'll still give a bit of time for people to come and settle in. Yeah, and then we can start off the second session of the day. All right. So yeah, let's kick it off. So for this second session, let's welcome Nicolas Ponticos to the stage, professor at UCL and co-founder of I2Gene.
Thank you. Cool. Okay. I'd like to welcome as well William Wolf, who's a postdoc working with me, and he will be sharing the talks. I'll be covering the first part, and he'll be talking on the second part. William, maybe you want to stand here so you can jump in. Great. Okay. So thanks a lot for inviting us. Very excited to be part of this really cool conference. So we are working on I2Gene. I'll explain a bit what it's all about. So we work with genetic eye diseases, and these are images here you can see of retinas of people who are affected by these genetic eye diseases. What's important to know is that they are a leading cause of blindness in young people all around the world, and there's a lot of different types of the diseases. What you've got, these images below, you have the genes which are affected in each of these people. So there's over 300 genes that can be affected in these individuals, and they cause irreversible sight loss, and it varies depending on the gene. And it's really important to identify the gene that is causing this person's disease, so that's called a genetic diagnosis. Why is it important? Because gene therapy is coming online, and we have a lot of these gene therapies now that are being developed. And what's common to all of them, though, is that you need to treat the patients early, so you need to identify the patients really early. However, genetic testing is not available all over the world yet. We only have, we're looking at the tip of the iceberg here in the countries where we can do genetic testing. There's a huge amount of patients all around the world that are not having access to genetic testing. So how have we solved this? We are using AI from retinal images to try and identify what is the disease that is affecting these patients. So it's a simple sort of convolutional neural network approach. From retinal images, identify the gene. And we've got a accuracy of detection of 93% to see whether it's a genetic eye disease, and then we can identify the specific type of gene to an accuracy of 86%. We've got a nice local data set that we've been using to do this, but we really need to go global, and we want to be able to run this and train on data from all over the world. We've got a large network of different sites all over the world that we would like to work with. However, as you probably know, information governance is a big barrier to being able to centralize data, and rightfully so, because privacy is a big concern in healthcare. So we really must turn to a federated approach. So I'm going to let maybe William now talk about what we've been doing with Flower to address this.
Thank you. Hello, everyone. Yes, so we'd like to talk about a project we've been doing, which was part of the UCL CDI, Centre for Digital Innovation Accelerator Program. And this is about taking some of the research that's been going on at UCL and sort of speeding up and maybe even helping to find sort of commercialization. So as part of this, we received help from AWS and as well some support from Flower. And this was really for us sort of a pilot project about sort of trying to sort of kickstart our federated learning capabilities. And what this really forced us to think about is it's one thing to be able to talk about all the technical aspects of federated learning, but it's another thing to be able to get a system actually running in a hospital, in sort of like a research setting, to be able to do federated learning for that. And there's a number of particular challenges. Number one is many of our collaborators who we'd like to work with and get federated learning set up with are clinicians, and clinicians do not tend to have extensive sort of computer science expertise. They're often very capable, but you can't just ask them to go and set up complicated environments and so on. And another issue is, even if they can, IT systems in hospitals. Obviously, we've been hearing a lot in the UK about digital attacks. Obviously, there's very real concerns about data privacy and security. So IT are very keen not to let stuff run and things. So while it is in theory possible, there's a lot of bureaucracy involved, a lot of overhead, and also just thinking about, even just from a practical perspective, every hospital system is different. And finally, as well, sort of building on that idea is you need compute. And getting compute into a hospital environment is difficult. And even if you can, do you want to be spending potentially thousands of pounds for every single site you want to collaborate with? Or getting a GPT machine running. So going to this, we sort of had a sort of list of requirements we really wanted to think about. We wanted to make whatever system we came up with as simple to set up as possible, so potentially it can be sort of like a one-click solution. We wanted to make something that was minimally reliant on existing IT resources that could ideally be operated sort of parallel to the hospital IT system. And I think sort of finally that last point sort of really drove a lot of our solution, is thinking about how can we actually get compute available to the sort of end nodes of the clients. So what we could have really turned to for this was thinking about can we leverage cloud infrastructure. And now I know somebody might be thinking that this sort of all seems to defeat the point of having the sort of privacy aspect. What we can find we can do in many instances is enable hospitals to have secure cloud environments which they control and move data there. And that we felt was really the key, so sort of enable us to then standardize platforms for our partner sites. Now we're still sort of thinking about one cases where that might not be possible. It still may be possible to do this based on local data, but that's the thing. But one thing sort of thinking about then even as well, as I was saying, that compute problem is still a very big issue. And if we're using cloud resources, we don't want to be running GPU servers for every single of our external sites, because it's just going to get very, very expensive. So what we kind of did is we decided for our sort of client node, we're taking a very standard sort of Flower client node here, but we're basically offloading the compute elements and also to some extent the data management to a separate process. And for that, what we're using is Nextflow. This is something that's been used a lot in sort of genetics pipelines, and we found that we can get it set up very nicely to run deep learning workloads. And that's nice because you can then basically, you can either run that locally, or you can ship that off to something like AWS Batch, and that can then get run by on-demand compute instance. So the way this works is basically we take our Flower client, and all that's doing is basically taking the incoming weights from the incoming parameters, saving them, working out how to building up a call to the Nextflow script, and then the Nextflow script will go off, run, do the job. It's got access to the data. That might be on an S3 bucket or so on. And then that will come back and then save another set of train weights, which the client can then read off its local disk and then send back up to the Superlink and so on, sort of to do the standard sort of federated learning. And so, you know, this is nice in many ways. So the client node, pretty much all it needs to be able to do is take some incoming data, save it to disk, and then read it back and send it off. Minimal overhead, minimal requirements. And sort of this encapsulation of different resources is something we think could be sort of, is worth exploring. So we sort of, maybe I'll go back a couple of slides, we sort of did a sort of demo of this. We've taken our, we sort of did a simulation of how this would work. We've built sort of independent AWS, I believe they're VPCs for the individual partner sites we were working with, used some temporary data, and basically use that to do a basic federated approach. So we don't do anything special. We haven't been doing anything special at the moment. That's something we really want to sort of explore, and hopefully something we'll learn a lot more about here. But so we sort of see that just demonstrating that if we're only reliant on local data, then we're very restricted. But as more data we can get, especially in something like this where data is very scarce, that can really sort of accelerate our really help to improve our model. So just to summarise, we're going to continue working on this. Hopefully the idea is that this will then sort of become a key part of our process rather than just training on the data we have already. We're going to try and move more to a sort of federated first approach. We're very interested to learn more about what we can do to improve our process, particularly as we have stuff like big data imbalances. We also want to understand more about security, not just from a sort of technical perspective, but also like just how can we stop ourselves from being able to run arbitrary code on individual clients and so on, and finally sort of start properly deploying this. So just want to say a very quick thank you. So this was very much a collaborative project. So Alan and Ismail in particular worked quite a lot on this. But thank you as well very much to the CDI team at UCL and also our support at Flower really helped to get this off the ground.
Thank you very much, William and Nicholas. Do we have any questions? I think, yeah, over there.
Thank you for the great case and also for the clinical relevance of your case. I have a question about the incentives for the data partners for the hospitals to join your project. Do you mind to explain a little bit, what brings them to join, collaborate, and kind of the shared incentive or convincing factors to join you?
Yeah, so there's several incentives. Firstly, obviously, patient care, so they're able to use this algorithm for their patients. They don't have a lot of expertise, a lot of these centers in these genetic eye diseases, so we are able to bring an expert system to them. Then there's an incentive, obviously, from a research perspective. They want to contribute to this on a research basis. And then I think from also a commercial point of view, their data is also used in training this algorithm, and they can, this is something we're discussing actually, is potentially how is this then reflected in any sort of commercial activity, for example, revenue share and so on. So that's an interesting one. But just being able to use it and be part of the project, because these are conditions which are very neglected, is really important to them to deliver better care for the patients. So I would say that would be the first incentive for a lot of them.
So I think we have. We have an online question.
We've got a question from online. The question is to the ITGene folks. They want to know just how much better could this get if you're successful? Do you want to get it?
Yeah, I think obviously. So at the moment, we're sort of seeing that based on the data we've got from Moorfields, is about 3,000 patients, maybe a little bit more. At the moment, with the stuff we've got from external sites is still quite low, but there are huge numbers of patients worldwide. I remember I was at Arvo a few years ago. Sorry, no, just last year actually. Sorry? No. Sorry, yes, Arvo, the big American Eye Conference, and this was I had a clinician from China who was very interested, and I was just speaking to her, and I was asking her, how many patients have you got? And she was saying about 3,000-4,000, and that's from one hospital in China. So there's places in, there's patients in India. Now, obviously, they may not have the genetic, they may not effectively have the labels we need, but there's lots of stuff we can think about. And so we think this can get a lot better. But also as well, I think we're thinking about in terms of how we can actually, as well as improving our algorithm, actually get it into, potentially into the hands of researchers without sort of, one of the things we sort of thinking about, obviously very conscious of the importance of open source, but as well protecting our own IP in case we want to commercialize it and so on. So federated learning is, as well as coming a way of getting data for us training, it's also a way of us being able to run models on external data without having to either transmit any data or I know we were transmitting model weights, but it's a potentially much easier way of doing that than having to run it independently.
Yeah, I think we're out of time. But yeah, just specifically, I think we can get an increase of maybe 10%. I think because we've got our data set is big, but there's huge data sets that we're not tapping into. So yeah.
Thanks a lot. Yeah, sorry for the remaining questions, but feel free to catch up later. All right, so our next speaker is Gill from the University of Virginia Tech, and he will be talking about a new framework, TraceFL, for debugging in federated learning. So can you just test the audio just to see if everything's set up properly?
Yeah. Hello, everyone.
Yeah, perfect.
Yeah, perfect.
I'll let you the floor.
Okay.
Go ahead.
Thank you. Hello, everyone. I am Gill. I am fourth-year PhD student at Virginia Tech. And today I will present TraceFL interpretability-driven debugging in federated learning via neuron provenance. So suppose we have 6 hospitals and they are training different models based on their data. And as we know, in federated learning, we have different data distributions. Now, let's suppose we aggregate this model. Let's say we are using Fed average, and on the central server, if this model makes a prediction, so the key question is which client is basically responsible for this prediction. So as we know, this a global model is not directly trained on any data. And no preferred solution is available. So there are a few challenges which we need to address while enabling debugging and interpretability in federated learning. So the first challenge is we do not have access to direct client data. For instance, in this case, we cannot directly, if we are sitting at the central server, we cannot go and inspect the hospital's data. The second one is the global model is not trained directly on any data. So the third one is all the clients not participate in every federated learning round. And as we know, the clients have different data distributions. So this is another challenge. And the existing ML interpretability techniques are inadequate in federated learning because they focus on different set of problems. For instance, if they try to understand which parts of the input are more important for the classification. But in this case, for instance, we want to know which clients are mainly responsible for the given prediction. And based on there was a survey from Google where they have mentioned that it's an open challenge in federated learning debugging and interpretability, basically. So we propose this TraceFL. It's a neuron provenance technique which basically tracks the contribution of each client to the activated neuron in a neural network. It consists of mainly 4 steps. I will go briefly on these steps, but you can read the paper or I can take questions if something is unclear later. So the first step is it's identify the activated neurons in the global model. And the second step is it use gradient to find the most important neurons among those activated neurons. And then in the third step, it's map the client's contribution to each activated neuron of the global model. And the last step is to basically rank the clients based on their total contribution. In the first step, for instance, let's say if the neural network is using ReLU activation function, and if the output is greater than 0, it means the neuron is activated or it's taking part in the prediction. So what we do, we do not track the contribution of non-activated neurons. We only track the contributions in the activated neurons, which in this case are the green one. So by just focusing on the relevant neurons, we can avoid irrelevant attributions. Basically, we can minimize the noise. And in the second step, we compute the gradient of each activated neuron. And the key insight is basically if we compute the gradients, neurons with a small or zero gradients have minimal impact on the output of the global model. And in the third step, we map the client contributions in activated neuron back to the global model. So, for instance, as we know, this is the global neuron, and it's made up of the corresponding weights of the each hospital weights or the client weights. And to summarize, there is a derivation in the paper, but I just want to skip it in the interest of time. That if we this equation basically tells us precise contribution of each client in this activated neuron. And in the final steps, we for each hospital, we compute the total contributions in all these activated neurons based on the step 3. And finally, we take we normalize the attributions, and we take the basically softmax on this for each hospital based on their contributions. So this way, these steps, we aggregate all the contribution to each activated neurons to assign a responsibility score. And finally, we rank basically the from highest to lowest client based on their contribution to the given prediction. And in our evaluations, we used image classification datasets, medical imaging datasets, and text classification datasets. We use CNN transformers. We scaled up the clients up to 1,000. We sampled 10 to 50 clients per round. We used mainly Dirichlet data distribution, and we also ranges it from 0.1 to 1 to cover different data distributions. And in 12 different FL configuration, 400 FL rounds, we found that TraceFL's accuracy of localizing the responsible client for the given prediction is roughly around 99%. And we also tested it with differential privacy, and we have seen that it's also works the differential privacy, because in differential privacy we just add the noise to the weights of the models, and since the TraceFL works at the neuron level, so we found that it's equally effective at with the differential privacy. And to summarize, basically, it's the first interpretability technique in for data learning, which can give the precise contribution of clients for the given prediction, and it's compatible with any Hugging Face model, classification model, and also any flower data sets. And it's so. And the complete artifact is available in Flower FL. In Flower, we implemented in Flower FL, but we are currently in the process of making its baseline. So, and it's also received all these functional, reusable, and available badges for this paper. And thank you, everyone. If you have any questions, please ask. I cannot hear. I cannot hear.
All right. If you have questions, just let me know. All right. Do we have anything from online?
Just one basic question is along the lines of an online person asked, is this easy to generalize to different types of hardware? And and the second follow-up question would be, is there any type of hardware support you wish you had access to?
If I understand it correctly, is there any hardware-related constraint for TraceFL? Is that correct?
Yeah, I think so. Yeah.
Yeah, so we don't see any hardware constraint. It's even this artifact is completely available on Colab, so you can just run it on Colab, and we are running like basically training GPT-2 model on the Colab, and we are using this Flower FL framework for the training and to find the attribution of each client. So we are using TraceFL. So I don't see any hardware constraint. So yeah, there is no issue on that.
All right, thank you very much. We have another question.
I was wondering, can we track the contribution of different clients from the data distribution of each client? If we have access to the data distribution across different clients, can we track the contribution?
So that is a very good question. So if I go over here, for instance, let's say, let me go over here. So for instance, so in this case, for instance, I think this hospital 2, 3, and 4 are responsible for cancer related to cancer labels. Even we have access to these data distributions. When the global model makes this prediction, we cannot be sure whether it's hospital 2, hospital 3, or hospital 4. So this can still be a problem if we can have even access to their data distributions, because we want to see, for instance, is hospital 2 is mainly responsible, or hospital 3 is responsible, or even hospital 4 is responsible. So there still can be this problem even if we have access to precise data distribution across clients.
To the labels.
Does
How
it,
do you? Sorry.
Yeah. So, does it? Can you please go?
Yeah, I was just wondering. Do you have labels? How do you know how much is the actual contribution of different hospitals?
Yes. So because we have, since we are distributing the data, so we established that ground truth so that we know that, okay, these clients will be responsible for this prediction. So we have access to that labels, but in real world, when we deploy the system, we may not be able to access those label data distributions. But for instance, for our evaluation purpose, we need a ground truth to compute those accuracy numbers. So we have access to labels because we were distributing this data. But for the real deployment, we will not need those labels. It's just for the purpose of this evaluation.
Thank you so much.
You're welcome.
All right, so I think that's it. Thank you so much. And yeah,
thank you.
Thanks again.
Thank you.
All right, so our next speaker is coming from the University of Warwick, and she will be presenting, wait, is that long enough? All right, perfect. Novel approach to eliminate malicious FL client. So yeah, please welcome Ashley.
Thank you, everyone. Short people problems. Sorry. Okay. Hello, everyone. My name is Ashley, and I'm a PhD student from the University of Warwick. Today, I'm sharing my project, which utilizes backdoor attack models in federated learning. So we all know that federated learning is a privacy-preserving technique where we know that where these clients just share like their model updates instead of their raw data. But then because of this lack of transparency, we know that federated learning is still very vulnerable to malicious clients, for example, backdoor attackers. So backdoor attack is a stealthy but common attack in federated learning, where these attackers work together to train the global model so that this global model misclassifies on certain instances. Okay, in particular, each of the attacker will train and poison their own local model so that the aggregated global model is also contaminated. It's sad because I made a nice graphics to it. Anyways, I'll show you guys later. But okay, so in order to poison the local models, the attackers will then poison their own training data. Specifically, they will pick a proportion of data instance and insert. Nice. Okay, I'll show you guys. this little underwhelming graphics that I was going to show you guys. So yeah, so this is the overview of how a backdoor attack is like. So where like poison attackers will be immersed as like a malicious attackers in the network as well. So in order to poison the local model, I mentioned that they're poisoning the data. So they will pick a proportion of data instance and insert a trigger into it. So because now we're taking a look at image classification, so the data will be the images. And then the trigger could be like a white pixel that put in the bottom right corner of each of the images. Then these attackers will select a target label to relabel these triggered instances. So for example, this time our target label is number 9. So any images with these triggers will then be relabeled to number 9. So an example case for backdoor attackers is like a federated learning-based facial recognition system. These attackers aim to poison the system so that any person with a specific feature is classified as an authorized user. So consider this system. The model can classify any of the people in one of these labels, such as not authorized with no access, standard staff with half access, and VIP with all access. So the poison global model will actually classify a originally non-authorized person to be a VIP just because they're wearing a pair of sunglasses. So now a pair of sunglasses is their trigger. Now that we know that all the risk has been brought from the backdoor attacks, we need an algorithm to detect these malicious clients before they actually make a negative impact to our model. So because we're only having the model updates from the server side, so we first observed the last fully connected layer weight on the server side because this is directly contributing to how the prediction is caused. So if we look at the last fully connected layer weights, we have plotted a heat map here for each of the row is representing on like the client's parameters, and each of the column is the class for each of the data set. Because now here we're taking a look at MNIST, so there are 10 classes from digit 0 to digit 9. And reminded that our target label is 9, we can see a simple yet impactful observation. We can see that the values of the target label for backdoor attackers are way higher than that for the benign clients, for both IID and non-IID case as well. So based on this observation, we introduced an algorithm called FACT-ASSESS, where we effectively detect backdoor attackers and their objectives, which is their target label, effectively in the network. And we further also propose to dynamically aggregate these backdoor attackers with the benign clients inside the network, which shows a unique perspective of how we are handling these attackers instead of just eliminating them from the network. So using this observation, we have split into a row-wise observation and a column-wise observation. So because each row represents a client, we then divide these rows into 2 groups according to the pattern. So we can see from the image, we have group 1 and group 2. And then we take a look at the column-wise observation because now we have 2 groups now. So the column that forms the biggest difference between the 2 clusters will be the target label. So considering the target label column, the cluster that has the highest value will then represent the backdoor attackers. So after we detect these malicious clients, we then propose to extract some clean model parameters from that, because we know that these models will maintain their high performance on the non-triggered instances while targeting on poisoning these triggered instances. That's why we can omit any of the parameters in the last fully connected parameters that is related to the target labels and then aggregate them with the benign models respectively. So from our experimental results, we can see that while our model is not poisoned because it has caused a very low global backdoor accuracy to our benchmark, we can see that we have a very similar or even higher global main task accuracy to our benchmark, which is FA, which is a FLAIR, which is existing work that eliminates all the attackers. This shows the effectiveness of eliminating This shows the effectiveness of also contributing our backdoor attackers to the learning will also help with the model learning without actually poisoning the models. So thanks to Flower, I'm able to implement my algorithm very easily with just a few lines. So in general, I have built my federated learning system using the Flower framework. Then I use a customized client's instances, which is you can see from the images. On the left-hand side, it is a generic Flower client, and then on the right-hand side is my constructed client instance with a few more attributes, such as whether they're malicious or not, their target label, and the poisoning rate, etc. etc. And then I'll also change the training function as well so that they actually poison the data before that. And then I also implemented a customized aggregation strategy, which is a weighted aggregation scheme based on whether it is an attacker or a benign client. Thank you very much.
Thanks a lot. Do we have any questions in the room? Yes. Oh. Perfect.
Hi, thanks for the nice talk. So your approach basically classifies this benign and malicious clients based on their updates, right?
Yeah.
So the one who is making this decision are seeing the updates in the clear to make such a decision.
The server side.
Yeah, on the server side. Mm-hmm. So did you consider extending this approach to the case of secure aggregation where each individual models are not given to the aggregator in the clear?
So this algorithm is actually based on the specific, not specific, like a generic procedure for federated learning, because a server will need to get the model updates from each of the clients. So it is inevitable that the server will receive these type of model updates. But then I can also extend it to if the updates are encrypted, but then this will be set as a further work. Yeah.
Okay, thank you.
Thank you.
All right. Do we have? Oh, yeah. I think we have an online question.
There's a Slack question from Gustavo. Just to clarify, the plots from the last layer are from the client's shared weights, or the aggregated model on the server side.
Oh, so it is all from the clients. So because each row is the contribution of each of the clients. So yeah.
All right, thank you. I think we have time for one last question.
Hello, thank you. One question: is it possible to extend this solution to other type of attacks, like for example, data poisoning or model poisoning?
Yes, I think so, because this is based on the model parameters of the final layer, which is the logit. So even for test recognition data set, they will also have such parameters to be observed. Yeah.
Thank you.
No worries.
I think we have one last question over there.
Thank you. So these plots show the values of weights or the outputs of the network after the final layer?
This is the weight.
The weight. So my question is, have you noticed, have you experimented, have you noticed anything interesting showing up when it comes to, let's say, the predictions of the logits actually, or, confidence, however defined, when it comes to the attackers versus benign cases?
I have not especially take a look at the output, because this fully connected weight will directly relate it to the logit. So I'm guessing that the pattern will be completely proportional to it. Yeah.
Okay, thank you.
Thanks a lot. All right, so our next speaker, you've probably seen him on our social media and all the initiatives he's been taking care of. Please welcome William.
I think we should give another round of applause to all the amazing speakers that are here presenting really cool technical work, and that will come also later today and tomorrow. So let's give it up again. I think it's that one, exactly. Is it this one?
that's not it. The community. Yeah, exactly. Yes. Okay. Hi, everyone. My name is William. I'm a solutions engineer at Flower Labs, and my presentation is not as technical as the rest of the other people here, but it's generally a big shout out to the open source community that empower Flower. And these are some of the numbers. You might have seen them, or you will see them in the other presentations, but this Flower community is growing. It's a big community, it's a vibrant community, and we have, you can see the numbers, 5,700 plus developers that like and use our framework on a regular basis. We have more than 2,000 open source projects that depend on the Flower framework, and more than 150 active contributors to the framework. And of course, you are welcome to be one of these if you're not already. But I want to share some recent success stories that have happened in the last year that came from the community. And the first one is Le Robot using Flower. This came actually from one of our contributors. That person said, let's do something in the robotic space with Flower. And it's a collaborative way to train robots in remote environments. And this got merged. This was a successful merge to the Flower framework. And you can see a bit of the application itself here. The application that it got tested on was basically moving around this sort of T that you see here, and it's supposed to fit in this little piece. And in the beginning it struggles, but eventually it learns how to do it very fast. But this scales to any sort of robotics application that you actually want to use it for. So it's up there on our GitHub, and it's available for you to use immediately. Then we've had a lot of cool speakers in our Flower monthlies, and this is, it happens every month. We invite speakers that are doing state-of-the-art research to come and show how they are using Flower for their research and applications. And, this is in any sort of domain. This is in medicine, this is in finance, automotive, and with different types of models as well. So I invite everyone to submit, and if to submit, cool talks, and you can come and join these sessions. So what's new? Well, we have on Fridays now Beers with Engineers. If you want to join, this is a laid-back and relaxed session where you can come interact with the Flower team, ask us questions about anything. How can I get started? How do I use this for that? Or just want to chat in general. But we are also announcing the Flower Bounty program, and this will be really cool, I think. This will be something where we put up on a whiteboard things that we want to see implemented by the community, and if you can voluntarily go in there, check out what we want people to work on together with us. But it's a voluntary effort, so you can see what we put up there or what the community puts up there. And afterwards, you can, if it's successfully merged, you can get rewarded for this as well. So we're really looking forward to this and hope that you are as well. And with that, I would actually just like to conclude it. I hope that you are looking forward to the upcoming speakers that will present cool technical stuff with that is using the Flower framework. And if you want to talk more about any particular part of Flower, I am live streaming. I'm helping out at the live stream that is for the online people. So if you want to talk about whatever you're working on in Flower, I'll be down there in the breaks, and you can come. We can chat for a couple of minutes so that the online community can get a feel of what it's like to be here. And with that, I would like to conclude it.
Thank you very much, William. Unfortunately, we don't have too much time for questions, but just know that William will be around, and even the whole team, and we'll be very happy to talk to you. So
in any breaks, if you want to chat, I'm down the stairs there.
Perfect.
And you'll be on the stream, so be prepared.
Thanks again. All right. So our next speaker is joining remotely. He's a chief AI scientist at Databricks. Please welcome Jonathan Frankel.
Hey, everybody. I'm just going to verify quickly. You can see my screen and you can hear me. I can't hear you, but I'm taking that as a yes. Awesome. So thank you so much for having me. It's really exciting to be here. I'm sorry I can't join you in person, but you're getting a brand new, fresh talk based on brand new results that literally were just released yesterday, and you're going to get some strong opinions. I think I've gotten a bit of a reputation for having strong opinions, and I would hate to disappoint. So please bear with me. The one other thing I'll say is, and for the host, this is an FYI for you. If someone has a really, really, really strong opinion in response and wants to chime in and yell at me, please let them do that. Please, please, please enable people to yell back at me. It's no fun otherwise. So I'm going to talk today about making AI real. It's going to be a little bit reflection and kind of thoughts, and then some concrete technical results. This is what's on my mind as of exactly this moment with new results and just my opinions on the space. So I think there's an easy place to start here. We've made big promises about AI lately, and there's some specific people in particular who have been saying things that, there's certain people who have bigger platforms who are saying these things, but I think for any of us in the AI community, we're hearing things like this from our friends, from our colleagues, not just from people like Sam Altman and Dario and Jensen and what have you. And I'm saying the word we here. I've tried not to say these things, but we as a research community, we collectively own these statements in the eyes of the general public, the world, our customers, the people who are trying to put AI into practice, enterprises, users, the open source community, everyone. Nobody's distinguishing between, Jonathan Frankel and, anybody else who's here. We jointly own these statements. And we've made some really big promises. And those promises have been, people have placed bets on those promises. They've placed bets in terms of GPU manufacturing, in terms of people willing to start companies on the chance that this is true, people spending money at companies, companies making huge capital investment, venture capitalists investing. A lot of people have bet on this in a very concrete way, have put money and time and energy and passion on the line. And I think the bill is coming due. I think that when I talk to my customers at Databricks, they hear all of this and they ask me, well, why isn't my AI performing at PhD level? Why don't I have something near superintelligence today if we're only a few thousand days away from full superintelligence? If we're going to have something that's, that surpasses almost all humans at almost everything in 2027, it's 2025. Shouldn't we be feeling something that's pretty close to that by now? And we all have to pay that bill. So this is how I think about the world today. This is what's on my mind as I go about my business. If we as a research community want to get to keep doing this and keep pushing the science forward and keep pushing toward the transformational change that I think many of us are convinced AI can provide for us, we have to make sure that we pay this bill. This bill is due. And I feel this personally acutely. Databricks is, I like to say Databricks is a really boring company, and that's the most exciting thing about it. We try to make it possible for people to do exciting things with all the data they have, whether that's storing it, understanding it, accessing it in real time, or using AI to ask questions of it and make effective use of it, what we kind of call data intelligence. More than 12,000 enterprise customers, so we hear and see a lot. And getting AI deployed in practice is still really challenging. Despite the fact that we're 2 years away from AI that's better than almost everyone at almost everything, despite the fact that we're a few thousand days away from superintelligence, getting AI deployed in practice still seems pretty hard. I'm thinking a lot about what's holding people back. I'm spending a lot of time these days personally just talking to these customers who are struggling or who are really fighting, or the few that have been wildly successful with this and trying to understand what isn't working and what is working. And I'll give you my take. This is the reflection part, and then we'll get to the technical results, I promise. I think people really need two things. Number one is they need help on specification. How do I describe what I want my AI system to do? In code, this is relatively straightforward. You write unit tests. You write integration tests. Even in a lot of cases, code is kind of self-specifying. You can just look at the code, and the code is a description of the procedure you want the code to follow. In AI, this is very distinct. Writing unit tests for code, or writing unit tests for AI, highly non-trivial. I'll say more about that in a moment. AI is not self-specifying. You can't look at, AI and see what it did. Even with reasoning traces today, I think, I'm a little skeptical of what reasoning traces mean to us. I kind of have this worry that reasoning traces are today's interpretability of yesteryear, where we looked at, saliency maps of images and tried to read the tea leaves of what the neural net might have been doing. A lot of it ended up being falsified with more rigorous science. And I worry we might be in a similar place with reasoning traces. So how do I specify in a world of AI? And how do I know whether my system is doing that? How do I measure? How do I judge outputs? How do I have a specification that is measurable? The other piece is system building. How do I actually get an AI system that meets the specification? And the last part, I think, is the most important one. That's what I'm going to touch on most today. How do I actually build an AI system using what I have, not using what I wish I had? So let me say a bit more about this. The research answer for specification is build an eval. How many people in this room, I can kind of see you, so feel free to raise your hand. How many people here have actually built an eval successfully, where you're proud of it and you think this actually describes your system? Okay, I see one person who raised a finger, not even a full hand, but a finger, which tells me quite a bit about how hard it is to build evals. I've had a really tough time doing that. And, I have access to a team of world-class researchers and huge amounts of data annotation budget. The reality is building evals is really, really hard. Showing up to an enterprise customer and saying, oh, just build an eval. Why didn't you do that? That's blaming the customer for something that is really difficult for them to do, something that is still befuddling the research community, befuddling an audience of people in this, who are watching this presentation right now, who are not exactly average. You're showing up to this event. You are not exactly the average person following AI. The startup answer is use AI to build evals. Just build an AI builder. The reality is building evals is still really, really hard. I've yet to see an eval builder that has really comprehensively solved this problem for more than one person. I think I have some other opinions on this, but that's a separate talk. But I think we're trying to prematurely optimize here. Okay, how do I know whether it's doing that? The answer is run the eval. I'll keep coming back to the reality. Building evals is really, really, really hard. I have a bunch of thoughts on what we should be doing here, and I'm working on some stuff on this with my team right now. All I'll say is stay tuned on that stuff. Okay, system building. How do I get an AI system that meets the spec? Well, fine-tune, prompt engineer, build an agent, whatever the system tuning du jour is. The reality is you need infra, you need data, you need money, you need time. Time is actually the hardest part. If you're someone at an enterprise and your boss has said, go do AI for us, they're not exactly giving you a year and millions of dollars to do this. They might be giving you 2 weeks to go and do this. That's the reality. And, the answer lately, verifiable rewards. Just figure out a way to a verifier for your task and then let the reasoner do RL and magic will happen. The reality is most tasks aren't easily verifiable. And our research answer right now is let's keep our fingers crossed that math and coding, the two things we know about as computer scientists because we learned about them in our intro classes, and so we've got AI doing that, they're verifiable. Let's pray that the reasoning process that AI models learn for this happens to generalize to things like enterprise writing and SQL and, doing call centers, the bread and butter of what enterprises are trying to do right now. Okay, the thing I'm actually going to talk about today, now that I've given you the rant part of this presentation, is how do I build a system using what I have? Not using what I wish I had, not using, thousands of preference pairs or thousands of well-labeled fine-tuning examples that I just don't have. Nobody has clean data sitting around that they just haven't tried to fine-tune on. And the answer, at least the beginning of an answer for what I'm giving to my customers today is in this talk. So, the bottom line. This is, if you take away one big part from this rant, to live up to the promises we as a research community have made about AI, we need to show it can matter in production, not just demos. I think a lot of the really exciting things we're seeing are demoware right now. And getting them into production is a whole other can of worms. To do that, we have to meet people where they are, not where we wish they were. That's my research thesis right now. This is driving my entire research agenda and kind of what we're doing in AI at Databricks. And also not where we should be. shaming people into saying, well, you don't have an eval, so that's your fault. You don't have good fine-tuning data. That's your fault. Good luck building a startup around that. At Databricks, that's our job. Okay, so I'm going to talk about this method called Tau that we released yesterday. You'll be forgiven if you didn't see it in the waning hours of yesterday when it came out. Tau stands for Test Time Adaptive Optimization. I wouldn't worry too much about the acronym. It's a name. Every good method needs a name. But the key takeaway here is the goal is to let people fine-tune models without labeled data. Sounds kind of like magic. Sounds kind of sketchy because, can you really do that? There's no free lunch here. And the answer is no, you can't do this in general. But actually, it works well enough that, it's good enough for my customers. And that's pretty nice. Okay, so that comes back to this last part here. This is what I'm talking about here. How do we help people, how do we meet people where they are when it comes to data? So, I sat down with my team a while ago, and the question we asked ourselves is, what data can we realistically expect our customers to get? Not what do we wish they had. Not sending them off to spend $1 million on data annotation. Not sending them off to do a big data annotation expedition internally that requires aligning a bunch of stakeholders, getting a bunch of other teams to go and, work with them for a while and not do their actual jobs. What can they actually get? And the easiest thing that I think you can get that is non-trivial is example inputs for your task. Here's how you do it. Really simple. Set up an LLM endpoint, prompt engineered, do something dumb. It doesn't have to be good. Have people interact with it. Those people could be you sitting at your desk. It could be internal users. Hell, it could be like asking GPT-4o to interact with GPT-4o, pretending to be a user. Whatever. Just get something. Get some example data that might be in distribution for your task. You should probably check to make sure it's actually in distribution. At this point, you may realize that your task is poorly specified and you have to figure out how to do things a little bit better, but what have you. Collect those inputs, use those inputs to make the LLM better, and then repeat. This is a really simple loop that I think anybody can execute. It doesn't require you to have any data up front, but it gives you a very easy on-ramp to get data. And from there, it creates a flywheel. I think this is realistic to expect from people. The hard part is how do you actually make this work and do anything that isn't stupid? How do you do this on input data when you have no supervision and you have no idea what your task is? That's the hard part. But I think meeting customers where they are means you start by asking, what are people capable of doing? And then you leave it to you as the researcher, you as the ML scientist or engineer, to figure out the magic underneath that can do something interesting with this. Your job is not to do something interesting and then hope people want it, or shame people into having the things you want. Okay, so I'm just going to give you the results. So these are 3 different sets of tasks. Finance Bench, it's a reasonable approximation for a lot of document understanding and question answering tasks that I see day to day with my customers. DB Enterprise Arena, that's an internal benchmark we did have annotated, really high quality. It's got, document and question answering. It's got multi-step reasoning. It's reflective of what we thought, enterprise tasks might look like. And then Bird SQL, it's a text-to-SQL task. This is meant to kind of, text-to-SQL is a pretty typical enterprise task. I see that a lot, trying to make sense of unstructured data, tool use. And it pushes the envelope a little bit from some of these fuzzier tasks to something that's a little more concrete. What I'm showing you, the leftmost bar in red here, that's Llama 3.18b. The 3 bars on the right are, 3 popular OpenAI models, just so you have some context here for how well different things are doing on the task. Finance Bench, once you get into the low to mid 80s, you're kind of saturated. Bird SQL, once you get into the high 50s to 60, you're kind of saturated. DB Enterprise Arena is actually not very saturated. It's nice having an in-house benchmark that's hard. I'm also going to show you supervised fine-tuning. This is what you get if you do SFT. Every single one of these tasks, we actually have pretty good labeled data sets, on the order of thousands of examples with labels that were collected at least in the same way as the eval set. We'll get back to whether these labels are actually good in a moment, but bear with me. This is supervised fine-tuning. This is Tau, which requires no labels. All we did was we took the same inputs that came with the training set, and we just left out the labels. Not only does it lead to improvements, which I found non-trivial, it actually beats supervised fine-tuning, which I found to be ridiculous and not something I remotely expected. And we put a lot of work into that supervised fine-tuning baseline. This is not like, we tried to cook the books here. I do expect my team to continue to do rigorous science. I found these results deeply surprising, that you can actually beat this without labels. I'll say a bit more about the internals of the method in a moment, but I thought this was cool. Same thing on Llama 7DB. The benchmarks are a little more saturated, so the results are a little less, mind-blowing, but you see the same thing. Supervised fine-tuning leads to slight improvements. It actually leads to a little bit of worse performance on Finance Bench, and there's a whole story as to why we think that's happening, but we did work really hard to get this to work nicely. Again, Tau actually works pretty well. No labels. This is surprising. It has less information, and yet it does a little bit better than supervised fine-tuning. What's going on here? I'll also, this does actually get some relatively general results. We have this whole kind of gauntlet of things. This is like what we call our Databricks Enterprise Gauntlet. This is what I kind of challenged the team on for more general purpose stuff. And actually led to meaningful improvements pretty much across the board, except for coding where, it didn't improve at all. It didn't really get worse. Again, I was surprised about this. Okay, here's how it works. This is an industry talk these days, so I'm not going to give you every, last detail of this. But the high level is RL. Use RL. And you have the LLM generate a bunch of responses for every given input. You score the responses, pick the best ones, pick the worst ones by some metric. And how that metric works is, it could be anything from a verifier to rules. In our case, we built a reward model for enterprise tasks. We call it DBRM, not open source, just available in-house. But we spent a lot of time and care curating pairwise preference data, both, human and synthetic, on specifically enterprise tasks. And the thing that kind of shocked me was it actually worked reasonably well across tasks. I figured this was going to have to be really, really bespoke per task, and we are going to have to ask our customers to give us some preference data or something that we could use to fine-tune the reward model per task. Didn't actually end up being necessary. Then you do some RL, you get a trained LLM, and you can just rinse and repeat this process. And it actually works quite nicely. But no labels required, just this reward model or any other kind of criteria you have, filtering, rules, whatever you have to throw at this. That's all it is. There are a lot of details that you have to get right. I'll give a couple quick FAQs, and then I'm going to wrap up, and we can chat for a little bit until we need to move on to the next talk. What are the full details? Stay tuned. This is an industry talk. Sorry. A lot of RL. There's nothing earth-shattering algorithmically here. It did take a lot of work to get the right combination of things, and there was extreme attention to detail in things like the reward model and how to get the right RL algorithms to work in the right ways. This is the hard part. I wish I could sit here and say we invented a new kind of RL. Novelty doesn't generally get you very far in practice. Getting the details right is what gets you really far in practice. And honestly, what I'm most proud of the team for is that they really kind of sweated the details here on things like the data for the reward model and, what combination of RL algorithms were used at which stages of the pipeline and things like that. That's what leads to success in reality, not, a big new breakthrough. Surely this can't work in general, right? This is too good to be true. You can train without labels. Yeah, there's no free lunch. I will not claim to you that this is going to work for every task. What I will tell you is just what you saw. It worked surprisingly well across, a decent number of enterprise tasks that our customers care about. The reward model is probably really important for this. We put a lot of work into that, and the ability to tell which outputs are probably good and probably not good, that's pretty important when you don't have any labels. And the fact that you can do this somewhat task agnostically probably says a lot about, how similar the tasks are that enterprises actually care about in reality. There's probably pretty clear distinctions between what a good output and a bad output is objectively. Even if you don't know anything else about the task, you can kind of intuit what the task probably is. And that's really what the reward model is doing. Now, is this going to get you to 99% accuracy on your task? Probably not. This provides a much higher floor for our average customer. This is a strong baseline for fine-tuning that they can get at without any labeled data. That's really important right now. So DBRM must be amazing if it beats SFT. You must have done a lot of work on this. And the answer is, yeah, we did a lot of work. I think it's a pretty good reward model. But also, I think getting SFT labels is just hard. I threw a really qualified research team at trying to get good SFT labels for these tasks. And the people who built some of these benchmarks, we paid annotators at, one of the top annotation shops to get us supervised outputs for these tasks. I think this just says getting labels is hard. This doesn't necessarily mean that we built some magic algorithm that's amazing. It may just mean the labels weren't that good. But if it was hard for a world-class research team to get good labels and some world-class data annotators to get us good labels, what's your average enterprise going to do? Maybe we need a different approach. And, that should be one of the big takeaways. Okay, so where do you go from here? It's pretty simple. These are the two big questions and the four smaller questions that I'm spending all my time on these days. If we can't solve these questions, nobody's going to actually use this stuff in production. And I hope what I've shown you is there's actually some really interesting research depth and a lot of novel work to do in answering these questions. But the important part is it doesn't start from saying, here's a cool technology I can build. It starts from asking, what do people need? It's a product question that leads to a research question, not a research innovation that leads to a product. I think that's really important, and it's a bit of a mind shift for at least people who come from my academic world in terms of how we think about this and how we make AI successful. I don't think coolness is going to be what gets us here. I don't think it's going to be mind-bending algorithmic innovation. I think it's going to be thinking really hard about how people are approaching this problem and what they bring to the table and making them successful at doing that. And I hope this is one little anecdote about that. With that, I'm going to stop. I don't know if we have time for questions, but thank you for having me.
Well, thanks a lot, Jonathan. That was very exciting. I think we do have time for questions. So anyone in the room or also online through Slack, feel free to let us know if you have questions. Yeah.
Thanks very much. Great talk. And I think it's something I've been thinking about a lot is how important in the context of LLMs, just how important I think rather than just data, it's evaluation, it's understanding, it's having reward models. Because we've seen how LLMs are continuous. Every time there's a new benchmark out, it lasts about 6 months a year. But there's things that are easy to optimize, and there are things that are hard to optimize. And it's often the things that are hard to optimize where I think is a lot of what you're getting at. Is it seems like they're the real things that actually are what are solving the hard problems.
Yeah, I think that's exactly right. Like let me see, I'm trying to think the right way to put it. I think it comes back to specification. Like there's a whole separate talk I could give and a whole separate conversation we could have about what a specification for an AI system should look like. And I was very careful not to say eval, but instead specification, because I think specifications can take a wide variety of forms. And an eval is one very specific, very concrete, very high, or very demanding way of specifying an AI system. But there are lots of other ways of doing it. Much like when we build software, we have, unit tests, integration tests, assertions. There's we do fuzzing. There's a lot of other stuff we do to help specify the behavior we want out of a system. I think the same is true for AI, and we need to be a little more creative about what a specification looks like, how we make a specification measurable in ways that go beyond explicitly having an eval set. And honestly, I spend a lot of time these days with user experience researchers and product managers asking, like, what are the ways that we can get a user to express what they want out of an AI system that are easiest for the user and most informative for us? And then it's on us as scientists to take these informative specifications and make them, clear enough that we can actually measure against them or evaluate a system to see how well it adheres to a specification. But I think we should be generalizing our idea of eval to specification. And I think you framed that really well.
All right, I believe we have time for another question. All right.
So you mentioned that this technique shouldn't be expected to work wonders and work in general, but I was curious about where you think the next exciting application of it might be, even one that might be a little bit more in the research direction. Is there a task that you'd love to try this on and you might see some interesting results, or what goes next for this, do you think, maybe more in an academic direction?
Yeah, it's a great question. So right now, I'm really curious. I'm going to not quite answer your question, but I'll give you something else that I'm thinking about a lot. We have spent a lot of time in the past, 3 to 6 months, which is a long time in the AI world, talking about verifiable rewards and doing RL. And we have found precisely 2 tasks where there are verifiable rewards: coding and math. The question I'd like to see answered personally is how verifiable do verifiers need to be for existing methods to work and allow us to make progress on a task? If you were to replace your verifier with 50 LLM judges in a trench coat, highly specific LLM judges, does that constrain the problem enough that you don't end up reward hacking like crazy and you can see some of the results that you're seeing with O1 and DeepSeek and what have you with a task that is not explicitly verifiable? I think that's a very concrete direction. Even just the simple task of trying to get reasoning models to work for math and adding noise to the answers and seeing how much noise you can tolerate. That to me seems like a very basic problem that starts to move us in the direction of understanding how verifiable verification has to be. If the answer is it must be explicitly verifiable in the way that coding and math are, then I don't think these methods are going to be that useful in practice unless reasoning happens to generalize really well from those tasks naturally in the model. If you can actually get pretty far in using 50 LLM judges in a trench coat, well-specified LLM judges and well-calibrated, but 50 LLM judges nonetheless, and something that is not explicitly verifiable and is potentially hackable, but you can still get that to work, then I think we have, potential breakthroughs on our hands for a lot of customers. But I haven't really seen that question explored very much, at least in the academic world. And, the academic world is a very narrow place these days. But I would love to see the answer to that, because that, to me, will tell us whether these reasoning models are going to matter or not.
All right, thank you. That was very insightful. We won't take up too much of your time. Thanks again for joining us. And yeah, everyone else in the room, it's time for the break. So feel free to go downstairs for the lunch. And we should get back here at 2 p.m., I think. Try to be there on time, because there will be some very exciting talks. Thank you.
And we're back with the live stream. Hope that everyone liked the presentations that were just up since the last break. There were a lot of very interesting research projects and applications that we heard about. Right now, we are doing a lunch on site. So if you are tuning in online, we will still continue the live stream and we will be moderating and talking to you. So if you have any questions, comments, anything you would like to see discussed, we have another chair here right next to me to invite speakers to come, join, chat. And if you want anyone that you know is here to come and speak to me, then feel free to drop the name in the chat. And yeah, it will be... It's first of all our pleasure to have you here online. We know that there are many tuning in from all over the world, and we are excited to bring Flower AI Summit to wherever you are. Yeah, you might have seen also I had to run up to the stage to present a bit about the Flower community. It's a vibrant, engaging, and a large community, and we try to do whatever we can to provide you with the best framework out there for any sort of applications or projects that you might have. I'm trying to monitor the chat as we go, so you might see me look down at my screen that I have right next to me. But I know that there were a lot of people talking about decentralized FL and peer-to-peer learning, which is a very interesting area of expertise, and this is something that is possible to do within the Flower framework. It's not the conventional way of doing it, but there are tweaks that one can do in order to make it work that include a bit of tweaking the communication protocol, but it works. And I hope that we can bring a speaker to you here to talk a bit more about it. Maybe we'll bring in someone from the Flower team to discuss this, but yeah, as I said, if there is anyone you would like to see here right next to me, then feel free to drop the name and we'll try to grab that person for you. But yeah, let's see if there's anyone in the chat currently active. I see people are active. Maybe people are grabbing lunch right now. It's a good time. We'll see when the people will be back. I think it's for about 30 to 40 minutes we will be doing this sort of live stream, and then we'll get back to the other presentations. And you should definitely stay tuned for the next session, because the next session is actually our keynote speaker. It's our CEO, Daniel, and he will announce a couple of very interesting and cool things. So I definitely think you should stay tuned, keep this window open in your browser, don't go away at this point, because the best is definitely yet to come. So you should stay around. I see someone. Will this event be recorded and available to watch on demand? We will post the recordings after this. We will post snippets and some presentations. We might upload the presentations themselves for you to check out. If there is one specific one that you would really like to, see or talk more about, you can join the Slack that we have. It's more than 5,500 people in our Slack channels, active on a daily, weekly, monthly basis, and most likely one of the speakers will be there, so you can check it out and maybe chat with them directly. So that's a great way to get in touch with the community, definitely. And if you haven't already, I would urge you to like and star our GitHub repository if you like what we do and would like to see more of it. We try to bring you the best framework possible, and if you want us to do some features, implement some features based on your requests, or fix some bugs, do some documentation updates, you can put that there. You might have also heard me announce that we are launching this Flower Bounty program. And this is a really cool effort where we will put up things that we think would be interesting, but that we might not have just the time to work on at this moment. And it's a voluntary effort that you can go and check out. It will be something like a Google Sheet where you can see what is something that we would like to see implemented to the Flower framework, and you can go, and if it's successfully merged into our GitHub repository, you can get rewarded for this. But we will announce this a bit more. We have only been teasing it for now, but you'll see more about it. So this will happen in the next coming weeks. So stay tuned for more about that. Then let's get back to the chat here, see what goes on. Checking Slack, if you're not already in there. In our Slack, we actually have a designated channel for this specific event. It's called Flower AI Summit 2025. So you can join it. You will see a lot of updates about the next coming speakers, who is speaking, what they are talking about, and just chat with the team. It's very easy to get in touch with us there as well. And you can find everything that you want to know about Flower Labs, the team, what we work on, what we have worked on, and so on, and the versions that we release. You can go to flower.ai and you will see everything basically that we are at this point able to provide. There might be some documentation things that you think could be improved. Please let us know. We will try to take care of it as soon as possible, definitely. But most of it is definitely online, so you can see it there. There are cool things like examples, strategies, and aggregation methods that you can use for federated learning, provided for free. It's on our open source platform. And if you have any questions, just, drop it wherever available. Slack, here, Let's see what else. Maybe a question to the live chat or the online community in general. Is there any application area like healthcare, finance, automotive that you're really interested in? If you are, then please feel free to drop it here. We'll talk a bit more about, let's take healthcare, for example. We have a lot of people from the healthcare industry here today. So If you want to hear more about how they are working with privacy-preserving techniques, we can do so. We also have people from the finances industry, if you are interested in, how they work with numerical data, maybe also text-based data. See, can you explain how Flower and Scale-Up framework can interact profit, especially consider personally using your FedPer? Especially consider personalized. I mean, it really depends what you would use it for. Academic purposes, we have everything open source, ready, available for anyone to use, and the FedPer is only one out of many strategies that you can use for personalization. Sorry? Okay, yeah, I'm active. Yeah, I just see some pings. So we have the FedPer, which is federated learning using personalization layers. This is a strategy that you can use for federated learning but you don't want, for example, let me back up a bit. If you have the most basic strategy is federated averaging, and what that means is that you pull an average of all the updates that are sent back to the server. So you can think of it if, let's take the automotive example, if you have an AI that maybe drives your car or something like that, and you take data from one part which is maybe aggressive drivers versus another part which is slower, environmental conscious drivers, and then you take federated averaging as a strategy, you would get a resulting model which is somewhere in between, and it doesn't really serve any of these parties. So in this case, personalized strategies like this one that we are discussing here, the FedPer, would be great, could be used for this sort of purpose, but it depends what use case an institution, an organization would want to use it for. And there are other methods as well, such as we could talk about clustering techniques, other things, but maybe we'll have some people coming in here today from the industry talking more about, let's say, personalized efforts, because that's definitely a very active research area in the federated AI community. But I think it depends. The question here in the chat is, how can frameworks here interact profit, especially considering personalized FL using such strategy? And it depends what customer comes in and wants it. It's not as straightforward sometimes to find the right business model to use it for, but it requires discussion, like what is actually the task at hand when you do this. And it depends if you're working, let's say, in automotive, in medicine, if you have readily available labels, like data that you can that is easy to make sense out of, and not just feature values that are unlabeled, let's say, then you would need to maybe use another strategy that we might have in our GitHub repository. So to conclude, a lot of blabbering, but there are a lot of strategies available in the Flower GitHub, and if you want to use it for personalization, you can do so. But it depends what use case you have at hand that you want to use it for, and we're happy to help you find, narrow it down what it is exactly that you want to work on, and how Flower can provide you the framework to do so, what data you need and what models you would like to use. Let me just grab some water. So yeah, we're still live here. We are on site here. People are walking around upstairs. You can see the screen that is to my lower left, and people are upstairs talking. It's lunch right now, so I'm not sure if we'll get some people. Probably people are hungry at this point. There's been a lot of good presentations running, so people probably grabbing some food. But I hope to bring down some people here for you to hear us chat with. We'll see if we get people from different industries, such as the medicine, healthcare industry, finance, automotive, energy. I think some people were talking about as well, or just general AI applications, maybe for research. We can also talk about that. Where is federated learning and federated AI at this point? What is the state of the art? What do we see in these big conferences? Because our framework actually sprung from you could say it comes from an academic origin. We try to make our research available for you on archive and through conferences all over the world. So you will see the Flower team posting about this. Let's see, I think we actually have some people coming in, maybe chatting soon. So let's see who they're bringing. Yeah, let's see who comes in here. And just stick around, we'll have a lot of people coming by here in today and also tomorrow. So let's see who comes. If anyone is interested in joining us here, we have space. So yeah, okay. There will be a lot of people. Some people are shy. They don't want to sit in front of the camera, but it's fine. I'm seeing a question in the chat here. When fine-tuning large language model, using the FO framework with a non-IID dataset, is federated averaging still an effective strategy, or would it be more? Yes. Non-IID, for those who don't know, is, let me see if I say it right, it's non-identical and independent distributed data, which means that the underlying data from these different 5 minutes, okay. The underlying data from these different sort of connected clients that we call them in a federation, take for example the healthcare industry again. If you have data that doesn't really, that isn't necessarily the same across all the sites, you could have maybe medical data from young people at one side, old people on another side, then that would be different type of distributed data. And that's a big challenge in federated AI, and how do we kind of overcome this sort of problem, or challenge at least. So when fine-tuning it, federated averaging is still an okay strategy, at least, but there are better ones to use, and they are available in the Flower repository, so you can check them out. But the downside of using federated averaging, it's kind of a standard technique, and you draw an average from all the updates that you get, and they might not just fit any of the participating clients that you have in this federation. So what you want to do, what you want to find, is a way of customizing the AI model that is sent out to, let's say, all of these hospitals, so that they can serve the patients well and perform really good on site, instead of just like an average solution that is broadcasted to everyone that participates. That wouldn't be the best. So what I would maybe recommend is that you use federated averaging as a baseline. You can use that as a benchmark, and then if you want to aggregate the updates in a different way, you can either use one of the ones that we already provide through our framework, but you can also implement it yourself, which is possible. We have the documentation up there, so you can go ahead and do that. And if you want to maybe implement something which reflects state-of-the-art research, you can do so if you can understand the code. But there are probably better ways to do that, but you can use federated averaging as a benchmark, or let's say a baseline. Unfortunately, there weren't people coming in here, but let's see. Are there any ways to quantify the contribution of clients to the global model in Flower, apart from leave one out method? Yes, that is a good question. Yes, you can do that. I mean, contribution. I'm thinking. I don't want to say the wrong thing here, but I do think that we either have baseline which is already implemented that you can use. I need to check the name of it, but if we don't, then there's one which is currently, we're trying to merge it to the repository, so it should be available soon. But you can see there are ways to kind of get around it and maybe measure the non-IID-ness, which is not really the same thing, but we have Flower data sets. This is our kind of secondary package that you can use together with Flower, and it works really well. So you can see you can visualize the distribution of the data across the sites, and maybe that will give you an indication of the general non-IID-ness of the data. Of course, that's not the same thing as quantifying the contribution of the clients, but you could, the most basic way of doing it would be maybe a weighted average if you know that some of the clients might have more data. Like there are ways to. I think it's a twofold problem. Maybe correct me if I'm wrong, but you can. Let's see how we do this. I'm just thinking. What you can do is. Oh, yeah, this is fine. Yeah. Should I swap? Okay. I'll just swap the mic. No, so you can do non-IID type of data in Flower and check what the distribution of the data actually is. But contribution of the clients, you can do weighted average. Maybe that would be the basic one, but there should be one strategy out there, I think. I have to get back to you on that. I'll keep that in mind. I'll just note it here because I don't have everything in my head right now, but it should be, it's definitely possible. I mean, as I was saying before, Flower is a modular plug-and-play type of framework, so you can implement it yourself if it's not readily available. And of course, we'll try to help you along the way. You can chat with us, put up an issue on GitHub if there's something missing, if there's a feature you would like to see implemented, and we'll get right on it. But I know that question, I'll try to get back to you. Thanks for it. Okay, let's see for the response. Looking forward to connect afterwards. Was just wondering, as you announced some time back collaboration with Scale on my current framework, we'll catch you later. I know there's a YouTube video on it. I think there was a recording, so I haven't watched it in a while, so I would maybe go back and see what it's like. But I will definitely check with some of my colleagues about this collaboration and see where we are, see what was the latest updates, and then I'll get back to you. I will note everything down here so that we have it for later. Collaboration. Yeah, let's do like that and get back. And if you're just tuning in, we currently streaming, but upstairs they are having lunch, so people are walking around grabbing a bite, and we might have some people coming by and we'll chat, and then in a couple of minutes, in 10 minutes, our CEO Daniel will speak. He is the keynote speaker for today, and you really don't want to miss this one. This is there will be a lot of cool announcements and just general Flower stuff. So if you are interested, which I hope you are, then you should stick around for another 10 minutes. Just leave the browser open. Let's see. How can I simulate non-IID data with Flower? Yes, I would say Flower datasets is the best is the package to go for this. So if you want to simulate, let's say, a label skew, where different clients, let's take hospitals again or something. Let's say that one hospital has very little amount of data versus a couple of others that have more data. That would be a quantity skew. So that you can do that. You can also partition it based on user ID. If you know that some users, data is allocated among users and you want to split it on a specific type of feature, you can also do that. You can do feature skew where you add a bit of noise to some of the features. There's also label skew. So let's take if you're doing some sort of multi-class classification, some clients might not get data from a specific class, but the others might, but they know that, okay, we should try to classify this and that, basically. Okay, I see that we have some people who are coming in here to speak. Hi, how are you? Straight from lunch, not even done chewing. Let's see. You can scooch in here a bit. So here's the camera. You'll see it. We're talking with the live stream right now. So please introduce yourself.
Yeah, hi. My name is Pavel Abramov. I'm here with a poster about machine learning compilers and how it is all relates with federated learning. I'm from ZDida.
Okay, nice. And you are having, I think you're having a poster upstairs,
Yes,
right?
yes.
Maybe you can, first of all, like, how do you like it? What's your...
Awesome,
yeah,
actually.
You like this event?
Yeah, very great energy, and I feel like there is a lot of intellectual power here and a lot of great ideas and a lot of great thoughts.
Yeah. Definitely. I mean, we have more speakers coming up today. The keynote speak is actually starting in 8 minutes, so we need to, that will be really cool. But maybe you can talk a bit about your research, maybe cool applications, or any specific industry that you work with when it comes to federated learning and Flower.
Yeah, sure. So I come from the industry of edge computing, and edge is not a cloud. Edge is about different devices scattered across vast geographical regions with vast different hardware resources, which is actually, I think, a really good basis for federated learning. And there is a great untapped market of data there. And what I worked on in a company is developing an operating system for those edge devices. And I think there is a great potential for implementing ways to run federated learning efficiently on those vast devices. Again, I think the customer ask is, how can I run my AI or machine learning models, and how can I run it effectively? And can I squeeze it in? So my research is focused on, in the case of virtualized environment, which we learned from our company and EvoS, the operating system we're working on, how in this scenario with virtualized environment containers, here, 1, 2, how can we effectively run machine learning workloads and AIs on a vast variety of hardware?
And is there a specific, is it broadly applied, or is there a target industry that you're working towards? Or is it more edge AI in general?
I think it's more about edge AI.
Okay.
And my main focus is to enable people to run it fast and effective.
Yeah. Okay. And are there some challenges that you have had to overcome? Like what when you got started, what was your, how did you come to use Flower? What type of things are you seeing that are maybe things that you will work on in the next coming period, or things like that?
So the thing that I'm working right now is, to frankly, proof of concept yet, prototype, and I am trying to gather ideas and feedback from how we can implement it from open source perspective. Right, and the story about Flower and how I started to use it actually goes with my master thesis.
Okay, yeah,
when
nice.
My background is in data science, and I did my master thesis in federated learning for automotive. And when I was assessing what frameworks are out there, I actually thought that and came to the conclusion that Flower is the best one.
Okay,
and so far so good. So far so good, yes. And
okay. And what language are you using? Is it more? Are you working with TensorFlow, or is it PyTorch, or is there something else?
So my idea, again, this is a broad idea of having intermediate representation for the machine learning models, which would be agnostic of the PyTorch models and all, because in the end of the day, it's a computational graph. You can think about it as a MLER.
Yeah. Okay. Yeah. Interesting. And where would you, if you had, now you're creating this proof of concept, and you're probably maybe deploying it on edge devices and things like that already, or trying it out. Is that correct?
Right now, I'm trying to make it all work.
Okay, yeah.
And I think that the interesting idea would be to run those things on NVIDIA Jetsons, the things that are deployed.
Yeah.
Because they have interesting accelerators. And
so have you looked at our embedded device example? There is one on our GitHub, I know that, but I had some people reach out to me because I think the documentation is mainly for Raspberry Pis, but you're saying Jetson machines that we'll need to make that readily available so that people can kind of copy paste it. But what do you see as like things that we could do, the Flower team, to improve maybe for people who want to use it on the edge? Is there something that you see?
Well, I think, frankly, the evil is we provide support for Jetsons. It is very challenging, and I think there is no one straightforward way to do so. But so I would just say that good documentation always helps, and examples.
Definitely.
Yes.
Yeah. Let's see if we have a couple of questions here. We're just gonna check quickly some questions. Are there metrics implemented in Flower? I'll definitely get back to these and try to answer them. See if there are any. Not even done chewing. Yeah. No. Yeah. What are you most? What presenter are you most excited for today? If you're looking forward to any of the speakers that are here.
I was actually looking forward for Databricks Chief of Science, who presented just.
Yeah, that was also a great one.
That was awesome. Yeah.
And people, I mean, we'll definitely try to make the recordings available for everyone who's tuning in, so that you can watch them again, watch the presentations. But yeah, that was a great talk.
Yeah, I agree with that.
Okay, glad to have you here. I think we maybe need to wrap it up because soon the Flower Keynote is starting. So Daniel, our CEO, is on the stage in a couple of minutes. So thank you for coming in, and I'm sure we'll talk more over the days. Yeah,
sure. Thank you.
Thank you.
Thank you.
Okay, Alina, do you want to jump in for a quick chat? Okay, after the demo. We do after the demo. Yeah. We have people lined up outside, so no. There will definitely be more people coming in and talking. Let's adjust this just a bit. Okay, yeah. So as I said, in 2 minutes, less than 2 minutes, we'll have Daniel, our CEO, on the stage. You definitely don't want to miss this. It will be, he has some cool things to announce, cool things to talk about. And there's honestly not that much more I can say about it. Let's see. Just checking if there are any more questions here. Well, you can check Flower datasets. Yeah, that's good. Are there metrics implemented in Flower for evaluating different aspects of training? For example, communication metrics. Great question. So you can measure communication, effort, and also hardware utilization. There are examples up there on how to use, let's say, both the simulation engine but also the deployment engine to do this. And if you want to, visualize this, we have integration with weights and biases that you can use. This is great for visualization, and you can see how the accuracy or the regression loss is going down, things like that, but also communication effort, which is a very essential part in federated learning. So if you have different entities spread out around the world, maybe a server, you want to be able to measure, okay, how much do I communicate between these sort of nodes? So that's definitely an essential part of what federated AI is, and Flower can provide that already if you're doing it in simulation or deployment. There are, of course, always things that could be improved, but if you see something, just drop us a comment, put it in GitHub issues if there's a feature request or a bug that you think should be dealt with. Yes, that's what I can say about that. I think, let's see. Oh, they're not ready quite yet. Yeah, so... Thing is, guys, I just saw that there was a little timer here on my screen and that was supposed to start, but yeah, let's just continue with it. Let's see if there are any other questions here. Metrics implemented in Flowers, good question. Yeah, this guy who came in was, he was still eating, so I didn't want to interrupt him too much, but he was eager to speak. So I hope we have some more people coming down. I was wondering, when dealing with cross-device FL, how the dropout edges from the training is dealt with. I was wondering when they know where the cursor. Okay, let me get back to you on that one, because we have some people in our team that knows more about this. I'm gonna check with them when the presentation gets started, and I can chat a bit with them. But yeah, as you see, there are so many things that are kind of built into the framework, so that it's difficult to know everything that is currently, state of the art in the framework. But yeah, that's what I can say about that. We'll see if we have. I think you might have seen Sean Chen, my colleague, come in here before. He could maybe talk a bit more about it, but we'll also invite some other people. I see some people walking around out here. See if they stop by later. My question for you in the online community, is there any speaker that you're really excited about, apart from maybe the keynote speaker or one of our founders? Is there anyone else that you're looking forward to see here presenting on the stage? If you are so, just drop their name here. We'll see if we can get them in the chair as well to talk a bit more. But yeah, the sun is hitting me a bit weird here. We'll have to pull the curtain, but it's a long day. It's 2 p.m. here in London, and yeah, it's very interesting to see all the questions that you have. Trying to do our best here to answer them, but it's yeah, it's very great to see that people are so engaged. Let's see if we have any in the Slack here. Bringing a guest down, some stuff. Okay, we have a lot. Yeah, we'll see who stops by. But we have some people lining up. But it's not much time left until Daniel, our CEO, is stepping up on the stage and delivering some good stuff. Yeah, I'm hearing we're about to start, so we go over to him.
Just to let you know, we'll be continuing with the third session in 2 minutes, I think. So yeah, please be ready.
2-minute delay. You can I'm hearing people speak to me in my earphones here. So 2 minutes, then Daniel will be on stage. So stay tuned. Don't drop out yet. I see Massimo commenting here. Can't wait to hear more about Flower Intelligence. Yes, Flower Intelligence is very exciting. So we will hear more about that. Okay, I see we split screen here. There you see myself as well. I think we have 1 minute to go, so don't drop out just yet. Stay tuned. There will be more interesting speakers after this as well. So not only the keynote, but a lot of people from invited companies will come up and speak. And yeah, you'll see people, you see the screen here on the side. There are people from companies, well-known companies, that will talk about their federated learning efforts and what they do together with us from the Flower team. So if you have any questions for them as well, feel free to drop them, in the chat, in Slack, LinkedIn, X, wherever, and we'll try to bring it to them as soon as possible. So yeah, we have the timer up again, 1.5 minutes basically till we are live. Daniel is soon stepping up on stage. I will try to get some food as well. This has been, it's great talking to you, and I think that you have, if you have more questions, just continue putting them down here. I note some of the questions that I can't answer immediately. I'll try to get them to the right colleague of mine in the Flower team and see what we can do about it. But I'll definitely stay active in the chat. So, we'll be here the whole day until 6 UK time, and then we'll also have some online presentation. We stay active on social media, so make sure that you also check out some small teasers, announcements that might go up there as well. There's a lot to do throughout these 2 days, but I think if you stay around, you'll be more than happy to see all the presenters that are presenting really cool cool work and technical implementations using Flower for federated AI. And this is, we try to bring you as much state-of-the-art as possible and see what people are actually using it for. So I'm hearing some people talking to me. Okay, we'll sign off and soon the keynote will start, so make sure to stick around. I'll be active in the chat.
Summit 2025. It's amazing to see so many of you here. It's last year was quite packed, but this year it's even bigger. I think you've seen the numbers that Nick showed earlier, and it's quite impressive. We also see so many people joining on the stream online, and it's just amazing to see how much the Flower community has grown since last year. Today, I think many of us, in many of the conversations that we had, I think many of us are here because we are excited and interested in where AI is going in the future and what the future of AI actually looks like and how we can build it together. And I think an interesting way, an interesting perspective to try to predict where the future might go is to actually look at the past and see how certain things in the past have played out. So one of the angles, one perspective I find particularly interesting is if we look at the history of computing, we had this era of mainframe computing. And if we look at characteristics of mainframe computing, it was those everyone was trying to build a bigger system, and these systems, they were isolated. There was no connection between these systems. Everyone just tried to build a bigger system. They were mostly proprietary, so they were under the control of the manufacturer, and you either had access to one of these systems and you could use them, or otherwise there was just no way for you to participate in this era of computing. Now, as we all know, everything changed with personal computing and the internet. And one way to frame this is to sort of call this the networked era of computing. And if we look at the characteristics of this, it looks very, very different. It's fundamentally, it's smaller individual units, and these smaller individual units get really powerful because they are connected. They're not isolated anymore. They talk to one another using open standards. Everyone can participate. Everyone can get a personal computer. Everyone can customize the computer. Everyone can run the software they want to run. This is also when we saw the advent of open source software, and it's fundamentally decentralized in nature. Now, if we look at the future of AI, if we look at where AI currently is and where it might go, I feel a little bit like we're almost in a mainframe era of AI. Everyone is trying to build a bigger and bigger cluster. These clusters are essentially isolated. These clusters are not talking to one another. The only way to participate is really to call an API. This is how still many, if not most, of the AI systems we all use today are built. Your device has a little bit of data on it, and all of this data goes to an API, and then behind that API, usually there's a closed source model, a proprietary model. And if we compare that sort of to the history of computing, then probably the next slide is quite obvious. I think the future we want is a future where it's easier for individuals to participate, easier for different organizations to participate, and a future that is not as isolated as the current one, but one that is more connected. So this future could, one way to frame this future is to call it the networked era of AI. It's fundamentally decentralized. It needs to be built around open source software and open standards. It's to enable this connection. It needs to enable individuals and organizations to run their own models. And essentially, it puts the user and individual, also smaller organizations, back in control. So it's open to participate, and it's fundamentally decentralized in nature. Now, one of the key ingredients we need to make this future happen is really the capability to run AI models on a device. But if any one of you has ever tried to get a model and run it on a device, especially if that device doesn't run Python, if you're talking about mobile devices or so, you probably ran into quite a few challenges. The first challenge you often run into is you have to use quite a complex tool chain to actually take a model and then convert it and understand quantization, things like that, to get it to actually work on a device. And don't get me wrong, these toolkits that we have, they're amazingly powerful. And if you're interested in this space and you know all the dials you can turn, they can give you great performance. You can take a model, you can optimize it, you can play with the quantization and things like that, and you can get great results. But it's not something that the average application developer who essentially just wants to integrate an LLM into their app, it's not something they want to spend their time on, actually. Another challenge, if you've ran through this entire process on the previous page, if you've ran through this process, you get one model that works very well on one device or a small family of devices. But there's so many different devices out there that if you want to do this, if you want to support all of these, and if you have a large user base with a diverse set of devices, you'll have to go through this process over and over again. Now, this is where our most recent announcement comes into play. 2 weeks ago, we announced the preview release of Flower Intelligence. And here's Charles to tell you more.
So yeah, Flower Intelligence, we believe this is very important to make sure that local AI can be democratized and used everywhere. Our goal essentially is to make sure that it is as easy to run local AI as it is currently to open up a browser and just go to a cloud provider. So the first step is, of course, building an open source tool for this simple on-device AI inference framework. And it was very important for us to make sure that the APIs were very simple to start with. Of course, you can get more complex if you have more complex needs. And also, we wanted to keep this compatible with current existing APIs. So, for instance, if you're running something with a cloud provider, you can just switch a single line and essentially run locally. And one very important aspect of this, as Daniel mentioned, is that if you have different platforms, it might be very annoying to switch your code in between. So we wanted to align our APIs for multiple languages and essentially make the framework fully cross-platform. One other aspect is the model support, and this is something we realized the hard way while implementing the framework, is that sometimes you might find a great model on some device, and on another device this might not be compatible, and you might struggle to find a version that works. And so we curated a list of diverse models, tested them to make sure that on all the devices using our framework they were working. And we also have some very small models and some bigger ones. And if you're still doubting the power of on-device AI, please let me change your mind with this amazing demo that you might have seen running there, actually. So this is currently running the biggest version of the DeepSeek R1 model. So in this case, this is 685 billion parameters. You can actually see, maybe it's a bit small, but you have all the RAM it's taking in memory. And obviously, so this is running over there. Feel free to test it out, to make some queries. Yeah, I think it's running pretty great for such a big model. So this shows the power of local AI. And in the cases where, I don't know, you're working on some different tasks and your machine doesn't necessarily have all the resources available to run such a big model, it was very important for us to have seamless support for what we call remote handoff to Flower Confidential Remote Compute. And so in this sense, the goal is that when no resources are available, the framework will automatically hand off, if this is enabled, to a remote server. It's all end-to-end encrypted. So because it was very important for us to keep the privacy aspect of this. And so this way, when you are working on your app, you don't need to worry about the hardware requirement or of a specific user or another. And so, yes, as a summary, this is what Flower Intelligence is. It's a local-first AI open source framework with optional Flower Confidential Remote Compute. Thank you.
Thank you, Charles. While working on Flower Intelligence, we've been working with one company that probably all of you have heard of and know pretty well. It's a company that has probably the highest standards when it comes to protecting user data. And that company is Mozilla Thunderbird. So they have an extremely high standard for protecting user data, and the traditional approach of building AI systems, just taking the user data and sending it to some third-party API was just completely out of the question and would have never worked for them to build a system. Let's hear from Ryan.
Hello, everyone. I'm Ryan Sipes, Managing Director of Product for Mozilla Thunderbird. Now, for those of you who don't know, Thunderbird is the world's most popular open source email client with over 20 million users. And as you'd expect, those users are very privacy conscious when it comes to their email data. What is interesting about our partnership with Flower is it allows us to ship AI features that respect user privacy. And that's why we're continuing to partner with Flower on the next generation of Thunderbird.
We're super excited to be working with Thunderbird. The Thunderbird team has been amazing to work with. We are together we show what a different way of building AI systems can look like, and you can actually try it out right here. Please definitely check out the demo that is on the demo table over there. So if you are also interested in working with us, if you're interested in pushing the boundaries and work with us to try out how to build different kinds of AI systems with a local first AI approach, I have good news. The Flower pilot program, batch 3, is officially open. You can apply to become part of the program on flower.ai/pilot. That's it for Flower Intelligence. So you've seen Flower Intelligence, the preview release. It's on-device AI with optional confidential remote compute. It's our contribution to in working towards this vision of making networked AI a reality. And there's preview release SDKs available already. And if you want to work with us, I can encourage you to go to flower.ai/pilot. With that, we're moving into the next section, which is about, obviously, the Flower framework. So since last year, since Flower AI Summit 2024, we had 15 releases. And all of these releases, we've been slowly rolling out Flower Next, and we officially completed this transition to the Flower Next architecture, which is a very fundamental change in the Flower framework. So with this new architecture and with all the new features that we have in place, the new version of Flower should actually be called Flower 2.0. But what we call it is not 2.0, we call it still Flower 1.17 because it's fully backwards compatible. So everything you've built with Flower 1.0, you can still run it in the version that is released today. A big effort towards getting us getting all the processes that are behind the Flower development into just a very professional state and into becoming more enterprise ready was actually to get ISO 27001 certified. So this was a process that we completed very, very recently to make sure that all the processes we have are ready and compatible with enterprise requirements. And if you want to learn more, go to trust.flower.ai. And I want to extend at this point a huge thank you to the team. The entire team has done an amazing job. When we started this process, we were told that it would take us 18 months to get certified, and the team did it in less than 3 months. So I think that deserves... So let's go into some more details about the Flower framework, and here's Javier to tell you more.
Thank you, Daniel. So we have some amazing news about the Flower framework. After all, it has been 12 months since the last Flower Summit, and the first piece of news is that we don't want to call it a framework anymore. Instead, we're going to call it platform, and this is because Flower has really evolved from being an amazing toolkit to do federated AI for any workload and any use case you might have into a really powerful platform. And now, still switching. And now it is so much easier to have multiple federated learning apps and workloads running in parallel. This is what we call multi-run. We have introduced a powerful command line interface, so you can submit your runs, see the status of your runs, get the logs, no matter where they are running on, and many more features. There is also built-in user authentication, so only those that are authorized to submit jobs to your federation can do so. And there is also different forms of node authentication, so those partners that are joining your federation, you can be sure that they are who they say they are. There is also a much improved support for running Flower in production. So we are now creating official Docker images, and also there is improved support for Kubernetes. And you will hear more about this tomorrow morning in another talk about Flower being ready for enterprise. So don't miss that. And finally, and this is a big one, we have introduced a new API that we call it the Message API. You will learn more about it later, but some of the things this enables is a new set of privacy-enhancing technologies. We have improved our differentiable privacy support, as well as secure aggregation. There is also great support for homomorphic encryption, and you will be able to see some examples on how to use it with Flower very soon. And the Message API also enables you to implement custom SMPC protocols, because the Message API is so much more versatile than what you can currently do with Flower. And of course, you can keep still using Flower mods. Many of our partners and collaborators have already been using the latest features in Flower in the recent months across multiple sectors, like including finance, with Banking Circle, health, with collaborators from Broadcounts, and of course, Mozilla Thunderbird. And you will hear more in detail about all of these and many more tomorrow and later today. Throughout these collaborations, we got some super amazing feedback that we have distilled into some components that can be integrated with the core framework in Flower. These are a bit opinionated, but we think that brings some capabilities that are really important for enterprise and pro users. For example, OpenID Connect, so you can plug your authentication endpoint, or audit log, so you know who submits which run and where it runs, and you can implement traceability features, for example. Or you can have Postgres integrated right in your Superlink. And there is one more, and I think this has been requested by many of you that I can see here, and is, yes, there is a dashboard coming to Flower. You will be able to see your supernodes, you will be able to see your runs, you will be able to see your logs, and many more features that will be announced in the coming weeks and months. And this is just a sneak preview about the Flower platform, and you will hear more about it in a couple of hours in my talk. So see you there. Back to you, Daniel.
So over the past couple of months, we've been working with one company that I'm sure everyone who's worked in federated learning has heard of. That company has been building FL system even before most people have heard about FL ever. They showed what's possible with federated learning in healthcare. And most recently, and this is where this picture comes in, President Emmanuel Macron from France even recognized their accomplishments at the Paris AI Action Summit. And the company I'm talking about is obviously Okin. So, Guillaume, come up to this there.
Yeah. Okay. Well, thanks. For the one who don't know about Okin, Okin is a company working on understanding complex biology through AI. I don't think I need to explain to you what are the application of federated learning in healthcare. We had so many great examples this morning. Okin has been a pioneer in federated learning in a way that we use in real-life research project for more than 6 years. And today, we are excited to announce that we are partnering with Flower to support us delivering federated learning on different projects. And if you want to learn more how at Okin we use federated learning on research projects, you can go to our talk tomorrow at 4:45, I think, with Hanka, my colleague, which is hiding by there. And thanks again, Daniel, for inviting us.
Thanks, Guillaume. We're super. Thank you. We're extremely excited about this partnership and to help Okin bring federated learning to even more users in healthcare and biotech. Now, I want to talk a little bit about the Flower ecosystem and the ecosystem that has been sort of evolving around Flower over the last year. As you probably all know, Flower allows you to practically bring all the tools you know and love from just regular centralized data science and then just plug them into your federated workloads. You can use any machine learning framework like PyTorch or TensorFlow, other logging libraries and things like that. But one part that sort of almost held back the federated learning ecosystem a little bit, or the adoption of federated learning, was that it was quite difficult to choose sometimes for users between one federated learning solution or the other. So ideally, if we look at the workflow that an individual researcher or AI engineer wants to go through when building a federated learning system is, you want to build your app, and then usually the first step is to try this out. This is where the Flower simulation runtime comes into play. You want to try it out on your local system or maybe a bigger simulation cluster. Now, if you want to move this to production, you'll want something like the Flower deployment runtime. In the deployment runtime, ideally, you don't want to make any code changes. You just want to take this app and move it over to the deployment runtime. Now, there's also a great ecosystem of platforms and other federated learning solutions, and sometimes you just have requirements that are better met by these other systems. So ideally, what you would like to do is you would also want to be able to run the Flower app on third-party runtime. Now, we've been working over the last year with a number of organizations, and I want to highlight a few of them to make this actually happen. The first one, as you probably all guessed, is NVIDIA. So last year at Flower AI Summit, we announced our partnership with NVIDIA. Holger was on stage and showed a very early demo. Over the last year, we worked incredibly hard to ship this. We actually shipped multiple versions of this. And you can now use it. You can use it in Flare 2.6 and the latest version of Flower, and they just work together pretty seamlessly. Make sure to check out Holger's talk tomorrow to learn more. The next company I want to talk about is Intel. Intel was one of the early pioneers in federated learning. They've given talks at past Flower AI summits. And Intel has been doing great work when it comes to standardization in federated learning and also confidential compute on Intel SGX. Patrick is here to tell you more about this in his talk tomorrow. Another fairly recent announcement we made is our partnership with Rhino. So Rhino is well known for their work in the healthcare space, but now they also work in other areas. And Rhino is helping organizations to bring federated learning really into the enterprise. There's going to be a talk tomorrow, and I highly encourage you to participate. Another announcement we made recently is our partnership with Aferis. So Aferis is a new member in the Flower ecosystem, and Aferis has been doing some great work when it comes to governance around federated learning systems so that you can safely collaborate on distributed data. Make sure to check out the talk from Chris and Jan tomorrow. Last but definitely not least is Octopipe. So Octopipe is working on FL operations, FL ops as it's sometimes abbreviated. And tomorrow Ivan is going to talk about how they integrated Flower into their system, into their platform, to use it to improve the energy efficiency of data centers. Now, with these integrations, I think we hit a very critical milestone, a milestone where suddenly these systems become interoperable. You, as a user, have practically almost infinite choice. You can build your Flower app and then decide where to run it. You can run it in simulation if you're a researcher. You can deploy it via the Flower deployment engine, but you can also deploy it and run it on top of NVIDIA Flare or Intel's OpenFL. And you can also use some of these commercial platforms that exist that give you features like governance or industry-specific features that you care about for your federated learning system. Now, a great milestone we also recently hit is the open source ecosystem around Flower is just growing like crazy. We have 2,000 dependent projects on GitHub. So this is other open source projects that have been open sourced and that are available on GitHub for everyone to check out. So that's it about the Flower framework. Flower framework gives you capability to run federated learning in a production-grade environment. And we have an amazing partner ecosystem that you'll hear more about throughout the rest of this conference. Next up is Flower LLM, and welcome Nick to the stage to tell you more.
So LLMs and foundation models more generally is where we see AI really pushing the limits of what it's capable of. I want to give you an update, therefore, what Flower and decentralized methods mean for this domain of AI. And so there's a lot of results discussed in AI every single day. It's hard to keep up. But one result that you really should take notice of and will actually probably stand the test of time in terms of what's happened in the last 12 months is a breakthrough in our ability to train distributedly, a breakthrough in our ability to have physically spread GPUs and computational resources and data, and yet still have that type of apparatus, that type of system, train foundation models and LLMs. In fact, in the last 12 months, there's been a reduction in the effort and the communications needed between these resources by a factor of 1,000. And so this is a complete breakthrough because it changes the way that we will start to build and train our models and no longer requires us to have the data and the compute all in one single place. And this is a complete game changer. If you don't think, if you don't have to trust me and when I'm saying this, let's hear from someone else. Let's hear from Jensen.
Yes, 200 to 300,000 GPU clusters are here, right? Does that scale to 500,000? Does it scale to 1 million? And does the demand for your products depend on it scaling to millions?
That part, the last part is no. My sense is that distributed training will have to work.
Right.
And my sense is that distributed computing will be invented.
Right.
And some form of federated learning and distributed, asynchronous distributed computing is going to be discovered. And I'm very enthusiastic and very optimistic about that.
And so research says that we can now do this. People leading in the field of being able to put together data centers and push the envelope in terms of compute say that we can do this. And so as a result, we're going to start to do this. We're going to start to see different forms of AI infrastructure evolve rapidly now that the brakes are off. So we can now build, for example, a network of web browsers that can literally train fantastically powerful foundation models and LLMs. We can start to see sit-at-home style efforts where we have individuals putting forward their computational resources and their own data and training models in a privacy-preserving way. We can start to see the types of distributed infrastructure able to train models based on data from cars and robots. We no longer have to live in this sort of data center-centric worldview that Daniel started the keynote off with. So now that we can do this, there's a vacuum, because we need to have the types of software, the types of algorithms in order to stand these systems up. And so that's something we've been thinking deeply about at Flower. Around 12 months ago, we showed it was possible for the first time to train foundation models, LLMs, beyond the 1.3 billion parameter barrier. And so what we've done in the last 12 months is is invest heavily on the types of support within the Flower framework in order to make all those different types of AI infrastructure feasible and possible. We've got a system called Photon. We've got embeddings called Depth. They run straight on top of Flower, and we have the beginnings of a brand new optimizer networking stack that will be offered in this calendar year. And when you put those things together, you can build all of the things I was just describing. It's completely open source. The various components of it have been peer-reviewed. It supports LLMs, but it's also entirely multimodal. There's nothing quite out there like it on the market or in open source today. It can even support various types of computational hardware. It's what the world needs to move forward. And so we've been using this already internally to test it out and to see what it's capable of. And so I'm very proud to announce today Flower LLM 1.7b. Now, we've used this software internally to build the first SOTA LLM that was trained using distributed and decentralized methods. Now, the emphasis here is it is a SOTA LLM, meaning that it has capabilities as measured that are equivalent to any other type of SOTA LLM model, and yet we were able to train this in a decentralized manner. And so most of the prior results in this space lag SOTA. They might lag SOTA by 5%, 10%, sometimes 20%. So while they converge and they work, they are not the best models. This is not true of this particular 1.7 billion parameter model. It has results, these downstream tasks when you measure, that are equivalent to the Hugging Face small series of models. And then if you compare it to more familiar models such as Llama 3.21b, actually exceeds its performance. And again, it was trained in a decentralized manner. So again, there's nothing stopping us moving forward rapidly. And that is why I'm happy to announce Flower's last partnership of this keynote, and that is with Vana. Vana is the leader in user-curated DAOs, where users can opt in and start to build their own collective of different various kinds of data. They have a membership of 1.3 million users who have created over 300 DAOs, each with unique types of data from various sources, their cars, their homes, emails, data they have personal to themselves, and it's data that you will never find in any other type of foundation model LLM. But it's the type of information, when handled properly, when handled selectively, can provide LLMs and foundation models with capabilities we've never seen before. And so in this year, moving forward, we're going to work closely with Vana to build what we call Collective One. Collective One is the world's first decentralized, user-owned foundation model. And so each user that opts into this process and puts forward their data and then trusts us to process it well will have a stake in this model. It'll be a model, again, as I mentioned, that'll have capabilities that we've never seen before, using data that's never been used to train on before at this scale. And we couldn't be more excited to work with Vana on this. And in fact, the creator of Vana and CEO of Open Data Labs, Anna, is actually going to be giving a talk in about an hour's time to explain much more about this initiative. And I'd just want to also say that, again, this will be 100% user-owned, 1.3 million users, 7 billion parameter model that will be standing up in this calendar year. So to conclude, the age of decentralized AI has arrived finally for LLMs and foundation models, and this is the way that SOTA will move forward. Flower is the choice of platform, open source, and peer-reviewed infrastructure that people will be starting to use to build up these various kinds of ways of training these models as we move forward. We've started to work with a lot more people, a lot more organizations that I have time to mention. There'll be a talk later today that will go and enumerate around this. But we have, for example, 2 different types of foundation models that have been trained using our infrastructure that I haven't mentioned yet. We've started to work with SprintDien, the German government, to stand up sovereign type of models that are such essential types of assets for countries moving forward. And multimodal support has also arrived. So there's a jam-packed series of announcements that relate to this direction that I'm happy to tell you about later today. Over to Daniel.
Thanks, Nick. So what we've seen today is Flower Intelligence is a new way to build on-device, local-first to remote compute. We've seen the next generation of the Flower framework and how it enables you to bring FL to production in a seamless way and across multiple platforms. And we've seen Flower LLM. I would just say decentralized foundation models are here. A lot of this is powered and only possible through the amazing Flower community. So huge thank you to the entire Flower community. And you'll be hearing a lot more about these topics, a lot more in-depth information throughout the rest of the conference. So enjoy the rest of the conference and see you there. We're going to a very short break now. I think I was told we ran a little bit over time, so we don't have time for questions, but there's an after-hours reception that will give us plenty of time to do that. So let's catch up after a super short break, and then we'll continue right away.
That is the keynote, everyone. Hope you liked it. It was great to see all of the speakers up on stage. We saw Daniel, our CEO, talk about different things in the keynote, about the Flower framework, about Flower intelligence and much more. But we also saw some of my colleagues also up on stage. So you had Charles talking about Flower intelligence, and also Javier talking a bit more about the Flower framework, and Nick, one of our co-founders, was also talking now about Flower LLM and foundation models in federated AI. So if this is anything that interests you, you should definitely drop, comment, ask your questions here in the chat, or reach out to us in Slack. They will be available there to answer your questions. And right now we're only having a short break, so we'll be back very soon with a fireside chat. And this chat will be great. It will have Mark Sermon and Daniel from Flower talking about anything basically between heaven and earth with regards to federated learning and federated AI. So I think this will be really interesting as well, so definitely stay tuned. There will be a bunch, they will talk about what's new, what's going on, what's about to come as well. So yeah, definitely stay tuned. We have had some people asking some questions in the chat. Yeah, I see people are connecting with each other already. It's great to see that the community is reaching out to each other and talking about their projects, talking about what they are working with when it comes to federated learning and much more. And if you stick around for today and tomorrow, you will definitely see how federated learning is implemented in the industry. So we have many researchers here today talking about, state-of-the-art research, how it works in theory, but also it's very interesting to see how people are working with it in practice. And we are actually going live soon again. The fireside chat is coming, so 2.5 minutes. Don't go anywhere. There's much more to come. We have people from industry joining in, probably asking questions. And if you are one of those here online, you can also ask your questions here. So just drop them in the chat. Feel free to reach out to us in Slack as well. If you haven't, you can just go to our website, flower.ai. Where you will find a link on how to join our Slack channels. There is a specific one which is called Flower AI Summit 2025, where we are, answering questions. We are putting up questions for you in the audience as well. So if you, go there, join our Slack, you'll see much more content as well. Yeah. And then we, of course, have our social medias like LinkedIn and X, and you'll see other people interacting with us there. There are some teasers and posts that we do throughout these 2 days, so make sure to also check what's going on there. But of course, this is the main event, and we are live streaming live from London. See what is actually going on in the room. You see people are moving around. We had our lunch break There were some people coming in here still eating but wanted to chat. And I'm sure this break is quite short, but we'll have a couple of other ones when we get some people down here. We'll make sure that we talk more about state-of-the-art federated learning in practice, in theory, answer your questions. So if you have any, just go ahead, drop comments in the chat, and we'll make sure to reply to them. And for you in the audience, is there a specific industry, data type, model that you would like to learn more about when it comes to federated learning? Maybe it's about how you get started with it. You have, as I said, we have our Slack and things like that. But yes, feel free to ask whatever you have on your mind. Put it in the chat and we'll make sure to answer. We are about to resume the fireside chat. So we just had our keynote speakers up on stage, and now we'll have a fireside chat. And it will be great. A lot of new things to come, a lot of things to be discussed, and you will maybe see some announcements as well. So definitely stay tuned for more. We have some people coming in here. I think we're going to the fireside chat soon, so I'm not sure. Sorry? Say again? Okay, yeah, then we have someone to chat with. Please come in.
Okay, hi.
Hi, just had to make sure that we're not going on a break. Hi, William.
Hi.
Nice to meet you.
You sent your message.
Yes, you chatted with me. Let's see, where's the other microphone here? It's somewhere on the side. There we go.
So it works, I guess?
Yeah,
it works.
Here, of course. Yeah, it works. Okay, so you can see us there, but there's the camera.
All right.
So, yeah.
Okay, yes, okay.
So how are you doing?
Very good, very good. Yeah, great. Yeah, enjoying my time here.
Yeah.
I think you did a great job.
Thanks.
Organizing a lovely conference.
Yeah. Did you like the keynote speak?
Yes, of course. Yes, definitely. Nice to see how Flower has developed over the years.
Maybe tell the online audience a bit about yourself and where you're from, what you do.
Yeah, definitely. I'm not sure to whom I should address it, but maybe I can tell you.
Yeah, that's fine.
I'm a postdoc at the Vrije Universiteit Brussel. So I'm working actually also on federated learning, but for brain imaging and multiple sclerosis. Mm-hmm. So I'm trying in my postdoc to create models that predict cognitive impairment from structural brain images, and actually trying to develop a tool that when patients come in for an MRI assessment, because they are followed up on a yearly basis, whether we can make some kind of triaging system in saying, okay, this person is at a high risk of cognitive deterioration and should be followed up more intensively, for example, by a neuropsychologist.
Definitely. Yeah. So we have a lot of speakers from the medical and healthcare industry here today, so we'll definitely chat more, but right now we're actually going back to the fireside chat. I hear someone speak here.
Okay, yeah.
So we'll make sure to talk more about it, but let's get over to the fireside chat for now. Yeah.
Okay, great.
Thanks for having you.
Thank you.
Sorry about that.
No worries. Thank you.
We have a fireside chat, and I would like to welcome Mark Sermon to the stage. Mark is the president of Mozilla. And Mark and I, we had a number of really good conversations about where we see AI going, what we want from the future of AI, what are things that are happening that are maybe not going the way they should go. And maybe we'll just start with that topic. So Mark, I know you thought a lot about this. What is, maybe just as an opening question, what are some of the things you are currently, you see that are happening, and what are some of the opportunities you see to influence the direction that AI is going for a better outcome in the future?
Thank you, Daniel, and hello, everybody. I guess first you got to think, what's the better outcome in the future? And there's a couple angles I might take on that. And certainly the future, I imagine, is networked. And you set that up really, really well. But not just networked or not just decentralized from a technical perspective. As a technical organization or two technical organizations, sometimes you think about that first. But why do you want things to be decentralized? And I actually think at this moment, really one of the things I think about in terms of a better future for AI or for society, for our economies, in terms of what we might imagine, is a networked or a decentralized digital economy. And sort of what do I think about that? When you think about the companies that are the mainframe AI companies, they're mostly on the West Coast of America, big tech companies, incumbents in the internet space, or in China. And they're building on this mainframe model. And I think one of the things that has struck me for a while, there was a Time magazine cover, I don't know, maybe it was even a decade ago, 6-8 years ago, of Mark Zuckerberg wearing this, like, kind of as Caesar sitting on the throne. And whether you think about the Roman Empire or the British East India Company, the Dutch East India Company, those companies are actually as big, the 5 big tech companies, as those colonial empires in their economic power and their reach. And so, what does that mean? Taking away the really abusive parts of that, it means that all the money goes back to the center. And so that's really, to me, one of the core metrics of, like, what is a better digital society, digital economy, is the money is more distributed. The opportunity, the benefit are more distributed. And I think that's what I'm looking for. And I think then you need the architecture for that. You need the architecture that lets the data stay in places, that lets startups be everywhere, that lets research be everywhere. And that's really the vision that, Mozilla has.
So there's a lot of things to unpack, obviously. I want to start with one of the things you said early on, and that is, it shouldn't be decentralized just for the sake of being decentralized. And I think that's quite a key thing to understand, and I fully agree with that. I think part of this is. In the end, the decentralized model of the web worked and won over the previous mainframe era because it offered more value to users. It gave users what they wanted, and through that it got adoption, and through that it was the winning model. So for AI, going forward, part of why I'm excited about the decentralized nature, the decentralized capabilities that we have now, is that it allows you to build new kinds of systems. So Thunderbird is a great example, actually. For Thunderbird, I think the traditional model of just sending data to an API would have never worked. It was just out of the question. What are some of the opportunities that you're seeing where, by building a decentralized system, we can offer better value to users?
Well, it feels like a weird thing to ask me those questions, in the sense that you had so many good examples in the opening, although one of them was a Mozilla example. But I think at the core, I'm going to go back and keep making fun of Silicon Valley big icons. But I think there was Eric Schmidt was the one who said a while back, like, privacy is dead, like, give up, basically. And I think that is not obviously our point of view, and we have to reinvent what's the value that we want as individuals, what's the value we want as our communities, as our families, as our societies from privacy, and, like, how does it work? And so I do think that's actually one of the key things, is, like, what do we want from privacy? And then I think some of the things you talked about in that collective one, which is a really exciting example, are that, right? Something where I don't have to kind of totally expose myself, or in order to get something that really is trained on data that isn't out there in the world, and is trained on data that is me, and that actually. And you certainly could get that in Thunderbird, or in something that is local and just specific to me. I could be fine-tuning, or however you want to call it, on myself. But then to go further, like, can I contribute to that and get value back from it? That's what's exciting about, the kind of DAO model, or some other piece where you're going to data that I never want to disclose on its own. But, like, my community is in that model, or my family is in that model. And so I think things that are customized to me, but that'll let me kind of be me and be private, I think there's a lot in that. There's many other examples, but that's the obvious thing to me.
Yeah, I think it's spot on. I think for especially now there's a lot of talk about agents, building agents that work for you, and a lot of the code examples you see in the wild, they still use models that are sitting behind an API. But then the types of tasks that these agents could perform, the types of tasks are fairly limited, because an agent where the model sits behind an API that is not under your control, that is under the control of someone else, will always have just a very limited view on who you are and your types of data. So I think a local AI model, you can just expose it to so much more data, and then you can fine-tune it, as you said. I'm quite excited to see what will happen with local AI models in that area.
I guess, to challenge it, but then, play around with it in some different ways. It's not true that behind an API model isn't going to necessarily know all of those things. In fact, often we disclose way more than we want or know. And I think the trajectory of the mainframe model, or even in terms of as we go to agents, is there's a set of very large companies that do have all our data, and that we disclose more and more and more and more, and that people don't care. And that's certainly not the future I want. But just to challenge, I'm nitpicking with you, but I don't think it's guaranteed that the future is that as we have agents, and we will automate more and more, whether we call them agents or not, that world is coming. It's not guaranteed that will happen in a way that we have agency. And so, it's actually kind of funny that's the word is agents, but the idea that we have control over it, that they actually are agents acting on our behalf, is really not at all guaranteed. But I think it is buildable, and that is where I do think local comes into it, but not just local. I think we're going to need trusted parties. Mozilla hopes to be one of them. We don't know how to get there yet. And maybe, I don't know if Flower will get into this business or is just the rails of it. But, we're in a world where already, even without things we call agents, we're moving through digital spaces, and we have thousands of counterparties that are hammering at us or taking from us all of the time. And really, we don't have the cognitive abilities to be negotiating with them. Certainly we click cookie boxes all the time, but that's just like an infinitesimal part of what decisions are getting made about us and with our data all the time. So I think there's a piece about local, but there's also going to be a piece about, which is where the DAO stuff is kind of one example and interesting. How do we build kind of trusted partners to us to move through those automated spaces when we're not cognitively engaged with them, to know that the thing actually is on our side, to trust that it's on our side, to trust that agents are under our control, because we're not going to be actually aware that they're acting all the time. And so there's just a tremendous amount of trust that we're going to have to build in ways that I certainly would not want to offer to the mainframe companies of today.
So if we look at the history of Mozilla, Mozilla has already contributed in an incredible way to one of these transitions. Mozilla, I think the web that we all use and know today would look very different if it wasn't for Mozilla. So Mozilla has this track record of influencing technological transitions in a very positive way. I know that Mozilla is very active in AI and does a lot of things. How do you think Mozilla can best contribute, given the experience, to this new transition that is happening now?
Well, I think part of the answer, I'm here in this room to help find that out, because we don't know all the answers. And, people may not know. Obviously, you guys know because we work with you. One of my jobs, I guess my main job in the last few years, has been to both bring Mozilla into the AI era. We talk about how could we do for AI what we did for the web, and I wasn't there in the beginning, and I think we were both, the people who were at the beginning were both smart and lucky to be able to kind of break things up and bring standards to the fore in terms of breaking Microsoft control. But it's not actually obvious how we do it again. I think we do need to do it for this era because AI is the sort of as everybody here knows, the kind of fabric technology of how things get built today. And it is in that kind of mainframe concentrated model. I would say that the things we're trying are certainly to try to turn Mozilla into a more AI native organization. So we just spun off just a couple years ago. It didn't work the first time. We have a new CEO, a separate Mozilla AI startup. Their job is really trying to help open source AI adoption. So the thesis there is really, everybody who's doing open source AI, we want that ecosystem to succeed. And we want to have one arm of Mozilla that's really focused on that. Imagine it maybe being something closer to like a Red Hat or an Ubuntu of really accelerating and making it lower friction to adopt. But the other thing that we've done, and I don't know if that one will work, is our belief is we may not invent the Firefox that breaks things out. And that's why we set up Mozilla Ventures, and we've invested in Flower and a bunch of other interesting AI companies. So I think part of the answer is building as many founders, as many nonprofit labs, as many anybody building stuff that is aimed at this decentralized future and this open source future as possible. I mean, I don't know any other way to try it than have a vision of what's different and help as many people try to move there as possible.
And I know part of the vision of Mozilla is this concept that is called public AI. For those parts of the audience that haven't heard about public AI, could you maybe just give a brief intro?
Well, my guess is nobody has heard of public AI because it's a very, I'll say a little bit more, but has anybody know what we mean by public AI? I bet you nobody does. Oh, wait, one person back there. Oh, a couple people. Oh, that's not bad. So, I mean, really it comes from the idea that we believe there needs to be something different than the Silicon Valley big tech model of AI, which is mainframe in its model, but also is a particular set of owners, a particular set of incentives, a particular culture, and the Chinese model, which has also got its own particular versions of all of those things. That there really needs to be a third stack. That needs to be an open source stack at its base, but it's not open source in its, as an end in itself. It's open source because we really believe there needs to be, a set of common public goods, whether they're data, whether it's open source software, whether it's methods, all of those things, standards that anybody can build on. So if you go back to that idea of the vision for AI we have is really a decentralized economy, of digital economy where anybody can benefit, where you can control your own data. You need a system of public goods, basically, the equivalent of roads or the equivalent of the open source software stack that people can build on. But of course, it's not just the same. It's not just continuing the open source software stack of the last 20 years. There's kind of got to be a different architecture for it because you have data, because you have compute, as well as software and models. And so public AI is trying to be a vision. Maybe it's not the right name. We're kind of looking for the right name for it, of some set of public goods owned in common that allow all of us to be able to kind of have agency over where we take the AI era that isn't beholden to Silicon Valley or China.
And would this be something that's mainly driven top-down by governments?
I think you're asking a leading question. Oh, maybe not. Maybe that sounds like public. It could sound like top-down by governments. That's true.
Or is it more of a grassroots effort by community open source believers?
I think for me, it's both. Different people have used different versions of this phrase. So there's an idea that's been floating around. It was talked a lot about in the Paris AI Summit of an Airbus for AI. And so, if you think about that, in some ways, that's a compelling version of what I'm talking about, which is, the Europeans said, well, we don't want to just let the Americans control the aerospace industry. We're going to pool our resources and we're going to build a counterpoint. And I find that compelling. As a Canadian, I hope it wouldn't just be the Europeans who would build an Airbus for AI, because we need to band together with you in many anyways these days. And actually, I think you could imagine you have amazing labs like the Allen Institute in the US. I mean, there's a lot of even American players who I think can plug into this vision. But that, I think, that is really, that play is oriented towards something a little bit more top-down, how the people behind it are thinking about it. I think something like that, because that's something that would be about, say, taking government compute labs and investments across all of whatever regions are involved and coordinating them, maybe through federated learning. I think you also need to have that be something that's driven in a very bottom-up way by startups, by open source projects, by researchers. And ultimately, that's where open source is an output. But more importantly, as I think happens in open science and in good technical communities, open source is the lingua franca of things adding up or of innovation happening. So that by its nature then becomes more bottom up because people just talk to each other by making things and by them being available under terms that allow them to fork them and use them and all those things. So I think it could be either. I think you need both.
So you mentioned open source quite a number of times, and there was fairly recently, or more like last year, this debate of open source and safety. So some people, not all, but some people argue that open source is actually quite dangerous as these models are getting better. What's your take on this?
Well, I mean, when you say it was last year, I think there were some things that were really peaked about it over the last year or two, but it's still going on. And of course, the critique is, and you saw it if you looked at the AI summit that happened here in Bletchley Park, whatever that was 15 months ago or November 2023, a real fear that open source AI is going to be the thing that's going to cause global terrorism to rise and all the bad things will happen. And, the only way to safety is the mainframe model. And our critique of that, and I think things have swayed dramatically back. If you look at all the open source stuff at the Paris AI Summit, our critique of that is it really was the big American companies who are using that safety argument as a moat to protect themselves and to kind of create a regulatory wall around themselves. And us and many other people, Hugging Face, many people made, I think, some good arguments in the U.S. policy environment, including stopping an AI bill that really would have been bad for open source in California last year, saying there really isn't a marginal risk or a dramatically different risk between open source and closed AI models in terms of bad actors are going to act badly and they're going to find ways to abuse these systems. There are some things that, though, really when you look at the researchers who've looked at, are worse with open source. So I think especially around CSAM and deep fake sexual images, that open source lends itself to certain kinds of abuse more. Our kind of view on that is, the same as it would have been in a previous era of open source. The transparency is the best way to fight that kind of abuse. And so there's an amazing thing that was launched at the Paris AI Summit called Roost, the Robust Online Safety Tools. I think that's how the acronym works. But basically, it's sort of big tech grade, sort of Facebook grade, trust and safety tooling, including AI, that is open source. So if I have a startup or if I have a research project, I want to be able to do things like make sure I'm pulling CSAM out of my data sets, that's available through a set of either open weight models, because you don't actually want to see the training data for that stuff, or is available as open source software tooling around it. So I think that it's wrong-headed and self-interested. Most of the people who are arguing open source is more dangerous. And B, open source, as has been the case in cybersecurity, is actually the path. Transparency is the path to more safety and security, if done right. But, you have to invest in the right software and tooling for that and use it.
That's true. So we talked about open source, and I think if we look at open source in AI, there's a couple of things that are related, often commonly referred to as open source. There's open source in terms of open sourcing the code. There's open weights in terms of just publishing the weights of a model. There's also things like open data. So if we look at all of these, and if we consider we're at the conference that is about federated learning and distributed LLM training, do you think the definitions we have today they're a good fit for running models in a decentralized way and training models in a decentralized way?
Yeah, it's such a good question and such a tricky question because, I mean, you didn't refer to it directly by name, but I think you're kind of hinting at it is, as happened 20, 25 years ago, there's a lot of, 20, 25 years ago, there was a lot of debate on what counts as open source. You also had the free versus open and all of these kind of debates that in my early career made me want to blow my brains out. But really, it took a while to kind of get agreement that the open source definition that the open source initiative has would be the thing that says this is open source, this is not. And I think we're in a little bit of that spot, but it's much more complex right now. It is helpful, especially because we're talking about how do things like open source interact with law and regulatory frameworks to have definitions we can rely on. I mean, I use the term open source AI pretty loosely just because people know a little bit what you mean, but we need more precision in that. So the open source initiative has been working on an open source AI definition that talks about sort of the elements you mentioned, right? Is that the code, whether that's like the pre-training code or things used to build the system or orchestration or fine-tuning, whatever code is there, that needs to be under an open source license, that the models need to have open weights, and that they at least need to have description of the data sets, if not the actual data sets themselves. It is an interesting question. Those things are pretty understandable. There's not actually a lot of models that actually go, or AI systems that kind of in the LLM space that go across that whole definition because, say, in Llama, there's no information about the training data really, and we know there's lots of problems with it. There's a few, like the AI2 OLMA models have open data sets. So I think it's an understandable and good definition. And like when you and I were talking the other day, it kind of breaks when you get to federated learning because part of the purpose is that you don't actually want to know much about the data. And so it is a really interesting question. I think of federated learning as being something that is actually a real boon to what open source can be, especially open, when the technology is open source. But I haven't really thought, and I don't think, talking with the OSI people, how does that break or work with that definition? Because the purpose is to have the data be sort of more unknown and in many ways even undescribable.
And I think there's also an interesting connection to what you were saying earlier about economic opportunities. So one of the questions, we build a lot of open source, and one of the questions that even we sometimes get, well, if you just give away the code practically, then is there even an economic model that you can build around that, and can you sustain that in the long run, and how does that work? So if we think about a more decentralized infrastructure that is open source at its core, I think we all agree that it should be open source at its core. Do you think there's still economic models possible, and what could these look like?
It's really interesting. Well, just like people were arguing over what is open source 20, 25 years ago, people were wringing their hands of how could you give it away for free and make money? And of course, lots of people have made money on top of open source, or people more often than not who have made money on other things have contributed back to open source because it adds robustness and lowers the cost of what they're doing. I mean, you can critique the level of corporate control in the Linux ecosystem, but also it is robust and evolves because of a lot of people are making money on top of having a robust infrastructure that the whole industry shares. And so I think we will find those ways. And what's actually nice, the woman who was interim CEO for Mozilla AI until we haven't announced the new CEO, is why I'm not saying their name, but it's somebody who's kind of well known in the research world and has run a successful startup. So I'm very excited when we announce that in the next few weeks. But we had an interim CEO there who was formerly the CEO of Canonical, the Ubuntu company, Jane Silber. And, she's always really good at reminding me, there's 5 ways to make money on open source, don't worry. And they're not that complicated, right? It's like SaaS, it's like enterprise services and so on. So, you can just see it in what you guys are doing is you're going down the obvious paths. Probably people who have startups in here, it's the same things. I mean, there's only a few ways to make money, and people make money.
And I think one angle that I find interesting, we've had a lot of analogies with the history of tech today. So one analogy I find quite interesting is the internet itself is also based on open standards, TCP/IP, HTTP, and plenty of organizations and individuals found great ways to build commercial models on top of the internet. So I think the same is definitely possible for AI. Now, I want to leave plenty of time for questions from the audience also. Maybe just one more question before we go into before we open up to the audience, and that is, you mentioned privacy. So, what would you say? What are some aspects about privacy in the age of AI that are important to understand, and what's a way to define privacy in the age of AI?
I don't know how we do that with 12 minutes left and have the audience questions. But the Mozilla Manifesto, which people probably know, we have a manifesto which we use to make decisions about what we're doing, talks about privacy and security being, non-negotiable, not optional. And so that is central to who we are. And actually, I think our interpretation of that over the last, let's say, 5, 10, maybe even 15 years has been overly conservative, or at least not adaptive enough. And so, Mozilla's privacy commitments really have come from building a product that, as all the other browsers were integrating with other services, just didn't integrate with anything else, didn't collect any data about you. And what it meant was we didn't actually follow where users wanted value. And I think as we start building out AI features, we need to figure out privacy in a different way. And so that means looking at federated learning, looking at differential privacy, looking at secure execution environments and trusted enclaves. And so I think starting to look at places where the definition of privacy is not no data. And I think Mozilla for a long time kind of got in the idea that privacy means no data, but you can't do computing today with no data. And so I think, it is looking at, in many ways, not questions of no data, but who controls and who can see and who can use under what terms all the data are. But I think this is a group of people who is actually far deeper and far more advanced actually than Mozilla in thinking about what could privacy mean now. And that's the conversation going forward.
Absolutely. So now we want to open it up to questions from the audience. So please feel free to raise your hand, and then we can pass you a mic to make sure that also the online audience can hear you. There's a question over there.
Hi. First of all, many thanks. Is Mozilla as an organization considering using things like homomorphic encryption to be able to provide, the new kind of AI-powered features with very strong privacy preservation?
I mean, it's definitely something that we've started to look at and talk to also companies who are working on it potentially to invest in. I mean, it's not my area of expertise, and as I've looked at it, it's not ready to be deployed in a kind of a many hundreds of millions of users environment. But anything like that, which again, it's all the things I just listed a minute ago, whether that's homomorphic encryption or blockchain stuff or new things that we don't know yet, that's the stuff we're watching and need to adapt too. And I think, I guess, the other thing that we're having to push ourselves to do is just build a new community and a new set of relationships, because the open source community around Mozilla historically is not the set of people who are in this room who are kind of tackling those things. And so one of the things that I'm really interested in is how do we build that new set of relationships, so as those technologies evolve and get more ready for prime time, we can use them, or maybe we can even contribute to them.
I think there's a question here. That was first.
Hi, thank you very much for the conversation. I want to pick on one of the topics that you mentioned, which was how nowadays we already interact with so many stakeholders online, and as we move towards more decentralized AI and more democratized AI, right, where everyone is developing AI tools and using data from other people to do this, how do you see the challenge of explaining intent, right? Even in the basis of, okay, I want to do this project, I want to convince people to, be it through a DAO, be it through open data systems, whatever they may be, to give me their data. How do you think this can be explained throughout, right? In terms of not only just explaining what your project goal is, but also how what you're technically doing is actually achieving that goal, right? And it's something sometimes even you as a developer can't be 100% sure, so how you convince people to actually work.
Are you asking about how a developer convinces people of intent, or how I have intent as a user using agents, or both?
It's kind of both, because both developers trying to, get access to data to build an AI model, how do you convince people to actually donate to you or share with you their data?
I mean, I think there's a million answers to that, but kind of two categories of things that come to mind. The things you can do now, which are kind of easy and hard, but are kind of involve a explicit cognitive process that I'm aware of, and a explicit communication. So, that's where having high trust and a clear value proposition, or at least clear intent, can work in that way. So if you think about those million whatever people in the Vana DAO, like the developer has said, here's a value proposition, somebody has made an explicit choice and gone and done that, or we have or Wikipedia is in some ways an example of that, or we have a thing called Common Voice, which is voice training data where people donate voice snippets and then do the tagging of them to create more voice data sets. So I think there are ways to kind of look at explicit value propositions and and in some ways those are really important in many ways, but in some ways those can also help us learn about the anthropology of the trust relationships of figuring that out. But then I think what you're asking about, or what we're all grappling with, is like, how do you do that at scale all the time without knowing? And that is the really tough problem. I mean, it's the big UX problem of living in this society, and mostly it's going very poorly. And it is where I think the people who are thinking about things like data trusts or things like DAOs are interesting people and be ahead of their time. Probably it does involve some version of institutions and not just individual responsibility, because we have huge, in fact, the biggest, wealthiest institutions on the planet as the counterparties to us. The idea that in some ways we should unionize or choose what unions we're in some ways to have counterparties to those agencies that we trust and have some kind of a fiduciary relationship with. I think something like that maybe is one of the solutions to it. But yeah, I mean, it's a very big, hairy question.
I think it's also part where open source is at a huge advantage because through open source you can build trust, and even if you as a user maybe you don't go into the source code, you can trust that if the user community is big enough, probably someone else will. I'm a Firefox user. I've never looked at the Firefox source code, but I still love that it's open source. I think there was a question over there earlier.
Hi, thank you for the talk. So I know that you said that people were
recently scared of open source, and I think it skyrocketed with the XC utils Backdoor. So I actually work for Canonical. We luckily were not impacted by that, but I think it was a meaningful thing to happen for us to learn more from that. So how do you think that the AI world can learn from that and, like, take a lesson from what happened and make people trust it again? Because, like, I had many conversations after that said,
and what was that? I just didn't hear the thing you said.
Yeah, for the XC utils, the backdoor that happened.
I don't even know what happened there.
Oh, okay. So yeah, it was a backdoor attack that happened on the XC utils package, and yeah, it was pretty critical, and many Linux systems were impacted, and yeah, so like it was a commit in the code that was planted, and nobody actually took a look at it, and yeah, it was giving backdoor access to everybody, and it was right there. It was in GitHub. Everybody could see it, and there was no action taken to prevent it. And when they found it, it was already too late in some cases. And this is good and bad for open source at the same time, because like the bad thing is that it happened, it was there, and the good thing is that it's already there. We can exploit it, and we can see it, and we can prevent it with good.
I mean, I think that's there's two answers. The second part is the answer that has always been there, and I think in whether or not it's like security or other abuses is the advantage of open source. It's just what you said, is that so many people have mutual self-interest in finding a mitigation, and there's transparency that even if it was missed for so long, like it's discovered probably before, if it was hidden inside of a not known in some proprietary system, that abuse can be there for much, much longer, right? I mean, and so I think that's partly just the collective mutual self-interest of open source, and critical infrastructure is our, there's always going to be bad stuff, but it's our best hope. But I do think it kind of goes back to many different things with like smaller libraries that have been exploited, or broken down in the last decades, is like, how do we actually, Linux is actually, I think, in a better position because so many wealthy like companies or everybody relies on it. It's when you actually have 2 or 3 developers who are doing something that's critical. And I still don't think we've found the solution to that. So there is something about open source economics that is a weakness that we still have to work through as a community.
I think there was a question at the far end of the room, and then also here later on.
Thank you for a very interesting conversation. So in the AI world, I've noticed that there is a lot of conversation about why technology is faulty, but not the people who are developing it behind it. What percentage of time, efforts, and resources does Mozilla invest behind behavioral research and sociological research behind AI development? And what are the specific initiatives that you are aiming to drive forward to enable safe people doing these things rather than blaming technology for its faulty outcomes?
The amazing question, and the answer is not enough. But certainly, one of the things that I started in trying to move us into the AI space was the foundation, which owns all of the Mozilla companies, but also does its own philanthropic and research work. There is a lot of our fellows and other things that we invest there. So that's, I don't know what percentage I could do it between all of the different companies, but about $30 million a year is much more on the social research and to some degree activism side. But where we don't have enough yet, almost nothing, is as we start to build out the product and R&D capabilities, we haven't really embedded that as well. It's certainly something I'm a champion for, but it's very embryonic and not a place where I could say, it's this % of resources. It's not enough.
Thank you.
So I think we're at time, but let's make just one super quick question.
Saying 000 here.
Yeah, I think there's a narrative in the
AI field, like kind of outside of this specialized area, that countries and regions that regulate the data and AI, they shoot themselves in the foot. And I think that also causes a lot of capital to not be invested in those regions. Like everyone would bet on a US AI company, but not necessarily on an AI company based in EU. How do we change that narrative outside of this area? Like, do we need a DeepSeek moment happening maybe from Flower? Or like, how do we get out of this narrative?
That Daniel and I are trying to find that DeepSeek or that AlphaGo moment. So if you have ideas how to get there, but I think we do need some of that to shift the imagination. Certainly, our view, but we're more a part of this world than the other one, is there's economic opportunity in balancing. I mean, it kind of goes all the way down to the last question and regulation, balancing human interest and societal interests with, private interest, and that, a healthy system balances those things, and there's money to be made in having healthy systems. And Mozilla Ventures, it's a reason we're invested in companies like Flower. So I think one thing is to shift the narrative and show what's possible. Maybe that is through Flower or people in this room. Another thing is actually to shift where the investing is. So increasingly we find another set of more responsibly focused venture companies as we build out Mozilla Ventures and try to bring them along. So part of it's the public or industry or government narrative. Part of it also is really just shifting the investor mindset, and it's something that I'm interested in seeing how we can do.
From the Flower side, I can only say we're working on it. So,
and we're trying to help.
So, Mark, thank you so much for joining us today. Very interesting, and I think there's a lot of threads that we need to continue. Unfortunately, we're out of time now, but I encourage everyone to just bring up your questions. Join us later today at the after hours reception.
I will be there. Okay, thanks, Daniel.
Okay, so we'll be making a fast change here to transition to another talk. Then we'll have our break. You heard earlier about Flower Intelligence. We need to know more, I think. It's a fantastic type of technology. It deserves a more detailed deep dive. And I can think of no better person to tell you about Flower Intelligence and how it revolutionizes how you're going to serve LLMs moving forward than Flower's own Charles Bouvier.
Thank you, Ron.
Working before, it's just you just hadn't selected, just get extended. Yeah. Can you just come here?
I'll just mirror.
You get going and
I'll just mirror it and.
This is the one from.
Oh yeah, this is the problem.
That's okay. I can also just mirror.
Yeah.
Should I
If
just
you
mirror?
go slideshow.
Yeah. But it's just on this.
Yeah. All right. Go on, you get going.
I'm just gonna choose. Yeah.
There you go.
All right, sorry about that. I think we can get going now. So I will talk about flower intelligence again, going a bit more in depth compared to the keynote we had before. Perfect, it's finally working. All right, I wanted to connect the laptop so I could share a quick demo at some point in the presentation. But before we do all that, I wanted to start with just a single number. So a very large number. And this is a very gross estimate of the number of requests made to LLMs, essentially, just to run inference in a year. Some online would even use this estimate for requests made in a single day. But the gist is that it's massive and it's getting bigger and bigger. More and more people either use services directly or integrate LLM APIs into their apps. And so we can ask ourselves, how are those LLMs run? And the first, most obvious question is probably some cloud providers. So I've put some there. I think we probably all used at some point some of those providers. And the way they work is basically they have those servers, and you, the end user, you're going to send your data to the server from the provider, and then hopefully it will work and you will get some response back. And this is great. As we saw, it allows to run massive models with very quick response times because they have very beefy machines on the server side. But in many cases, this is actually not possible because you have no privacy. And in some spaces where, for instance, you have sensitive user data, or you're inside company or an organization that's not willing to share their data, this is just not feasible, and you're stuck with bad working solutions because you cannot share your data. And also, some other disadvantage is that you get actually less reliability because the server can go down. This kind of message probably already happened to some of you. And also, if you have no internet, then you can just not do anything with your model. So if you're, I don't know, in the plane or in a train, you might not be able to run your models. And so this is where local AI comes in. And so in this paradigm, the data is already on the machine. And then you also once you have the model on the machine, you can just run, and this is beautiful because it's private. The data doesn't have to move. And also, once the model is downloaded, you can just run without any Wi-Fi or connection to the internet. So one thing that's great for local AI is that models are getting better and better. I've just added a few there to highlight the recent developments. And this is really in the span of only a month. So this is really exciting about the future, especially because on the other side, in terms of hardware, this is not very visible, but the gist is that the amount of VRAM in end-user devices is increasing exponentially year over year. So this is all very exciting for local AI. But unfortunately, there's one thing that's stopping mass adoption for local AI. And if we go back to this example of cloud AI, this is very simple. We only make a single request. We do have to share our data, but it's very simple for the device. And this can be a laptop, a phone, or even some embedded devices. And this should work without any issues. But as soon as we move to local AI, you have many steps where you first need to download the correct model that's compatible with your actual device. Then select a runtime that's also compatible, install some dependencies maybe. And the painful thing is that this might be different for each device you have. And so this can get very complicated very fast. And this is also what Daniel showed earlier. So those libraries provide amazing functionality for advanced developers, but many of the people building apps for end users don't necessarily want to care or spend a lot of time on those details instead of working on the actual functionality or the value proposition of their app. And so you also have to replicate this for each device, and there are different hardware constraints. And so we believe that this is what's really stopping local AI from getting bigger and really for the adoption to be there, because I think we see a lot of new models, some hardware coming out, but then on the software side, it's not really catching up. And this is where, if we kind of recap what we have, cloud AI is simple and device agnostic, but it's not private and not always reliable. While local AI is private, highly available, but then it's very hardware dependent and very complex to deploy. And so the main question is, what if we could have the best of both worlds? And we believe that this is what Flower Intelligence can allow us to do by providing an open source on-device AI framework with confidential remote compute. So the goal is to be fast, powerful, very simple, private, highly available, cross-platform, seamlessly integrated with existing applications, and open source. And so we believe that with Flower Intelligence, we actually check all of those boxes. And so this is similar to the example I showed earlier during the keynote, where you can see that this is very simple, and most important, this is available for different platforms, because we believe that in order to be widely used, it needs to be able to run on apps on different devices and OSs. And so about the seamless integration that I mentioned. This is the code for cloud AI, so using OpenAI. And if we want to switch to flow intelligence, it's actually a single line change where we just instantiate the flow intelligence instance, and we don't even have to provide any API key. So just again, this was very important to us, but because we believe that many developers might have already developed complex apps, and they might not want to change all their code base to be able to run local AI. And again, going through the list of supported models we have here, we try to have quite a few, the goal being that they're all compatible on different hardware. That was the tricky part for us. And we also, I feel like I'm doing the exact same thing, but just to show the power of local AI, here's the demo of the demo of DeepSeek R1 685B running locally. I hope you have had time to look at it over there. And play around with it. But yeah, the video froze. Well, that's good, because I'm not going to show it in its entirety again. And coming to confidential remote compute, as I mentioned earlier, this is a very important feature for us because it really allows to reduce the utility frontier between existing apps and hybrid apps using local and remote. And so we want to provide a very seamless way for people to train locally when they have enough resources to do so. And once, they consume too much RAM, for instance, instead of just shutting down or crashing, you're able to still have a successful request, but it just goes through a server fully encrypted. And this is, of course, optional because in some cases, again, even if it's encrypted, it adds some new trusted party. So this might not be possible. So this can be disabled. So it only runs locally. But then you might get some errors if you don't have enough RAM, for instance. And we really believe that this will push the adoption for more local AI and more networked AI, as Daniel mentioned before. So yeah, I just wanted to highlight the fact that this is already out. So you can already check out the different SDKs that we have open sourced. And also the documentation. So this is at flower.ai/docs/intelligence. There you will find different steps to install and then run some basic examples, guiding you through more and more complex examples. And I think this is time for me to show a little demo. So let me... All right, so I have this web page here. And this is running Flower Intelligence. Here, I'm just running Llama 3.2b, 3.23b. And I wanted to ask, who is Albert Einstein? Let's see what I get. So this is currently local. And so we'll get a response from the model, probably what you'd expect from an LLM. And the beauty of this is that, so I'm currently connected to the internet, but I can actually remove my Wi-Fi, and I have no Ethernet cables. And then I can ask other questions like, he go to school. And this continues working because that's essentially the beauty of local AI. All right, I also had demo on iOS. I think we'll be a bit short on time, but feel free to come see me, and I can show you all the beautiful things we've built with Flower Intelligence. One very important thing is that if you want to actually try out the Flower Confidential Remote Compute, this is currently in closed beta, so you need to sign up to the Flower pilot program. And through this program, you can also get some support from our team, and we can help you build some amazing projects. Yeah. Last thing, but not least, I want to welcome to the stage Andre, who is part of the Thunderbird organization.
Hey everyone. So we started building some services recently because we noticed that a lot of our users are getting dissatisfied with big platforms like Gmail and others. And certainly part of the conversation almost immediately was LLMs. And of course, we looked at the big platforms, and we could have put an input box for ChatGPT on things and hope people used it by accident, but that really didn't seem like what was in the best interest of our users. So then we started looking at, doing our own infrastructure for deploying various AIs and LLMs. And it's a lot of work, and we discussed doing our own kind of confidential compute, doing on-device computing. For a small team trying to build several products at once, it was just more than we could handle. So partnering with Flower allowed us to focus on building our products, and know that the back-end stuff was going to be handled in a way that respected user privacy, and so that's been great for us. Tomorrow there will be a talk by the lead engineer on our Thunderbird Assist project, Chris Okin. So check that out, and I'm sure you'll find it pretty interesting. We also have our demo table over there on the left side, so if you want to see a demo of Thunderbird Assist using Flower Intelligence, please stop by over there during a break or whenever. Thank you.
Thanks a lot, Andre. And I actually have a slide about the project, but I would highly recommend instead checking out the booth that Thunderbird has over there. It's way more detailed, and you can actually try out the tool. So yeah, to recap, Flower Intelligence is an on-device AI framework with confidential remote compute. It's fully open source, and you can actually already check it out on GitHub. I would recommend also going through the docs. The Flower Confidential Remote Compute part is currently in closed beta, but you can sign up to the pilot program to get access to it. And I'm very excited about this partnership with Thunderbird, because I think that, what they built is great. So please check it out as well. Thank you.
Thank you, Charles. That was amazing. We're going to go to a 10-minute break now, but you can find Charles if you're in the room. Ask him all the questions you want. If you're online, you can talk to William down in the booth down below here. So thank you, guys. Let's have a 10-minute break, and we're back with even more fantastic talks.
When do you want to set up the panel? Like in the break before, or just before the panel actually starts?
We're back. We're back after a long and very interesting fireside chat, but also a very interesting presentation from Charles, our colleague here. If you have any questions about what he just talked about, or any questions that you want to address to the Mozilla team or the Flower team, feel free to just put them in the comment section and in the chat that we have on both Slack, YouTube, X, and wherever you can find us on social media. We are active there throughout the day, also after hours, tomorrow, so feel free to drop your comments and questions there. Yeah, maybe we'll get some more people coming down here, we'll talk to them, but we have throughout the day had a lot of very interesting questions about the Flower framework. We talked about some decentralized federated AI, which we'll hope to bring some experts in on, but also questions about the framework itself and how it applies in industry and research and so on. So we have people lined up outside, and if there's someone who wants to make an entrance, we are happy to have them here. Yeah, as I said before, just drop your questions and anything you want to talk about. We'll have definitely enough time to discuss them throughout the day. What you can also do is to check out any demos that you are interested in. We have Flower Intelligence up in preview, so that's a very interesting sort of demo that you can use both on your local computer. Try it out. We have examples and baselines up on our GitHub, so feel free to check it out and how you go ahead and see how you can apply it to your own research projects, applications, and so on. If there is any industry data modality model that you would like us to talk about, feel free to ping us here. Happy to talk about tabular data in finance or large language model, text-based data. We heard Charles just talk about Flower Intelligence and show an actual application of how these sort of models run in offline mode when you're actually not connected to the internet. He showed us how you can turn off the Wi-Fi, but the model is still running. So if you are, let's say, traveling, you're on a plane, you're in a train, you can still get the best of this sort of AI world by asking it what any question you might have. So it runs in offline mode. That's the beauty of Flower Intelligence. I think we have some speakers who want to come in and chat, so I would welcome them to sit down if there's anyone. Hey.
Hello.
Hi.
I had a question about the Flower framework.
Feel free to sit down. Maybe also introduce yourself. Hi.
Yes. Hello. I'm Dawa. I'm joining here from SURF, working on like an EU project, and we're using Flower there. But I had a question about the framework.
Okay. Yeah.
So, like the new setup with the super links and the super nodes is super nice.
Yep.
But I was wondering, like, if you actually do the federated learning at different medical centers, for example, they would want some accountability, like who submitted the run, what did they do, what did the code do, and I saw that you had something coming up with auditing.
Yes,
I just was wondering if is it more going to be told later, or can you already say something about it?
There will be, but maybe to your question, you also talked like who can get access to this sort of federation. We do provide things in the Flower framework to authenticate users if that's something that you need. So if you need to, I mean, the basis here is trust and what these sort of federations want, but you can authenticate users. You can make sure that there are certain people that have access to see, okay, this is actually what's happening, and these are the metrics from the training and so on. But yeah, we have more things like confidential compute on specific hardware that you can use, or other techniques, differential privacy, secure aggregation, and all of these to make it even, to build the trust among partners and things like that. But I'm sure there will be people talk more about it either later today or tomorrow, and there are some poster sessions here online, and if anyone online has questions for us, feel free to drop them. We'll try to see if we can give you some more answers to this, but yeah, thanks for the question.
Okay, thank you.
Thank you. And we have more speakers. They are lining up outside, basically. Here, give this to Aline.
Hey,
hi.
Yes, hello.
How are you?
Yes, loving the summit. Like, I hope everyone online is always enjoying. Like, it's really, really exciting.
Yeah, it's been great. We've had a lot of people asking. You can see there's a whole chat here with a bunch of questions. But if anyone has more questions, feel free to put them in the chat. Maybe introduce yourself to the people online.
Yes, I work at the Internet of GPUs Foundation. I'm focused on decentralized AI research, which includes, of course, federated learning, homomorphic encryption, confidential computing, and all about optimizations. And this is related to IO.net, which is Airbnb for GPUs. So there is a decentralized GPU cloud. Yes, and today on the demo, the idea is that we can also scale the local simulations. So if you're working with local simulations and you thought like, can I have more resource and have my local simulation not to be limited to the local environment, then I'm going to share an approach that actually everyone can also replicate. There will be a GitHub repository available.
That's great. And Aline is also contributor to our framework. There was a successful merge that we did not that long ago. Maybe you can just talk a bit more about what that was also, because you identified something and you just thought, okay, this is something that has to be there.
Yes, and I thought the team was very fast in reviewing. I sent a pull request and I joined the Slack because actually I was trying to make the submission to a production rate cluster. And then I identified something in the library, and then I fixed on a specific fork. And then I said, oh, it works. And then I contributed back, and the team was very fast, and it's released on the this new version that was
exactly, yes.
And it's very, very interesting to be able to join this.
Yeah, that was one of the great examples when it comes to the merge and the pull request that one can open up as an external developer, and we have our reviewers internally that try to go through it as quick as possible. But is there, with regards to IO.net, is there any particular industry that excites you, that you see, any application areas that you personally are excited about?
I'm really excited about decentralized AI, and of course you can go to the verticals when you come to federated learning, so like health and autonomous driving. So I'm really excited about optimizing things. Like for more than 20 years, I've been working on software solutions and scaling and automating. Before joining IONET, I worked at Amazon AI Robotics, also optimizing. Before at Petrobras energy company, also optimizing like on the largest HPC cluster in Latin America. So yeah. I'm very into optimizing things, and I'm looking forward to see how we can optimize the local simulations.
Yeah, I think you went quite low level into the simulation mode, or like at least to the ray code part of the simulation, in order to enable more efficient run on both CPU, mainly CPU. Was the pull request that we?
Yes, and I think it's an initial step. I think this approach will unlock a lot of local simulations of like simulations to be scaled, and then for Flower 2 and LLM leaderboard. I see new publications to the Flower LLM leaderboard based on this approach, because it will also unlock faster research cycles. Mm-hmm. So I'm really excited to the tricks that we will be able to do and to
better convergence and utilizing the hardware as efficiently as possible. Right?
Yes, because then you can submit, and even a lab can have sort of a ray cluster with good GPUs and hardware, and then submit to this ray cluster. So everyone in the lab, so without needing to manually configure, because Flower already is prepared for this, so it can leverage this.
And we should say, when we talk about simulation, it's mainly what you would normally do on your computer when you experiment with a specific model or a data set or things like that, before you take it to the real world deployment and put it out there in the world.
Yes, exactly. And I think there is a lot of work that goes on this research and simulation area. And if you want to simulate and test how it is going to behave with, say, like 100 clients, so how do you simulate this locally? Usually it will run sequentially, it will take too much time, but you can simulate also in a multi-node scenario. And then you can, that's before the deploy part. That was very good pointed out by you.
Yeah. And if people want to connect with you, where should they go if they want to see what you are working on and maybe help you out in your research or in your projects? Is there anywhere they can find you?
Yes, LinkedIn, or my email is aileen@iog.net, but also on the LinkedIn and on the Flower Slack channel, you will also find me.
Yes.
And at io.net and iog.net website, you can find me. And we have some partnerships for research also. So also offering some GPU resources for research, which are aligned with the decentralized AI. So definitely reach out and watch the demo. And also reach out.
Yeah, so Aline will have she has recorded a demo that we will show in one way or another here online or later on. But yeah, stay tuned for more. I think we are resuming soon. So I want to thank you for stopping by. And I see that one of our top contributors, Massimo, is commenting in the chat. He was one of the top contributors in for the FlowerTune LLM leaderboard. So
let's talk.
He seems to be very interested in how one can optimize this. So I'll connect both of you.
Yes. And I must say, William, you were amazing. Very you welcome everyone to contribute. So I really felt really welcome. And yes, and it was very streamlined and
very nice to have you here, Alina. Thanks for stopping by.
Thank you.
Yeah,
so
thank you.
See you. Have a good summit.
Okay, that's good to know. Yeah, so that was Alina. You might see more of her during today or later tomorrow, but we're still live, we're broadcasting, we're still going strong for another, I think, 2 hours, and soon we will, let's see what the next thing on the agenda is. Yes, the next thing is also another Flower talk, so it will be from our lead research scientist, Javier. He will talk about the Flower framework. You might have seen him during the keynote speech, where he participated and presented a part of the keynote. But he's a great guy. He is one of the most knowledgeable people about that knows a lot about federated AI. So if you have any questions specifically about the Flower framework, now is the time to maybe think about what those are and what you would like to know, because he definitely has some good insights on what we are working on and what we will be working on in the coming weeks. So stay tuned for more. Let's just turn back this one. We're not ready yet. Yeah, so people, there are a lot of people here on site still. People are interacting with each other, and we have still a lot of speakers to come. So people from industry, people from academia, people from the Flower team. As I said before, Javier is the next one to talk, but if you have questions for other people in the audience, feel free to drop them in the chat. And yeah, check out flower.ai. There you will see all of our... Okay, we're gonna switch over. So flower.ai, and stay tuned for more presentations. We'll be back soon, and yeah, Javier is the next one coming up. So stay tuned.
Feel free to sit down. We'll start anyway. Okay, T minus 30 seconds, folks. It's really happening. Okay, let's get the next session underway. We have 3 incredible talks for you. We're going to start off with a deep dive, an expansion of what you've heard already about how Flower has evolved as a framework, as a platform, as critical infrastructure for building federated systems of all kind. I'm joined here by Javier Fernandez. He's at Flower Labs. He's going to tell us all about it. And so over to him. Thank you.
Thank you, Nick. Well, I'm here once more to talk about not the Flower framework, but we'll see why we are calling it a platform in much more detail now compared to previously. So by now you know that Flower has been designed with compatibility in mind since the very beginning. It's compatible with your favorite tools, including tools that have been around for a long time, like PyTorch, TensorFlow, Pandas, and others. And it's also compatible with newer tools, like MLX, if you are developing federated applications on the Mac, or even super new tools like Hugging Face Legobot library, which was, as William presented, is one of the new exciting examples in Flower, where we show how you can set up federations of robots that collaboratively train a single model. Because with Flower, you can really do you can run all these type of workloads. There is no surprise that many of you, whether you are in industry or in academia, you have been applying Flower to many sectors, in sectors as important as transportation, finance, health, and more. And because of this, we know you can apply it in those sectors. You can apply it also in cross-device setups, where you run Flower applications in the devices that you own, maybe the devices that you even wear, such as smart watches, for example, if you want to build the next-gen human activity recognition model. The only way to do it is with federated learning. So we know, and you know, that Flower is a powerful framework, but this is all news. We knew this for quite a while, and in fact, we were talking something about the same lines in the last Flower Summit. In the last 12 months, we have introduced a series of key components that I'm going to enumerate now, and I'm going to briefly talk about them, but I'm very happy to talk in far more detail later. And together, all these components that I'm going to present is why we are calling Flower now a fully fledged platform. First is the Flower CLI, which we'll see in more detail today, and in greater detail tomorrow, which is the best way to create a Flower app from scratch, from some built-in templates we have, and to also execute them, whether you are running them in simulations on your laptop or workstation, or if you want to run them in deployment. The way to run them is identical. It doesn't matter if you are simulating them or running them for real. We have formalized what the Flower app abstraction is, and this means that there is a unified way of writing how the server-side logic and the client-side logic works. And this is great because by following these guidelines, we can guarantee you that your application will run in simulation and in deployment. When it comes to running things in deployment, we have introduced 2 infrastructure-level components that we call them the superlink and the supernode. You can think of the superlink as the server that will relay messages between your strategies, like the orchestrator for your applications, and the clients, which are the ones that have the data. We call the clients now supernodes. And as we heard from Daniel earlier in the keynote, we have really redesigned from the ground up how the deployment runtime works, and also how the simulation runtime works. And they both share a common backbone, and that's why you can go from simulation to deployment and between them without any changes to the code. And of course, we cannot forget about Flower datasets. It's one of the greatest libraries that live in the Flower ecosystem. It allows you to simulate different scenarios of, in particular, data heterogeneity rated scenarios. So you can test all your algorithms in as challenging and difficult scenarios as you want. So once you are ready with your algorithm, you can deploy it in the real world. There, you won't have control over your data, but because you can control how your data is partitioned in simulations with Flower datasets, your application should work pretty well. And because of this, I'm repeating myself a little bit, but it's really, really remarkable, I think, that we can develop a Flower app We can run it in simulation right away. We can increase the size of our simulation very easily, and without changing anything in the code, really nothing, we can run it in deployment. And this cycle is really complex to achieve, but I think in Flower and with our amazing team and contributions from the community, we made it. But you don't have to trust me, so I'm going to show it to you right now. So for that, I have here VS Code, which, as many of you know, is one of the most popular IDE for developing pretty much anything. And what I'm going to do is I'm going to use one of the Flower CLI commands, which is FLWR, which is short of Flower. I'm going to say Flower new. And what I'm going to be creating is a Flower app. So I'm going to give it a name. For example, demo 1, 2, 3. And this is going to guide me through some process with a couple of extra questions. Just two, so don't worry. And it's going to ask me for my username. So I'm going to type my name. You can write anything you want, really, as long as there are no spaces. And then it's going to ask me for what Flower template I want to use. All these are different templates for different Flower apps. You might want to choose the PyTorch template or TensorFlow template, or if you are, you want something maybe more exotic, you want to go for JAX, you can do that too. And when choosing one of them, you will be, if you were paying a lot of attention, you will see that a new directory appears here. This is a Flower app. So it's a compliant Flower app with a structure that is expected for all Flower apps to have. And if I open just one of the files, for example, the server, I would see that we are using very familiar high-level components like the FedAverage strategy. If you want to use something different, like FedProx or FedAdam, you would just change this line of code. I'm not going to go in detail through all the code, because you can run this Flower new command exactly as I did yourself on your laptop. But what I'm going to do is I'm going to run it, which is one of the best parts of the new Flower app abstraction and the Flower CLI. So for that, I'm going to use the Flower run command. And I'm going to put the name of my app, which in this case is demo 1, 2, 3. And just by doing this, by default, Flower apps will run in simulation. Most of you have already been playing around with this, because this has been around for a few months now. And by default, the config file of my Flower app is using 10 supernodes, which is equivalent to, say, 10 clients. What if I don't want 10 supernodes because I'm expecting to see 500 clients on my real-world federations? So to make the change in simulation is really as easy as changing the 10 to a 500. And if I run it again, well, surprise, surprise, now instead of sampling half of the 10 clients I had before, now I'm sampling half of the 500 clients I have. And what's happening here in this round is really I'm training 250 individual models that they get aggregated by the strategy. And you can see that this simulation is running pretty efficiently. What about the infinite loop cycle going from simulation to deployment? So in order to do that, what we need to do is just to add we need to tell our Flower run command where our superlink, which is where our server is. Typically, you will deploy this somewhere in the cloud, maybe on premises or somewhere else. And we call this, we refer to this as federations. So I'm going to create a new federation, which I'm going to name, for example, remote. This could be really anything, any string, as long as it doesn't have spaces. And I'm going to point it to the address of my superlink that I have already deployed. This is being deployed locally on my laptop, but the process is identical, even if it's running somewhere in a public cloud. So for that, I'm going to put the address and the port. I'm trying to do with one hand. So, and the other thing I need to pass, because we want this to be using TLS, so everything is encrypted, we're going to pass our certificate, which I have already downloaded. So for this, we just need to write root certificates, and I'm going to pass the path to my certificate, which I know where it is, so it's here. And just by doing this, now if I want to run this for real, in a real deployment where there are super links, and I think I have 7 super nodes, this means 7 individual Docker containers, I will just do it almost identically, but thank you very much. It's great to see a lot of attention. Thank you. So now if I want to run it on the remote federation, if you pay attention, here you can see that default federation will be pointing to this one, simulation. I want to use the remote one, so I just need to say remote. And like this, I want to also, for example, stream the logs because this is going to run remotely. So now this is really running remotely. What has happened is that my app has been, all the code in my app has been bundled into a single binary file. It has been sent to the server, the superlink, and the connected clients to the superlink were able to pull this code and execute it. And you can see, as I mentioned, there were 7 clients, so we are following the same logic, sampling half of them for training and all of them for evaluation. We'll go back to what results are being generated with this later in this talk, so stay tuned for that. So going back to the slides, that was a quick demo on how new components in Flower work. Putting everything together, we have the Flower CLI with commands that we have already seen, Flower new and Flower run, but there are many others like Flower less, Flower log, Flower stop. You will learn more about them tomorrow morning. We have the Flower apps abstraction, the superlink and supernodes, and new simulation and deployment runtimes. And all this that we have seen is possible thanks to high-level APIs that we refer to them as strategies, and also the client, high-level API and client abstraction. But what I want to talk about are the strategies. So strategies are really what took Flower to the next level a few years ago. And we are also very grateful that many of them have been implemented by people like you from the community. Many of them are from top-tier papers from the FL literature. And the great thing about strategies is that they are modular and highly customizable. In fact, I think one of the talks this morning, we heard that somebody developed a custom strategy, which is amazing. They are really easy to work with. They power the best research, and we have seen some of it today, and we'll see more tomorrow. And they are also loved by our partners, because out of the box, you get all the complicated logic to make sampling of clients done in a particular way, and more importantly, they come with built-in algorithms on how to aggregate the models that get trained in the client side. But sometimes we were wondering if there is a better way to write Flower apps, a better way that give us more control than what strategies allow us to do. And we think there is a better way. We call it the Message API. And to tell you everything about it, here is my colleague, Pan.
Thanks for the kind intro. So, hi everyone, I'm Pan, a research scientist from Flower Labs. So before we jump right into the topic, I'd like to spend a minute talking about the initial motivation for us to do this. So we always receive messages from lovely Flower enthusiasts asking, oh, I really like the abstractions of strategy and client, but I was wondering how to do early stopping. What if I have multiple models? I want to do analytics. I want to do things asynchronously. And I saw there's something called parameters. Can I put gradients inside it? Things like that. So these questions basically asking, how does Flower work? So how does Flower work? Oops. So I think, well, it is definitely possible to make that happen just with strategy and client. But there's always too much to learn, and we expect that anyone can get started with Flower easily, even if they know nothing about Flower. So let's just strip federated learning to the bone. So there's a server. We call it a server client. A server app. And here's a client. We call it a client app. So to do something federated, they need to exchange message. which is actually just a specialized dictionary, a Python dictionary, containing parameters, metrics, configs, or anything you like. So that's actually everything about low-level message API, which is available today. Let me give you a short example. It's actually 4 examples if you remove the dots. And here on the left-hand side, we have the implementation of the server app. And we create a message. And when we send the message received by the client app, it will be exactly the same message, or say the same Python object sent by the server app. So you don't have to know what happened on the hood, but it's just the same Python object be delivered from the server to the client. And when the client app creates a response or returns it, or basically echoes it, the same message, or say the same Python object, goes from client app to the server app again. So that's how low-level API works. And that's really everything you need to know to get started with Flower low-level message API. So that means you will have full control of the federated learning flow. You can basically do anything you like. And yeah, that's the amazing part of it. But having full control means you need to write some code, definitely. It's not something out of the box. So although we already have low-level API available today, but we are also happy to share with some early prototypes of high-level message API. So here's the code for sampling clients, or say sampling nodes. So that can be done with a sampler. And here's the code to create messages for each of the clients. And that's a communicator. And finally, the most code comes from aggregating message replies from all the clients, aggregating metrics and their individual static, or say any other model weights. So that can be replaced by a single aggregator. So if we put them together, we can see a nicely put for loop. And in each server round, we sample the nodes and create message for each of them, and send a message, and finally aggregate the results. So what if I want even less code? I want something out of box, just like strategy. That's also possible. Well, we have sampler, communicator, and aggregator. We just need something to orchestrate them, to glue them together. So that's orchestrator. With one line of code, you can complete the entire round of training step in federated learning. From passing the model to load the model back to the load the static back to the global model. So with low-level API available today, we also have something amazing on our roadmap. First of all, is obviously the high-level message API we just showed. Also, we'll bring native support for secure aggregation and differential privacy with message API. And finally, we're also interested in support decentralized FL and hierarchical FL and potentially other network topologies with message API, because it empowers, basically allows us to do anything. It's just it just flows naturally because it's very easy to understand, and we don't bring any extra limitations on them. And that's everything about Message API. And for the low-level parts, it's already available today. And I'm going to hand it back to my colleague Javier, who's going to show you something really amazing in the next few slides.
Okay. Thank you, Pan. One thing I want to say is that the Message API, go try it, is really amazing. And also for those of you that are big strategy followers, don't worry, they are not going away. But the Message API is a different way of doing things, and over time, I think they both will end up merging. We'll see. So, but if you have some feedback, we are really welcoming all type of feedback. So the big thing, which already we show you during the keynote, is that we are working on a Superlink UI. This is going to allow you to not just see information about your experiments, but also see a bit of information about the federation where your experiments are running on. So we see this as a unified interface that will be very useful for scientists, but also for the admins, because at the end of the day, if you have a network of, for example, hospitals or banks or other type of institutions where there are very high stakes, someone has to manage those federations, someone has to enable a hospital to be connected to another server. So for the admins, this type of UI will be essential. And of course, scientists and admins will have a different view of the dashboard. So I can show you a quick overview of it. You saw simple images earlier, but this is how it feels like. So I submitted a few rounds earlier. In fact, the run I demoed earlier is somewhere here. I will open one of the runs I did earlier in the morning, which was with a Flower app called Message API Demo. So if I see it, I can see that some of the metrics my server app is generating, like accuracy and loss, they get natively displayed. I can see also what was the run config I used. For example, I decided to sample half of the clients. The learning rate was 0.01, and so on. Of course, because the apps get their own identifier, I can also select other apps. So I can compare how the same app, but using different hyperparameters, perform in my federation. And of course, I can see things like the logs that those particular runs generated. If I want to get an overview of what are the nodes in the federation, which, by the way, these were the nodes. Each of them are super nodes where I submitted my remote workload earlier in my demo. I will be able to see information, for example, like who they are. They have a node ID, but where they are based. Or this will depend a bit on what kind of federation we are talking about. Different industries will have different requirements. And this is a quick overview. We see there are 7 supernodes, but you can think that there is a lot of functionality that can be built on top of this. For example, admins of the superlink might be able to allow supernodes to join or deauthenticate supernodes whenever a project has finished, for example. We'll have much more to share about this later in Q2 and Q3. So wrapping up the talk, because we are way over time, I just want to conclude with something that Daniel mentioned earlier in the morning. So since the last Flower Summit, we have done 10 major releases, but other patch releases. And there are a lot of functionality that we don't have time to talk about now. Things like the FAB delivery mechanism, which is the mechanism by which the code I develop on my laptop gets communicated to other members of my federation. Or how the isolated execution of my client app works. Because if at the end of the day, if I have a server in the hospital, I don't want the client app that somebody else wrote to be able to do anything with the file system. So there are isolation mechanisms, so everything is compliant. Node authentication features, so we know that the supernodes are who they say they are. And also custom message handlers. So now you won't have any limitations on what kind of messages you can create. By default, you have train, evaluate, and query, but you can create as many more as you want, which is something native to the Message API and really will make your Flower applications way more versatile. And this is everything I had to share. If you want to try the Message API, we have an example in the GitHub. If you scan it, it's here. If you prefer to go to GitHub directly, it's called App PyTorch. And that's it. Thank you.
Javier, that was a great talk. We've got another great talk coming up next. It is going to be given by Eden Ruffle. She is a PhD student at UCL. She's an honorary fellow at Moorfields Hospital, and she holds a number of other positions where she is currently investigating how we can build foundation models using sensitive information about the eyes, and then so the downstream task can start to automate, important types of detection of diseases, perhaps delivering those results to people much faster and more accurately than can be done by humans alone. We've been working with her for quite a while as she is trying to transition that type of training process to be federated. And so I've been incredibly impressed with the results she's achieved so far, and I can't wait to see where she's got to now. Over to Eden.
Thank you very much. Let me just figure out how to share my screen, and then I'll kick things off. This is classic technical difficulties. You would think with a room full of computer scientists they'd figure out how to do this, but maybe not. What do I need to do?
Go mirror and then choose content.
Ooh. Here, I want to share this screen.
Yeah, great. So go extended.
And then do I just drag it?
Sure.
If I can figure out where it is.
There you go.
Oh, I had it.
You can mirror. That's helpful.
No, I'll do this. It should be fine. I just need to see in the distance my tiny cursor. I cannot see where my screen is. Okay. Brilliant. Okay, fabulous. We're making it work. Hi. Thank you so much. My name is Eden. Thank you very much, Nick, for inviting me to speak today. As mentioned, I am a PhD student at UCL, so I'm actually in the first year of my PhD. So the work that Nick was referring to earlier was actually during my master's, so be nice. I'm also an honorary research fellow at Moorfields. So as part of my my research group, my supervisor is Professor Piers Keane, who is a consultant ophthalmologist at Moorfields. And as such, I primarily use eye data. So we're using that to build these foundation models. And again, as Nick mentioned, we're using foundation models and trying to see how we can apply federated learning to the fine-tuning of that. So I'll talk about that a bit more later. So in addition to my role as a PhD student and honorary research fellow, I also am a data scientist and researcher at an organization called Insight, which is an NHS-led initiative that helps to make anonymized data available for researchers, both at the hospital but also elsewhere, in a really safe way. So we take the data from, for example, a hospital like Moorfields, we make it nice and tidy, we clean it, and then we make it available. And at the moment, the Insight data set that we have is the world's largest ophthalmic imaging bioresource with like over 24 million eye images, 2 million patients represented, and this infrastructure is allowing us to take advantage of this data and validate the sort of cutting edge AI tools that myself and others are developing at UCL and at Moorfields. And one example of the things that we've managed to do with this data is develop the world's first retinal foundation model. I'm sure a lot of people in the room know what a foundation model is, but I'll be generous and explain a little bit. Essentially, a foundation model, at least a vision foundation model here, learns generalizable representations from vast amounts of unlabeled images. The RetFount model specifically, which we published in Nature in 2023, uses both fundus photography. So if you've ever had an eye test, that was a fundus photograph, and you can see that's actually my eye just there at the top. Also OCT, so that's ocular coherence tomography, and those are 3D eye scans. It's essentially a bit like an ultrasound, and you can see the back of the eye through the retinal sublayers. I'm not a clinician, so don't ask me any more questions about eyes. I'll refer to other people in the audience who have much better specialties than me. And with this foundation model, we were able to then take those generalizable representations that we've learned from these images of eyes, and then fine-tune them, so adapt them for lots of different downstream tasks, whether that be predicting eye disease, like diabetic retinopathy, or predicting systemic disease in a field that we like to call oculomics, which is essentially using eye images in order to predict systemic health conditions, so whether that's predicting heart attack or neurodegenerative diseases like Parkinson's from eye diseases. That's something that we are trying to do with these sorts of models. However, although we have this very large amount of data, it is only coming from a single institution. So we're kind of limited about the sort of power that these models can actually imbibe within them, because we are only using data from a single source. So this sort of led me to think, when I first joined my research group kind of just over a year ago, and when I was starting my master's project, what is kind of the next step for these large foundation models? How can we access more data? Federated learning, which is why we're all here today. So trying to think about how we can introduce federated learning into the development cycle of these foundation models was something that really interested me for many different reasons. Where exactly we can introduce federated learning can happen primarily in two areas. So either the pre-training, so that part I talked about just now, where we're using these unlabeled images to train the base model to give it that foundation of knowledge. But then also at the fine-tuning stage, so when we've got this base model and we want to then apply it to lots of different tasks. So as I said, whether that's predicting whether a patient will go on to have dementia. And in healthcare especially, this is really helpful for three main reasons. Collaborating with other hospitals is very challenging because there are a lot of data governance issues, strict IG that have to be overcome in order to actually make those collaborations happen. And having only worked in this field for a year, it's been very challenging to work with other hospitals for these reasons. But if we can use something like federated learning to help develop these larger models in this way, then this would be great. It would also enable us to have much broader data sets that are from a wider, diverse population. So this helps to improve the health equity of these models so that they can actually serve a wider audience of people, maybe underrepresented populations. And then we also we can spread the computational benefits as well. So if you have a smaller hospital, then you're likely not going to be able to have lots of computational resources, so we can spread that around. So my research, as Nick said, has been primarily about taking the foundation models that we've developed and fine-tuning them using Flower, which has been amazing. And I really like all of the framework updates as well. It's made my life way easier. And the reason why we were able to do this with real federated data is we have this data set that we call ALZI, which actually comes from lots of different hospitals that are within the Moorfields network. And we have this data that comes from around 350,000 patients, and that's taken from around 10 years. And we've been able to link their imaging that they've had at Moorfields to systemic health data. So from there, if you've ever gone on to, when any of the patients have gone on to go to hospital in A&E or admission or have an outpatient appointment, we can look at why that happened and then link it to their imaging. And in this way, we can have clients in a federated learning setup that are truly distributed, and the data that is within each client is coming from only one of those single institutions. So we have very varied sizes of the clients, but also very different distributions of the patients that are represented in those clients because of the locations that they're coming from. Most recently, I've been developing, fine-tuning a new foundation model that we've developed, which is a version of RepFound pre-trained using DynoV2, which is a kind of very popular methodology for pre-training foundation models, especially in the medical sphere, specifically to go on to predict, using eye scans, predicting whether a patient will go on to have a heart attack, using around 1,400 patients overall, the whole network, but using clients that have very different sizes. So the smallest having just over 100, but the largest only having 1,300. So still not huge numbers. And very briefly, because I know I'm really running out of time here, what we found, and this is again very exciting, is that the centralized model, when we compared it to a model that's been trained over 5 server rounds, that there was no difference really in the performance. And this was just using the very straight out of the box federated averaging. So that's really exciting that we know that this is possible, that training foundation models using federated learning for the fine-tuning works. And the only significant difference really in the performance was when we had kind of more of a zero-shot approach where we just did one aggregation and we compared that to a centralized server. There was a difference, so more rounds essentially allowed the model to learn more. And we also validated our outputs using a large data set called UK Biobank. And although overall the performance is degraded across all the models, we again didn't see any significant difference between the server model that is trained for 5 rounds versus the centralized model. I won't go into too much detail because I'm really running out of time. But we also looked at the equity of how the larger clients performed versus the smaller clients. So from left to right, it's the largest hospitals, and on the right, we've got the smallest hospitals. We saw that for the larger hospitals, the performance when only trained on its local data versus the kind of being part of the federated learning strategy setup was definitely an improvement, but wasn't a drastic improvement. For the sites that had kind of mid-level of numbering of patients, we saw a slightly larger improvement. So this again highlights the the importance of these smaller hospitals benefiting from being part of a federated network. And the smallest hospitals saw the largest improvement. So when only trained on their local data, you can see that they don't do it very well at all. But when trained in the federated network using all of the accumulated data, those clients actually did really well on their data. In the future, we're looking to focus more on that pre-training aspect, and I have active collaborations with people in the University of Washington, the University of Colorado, trying to see if we can implement some of these federated strategies at the pre-training phase. And I'm also working with colleagues in the Institute of INEA at Harvard University, seeing if we can deploy just some of these very, very straightforward federated learning frameworks to train some of these foundation models using their data in addition to ours. So that's really exciting. Any questions? Thank you very much.
Thank you, Eden. We have time for one or two quick questions. Yeah, right down in the front here.
Hi, thank you. That's really nice work and a nice talk. So the hospitals in your network, do they have compute infrastructure in the hospitals? And my second question is, presumably this is sensitive patient data, so do they require any privacy guarantees around the model weights that are being transmitted between the server and the client?
Mm-hmm. So to clarify, so the data, although it's coming from separate places, because it's part of the Moorfields network, it's actually all in one single location. What we wanted to see with these experiments is if these clients were actually separate, would it still work, despite already having a single kind of data set that we've got accumulated? But yes, absolutely. With patient safety, we would have to, if we were going to do this in a real world setting with the data actually being distributed and trained in a distributed way, we would have to consider additional privacy mechanisms. And the changes to the Flower framework have made sort of setting that up very simple. One of the challenges, obviously, working in healthcare is making sure that not only do each of the different hospitals have the kind of compute resources, but also the technical understanding in order to set up the privacy infrastructure. So there's always struggles with that. Thank you.
Great. Let's take one more question just from Sophie. I think she had just here.
Hi, yeah. So other than the obvious issue of data privacy, what other potential obstacles have you had to overcome really implementing this in the real world?
So implementing this in the real world, so as I mentioned, some of my collaborators that I've been working with been doing this for kind of just under a year, and these processes are very slow. So the governance is still very challenging in the healthcare sphere, despite people understanding what federated learning is and understanding that there is definitely this separation where data is not being moved. A lot of active collaborations, at least when we're trying to come up with research projects, still require the governance, that as if the data was actually being moved into a single location, which makes it very frustrating because we're trying to show that we don't need to do this, but they want the safety net there just in case. So that's been a challenge. So things are very slow moving. So this is why we wanted to initially show that it was feasible with data that we had access to that is truly distributed. But then we're moving to actually working with others. It should be quite straightforward. It's just a case of having the infrastructure set up. One of the other challenges that we've seen is obviously different institutions store their data in different ways. They have different resources in terms of the compute that they have. So obviously working at somewhere like Moorfields, collaborating with institutions like Harvard, they have great resources. But if you want to integrate working with other smaller institutions, they might not have that same power of resource or data. So that's been another thing that we've been contending with. Thank you.
Great. Let's thank Eden again. Thank you. And so for our next talk, we're really happy to have Harish Srinivas. He is at Meta. He'll be calling in online to tell us all about some important new changes to Executorch and how they can have quite profound ramifications for federated learning, because it can start to expand the footprint of mobile devices that can finally start to do on-device training and therefore participate in federated systems. He's actually been quite a pioneer in federated learning himself, working on the Papaya system earlier. And so I'm fascinated to see what Harish and his colleague is going to tell us about.
Hey guys, hopefully you are seeing the screen of the slide share, and I'm not able to see the full video, but like, yeah, hopefully all of this is set up correct. If so, like, yeah, cool. Yeah, thanks, Nick, for the intro. Yeah, I'm Harish, software engineer in the PyTorch Edge team or the Execute Torch team, working on federated learning at Meta. And like, I have my colleague Jacob, who is part of the Execute Torch runtime team, and like he'll be giving an intro about Execute Torch, and I'll be following up with the training and the federated learning aspects of it. So yeah, Jacob.
Yeah. Can you go to the next slide? Yeah, so like Harish said, I'm here to talk about ExecuTorch. So ExecuTorch is kind of the solution from PyTorch for running your various ML models on the edge. One thing I'll say is that PyTorch tends to think of the edge as a lot more restricted than kind of people in the open source community might. So when we say edge, we're talking about kind of like the far edge, so ranging from like mobile phones is kind of like the most resource rich environment down to like embedded DSPs or something in a headset or other kind of devices. So our previous solution was, our previous solution was like PyTorch Mobile, but that's mostly deprecated, and we're all about ExecuTorch now. Yeah, so the general kind of problem statement is like most researchers and model developers start with a PyTorch program in Python, and then they want to figure out how they can get that model to their edge devices and run it performantly, and potentially even start training it. So the general way we think about this is you have your eager PyTorch model, and then you run it through like an exporting type system where you give it some inputs, and we like try to convert it into an exported graph of nodes, right? Of like calling one operator into another operator, or maybe some control flow as well. And then we take that graph, and you can run all sorts of user passes on it, like reordering nodes or fusing nodes, things like this, to gather like better performance guarantees. And then we take that graph and we convert it into a sequence of like execution instructions, an execution plan, so that you can run it on device. And then we convert that into like a binary that we can then ship around. So one benefit of ExecuTorch over the old system is that it's export-based, which is like a first-class citizen in the PyTorch ecosystem. You can take your model, and it's like the same kind. It's a very similar flow to torch.compile, though there's no Python backend if there's a graph break. And you can capture a wide range of dynamism, from like loops and branching if statements to shape dynamism for like batch sizes and things like this. There's a standardized smaller set of operators. So regular PyTorch, I think, has around 3,000 plus operators, which makes it really hard for the various backends on the far edge to kind of integrate, right? Qualcomm would have to go and implement 3,000 operators. Apple would have to go implement 3,000. So we restrict it down to 300 through decompositions and replacements, while still remaining numerical consistency. And then the APIs and your models are the same, essentially, between authoring in Python to running in C++. You're still dealing with like module type things. You're still running them. Another benefit is that you stay within the PyTorch ecosystem completely. You don't ever have to go out. The delegation and lowering processes are very consistent contracts. We have native debugging and profiling built in, so you don't have to try to fire up third-party solutions. And then you can progressively lower, like step by step, to get all the way down. Another benefit is it's really modular. You can kind of pick and choose for your solution based on what you want to deploy to. So I think the next slide maybe shows this a little better. Yeah. So you can pick like, oh, if you want to quantize your model, how you want to quantize it. Then you can decide which accelerator you want to go to, be it like CoreML on Apple or a Qualcomm accelerator. You can write your own custom passes on the graph to fuse and mess with nodes. You can write your own custom memory planning. It makes it all very customizable to whatever sort of hardware you see in your particular kind of edge instance. And then another benefit is that because of this modularity, it's really easy for us to go and partner with lots of third parties, such as Apple, ARM, and Qualcomm, where they provide kind of industry-leading performance on their hardware, and you often just get it for free using Executorch. You can just say like to backend Apple or whatever, and we'll just naturally pass over your graph, select sections of it to delegate to Apple's accelerators, and then you just get it for free. Yeah. The other advantage of PyTorch is that it ditches a lot of heavy dependencies that come with the full libtorch package on PyTorch. So our core runtime is only 50 kilobytes in size. We don't have any dynamic memory allocations, no malloc, no atomics within the core runtime. So you can deploy this on all sorts of bare metal applications. Yeah. And so now I'll pass it to Harish to talk about training some.
Cool. Yeah, thanks, Jacob. So Executorch began as an inference-only framework, and we have currently added the training support, like very similar to like inference, like where we capture instead of the forwards pass, like we capture forwards and backwards the entire graph ahead of time, and then like every other step is the same, right? Like it's composable with the existing Executorch workflows and the different backends as well. So right now it works for a handful of models. It is open source, so you can go and like check out the repo. Like it works on XOR, CFAR. Like we also tried it with LLM LoRa training on like smaller kind of the smaller LLMs. So like it is there. It's in the preview or experimental stage at this point, and yeah, we have a lot of ongoing work, like especially around improving the coverage of models, improving their performance. All of this is planned and like upcoming. So just stepping back a bit, before I talk about the ecosystem and federated learning and like how all of that kind of ties in, like what we are seeing is that we see an emergence of AI use cases, right? Like expanding from the server to edge use cases, and like this translates to real opportunities from the use case perspective, like with the data being generated at the edge and consumed at the edge, right? Like as most of the other talks have also alluded to, like you can do offline. It works with offline environments. Like obviously, like there are like privacy and personalization benefits with data all being on the user's kind of local device. Like you can potentially have new experiences that is possible only in this particular environment. Of course, there are, on the other hand, we have hurdles and challenges when deploying these models on the edge, namely the biggest ones being and the resource constraints themselves, right? Like power restrictions, memory restrictions, even thermal restrictions, like where you don't want the phone or your wearable to heat up, like as you are kind of using them. And the other things are like these are heterogeneous set of hardwares. And finally, like debugging and is hard, right? Like especially in the federated setting when you don't have access to all of this data, and like you're also concerned with privacy. Debugging is very hard, and especially when you're talking about device deployments with longer release cycles. And for an on-device training kind of system, like I want to, the main takeaway here that I want to share is that there is more than just the training capability itself, right? Like first, one would need an on-device storage kind of system to collect the data, have feature engineering capabilities to prepare the training and like eval data sets. This needs to be present on the device. Like you will need a scheduling, you will need scheduling capabilities that is resource aware. One needs to one needs a way to like say, okay, like hey, start this training job only when the device is idle, connected to Wi-Fi power, and like this these restrictions will also change during the part of the run. So you will need to be able to stop and like resume kind of runs. Like you will need to have this capability. And finally, one needs some server communication channel, especially with the orchestrating server to download models, upload model weights, or any other kind of artifacts. Again, these are not an exhaustive set of capabilities, but I'm just saying like there is a lot more that needs to be built out for there to be a fully fledged on-device training system on the device. Like this is a kind of continuing the ecosystem. this is kind of the federated learning system at a glance at kind of Meta. The previous slide talked about like all of the client side kind of bits. Like as this group might be very familiar with, like there are like a bunch of server side components that will also need to be built out, from assigning clients to tasks, aggregating model weights, etc. One thing I wanted to also like point out here is that like we rely on a trusted, secure aggregator hosted on secure environments to aggregate all of the model weights, so that only the aggregated model weights are observable by the orchestrating server. So I also linked the systems paper for more reference here. Yeah, like just again at a very high level, don't without going into too much of the details, like the federated system at Meta like is focused on the cross-device setup, right? Like it's that's where our focus is, and as a result, we have designed for one heterogeneous set of devices with limited resources and unreliable connection to the server, right? Like they can drop in and like drop out of the protocol at any given point in time. There are two flavors of FL algorithms, broadly speaking. Like one is sync and like async. Async, like sync is the standard, and like async is where like straggling clients can still contribute to the different model weights. Async definitely has better system properties and leads to a faster convergence in practice, as in our kind of result. And like finally, like we also aim to provide defendable privacy guarantees, relying on trusted execution environments and differential privacy. There's a final this one. So as a continuation of the effort, like we also see the need for doing federated computations beyond federated learning itself, like such as federated analytics to understand feature distributions and like help with more of the privacy preserving work that is required. So again, like we have a systems paper that I have linked here, like which goes about like, okay, like what the differences are and like how we are seeing it. But yeah, thanks.
There's a hand right in the middle that went up extremely fast. Let's take that question. Jason, to you. Yeah.
Hi. I was just wondering, how does ExecuTorch compare to other offerings such as Onyx Runtime? Is it mainly focusing on the extreme low size, weight, and power deployment options?
Yeah, I can take this one. I think in a lot of cases, our integrations with other backends typically lead to faster performance. But the bigger kind of benefit, I think, compared to Onyx, is the pain point we've often seen internally and certainly in industry is the Onyx conversion scripts often fail in ways that are like hard to resolve and things like this. Whereas with ExecuTorch and with really all of PyTorch 2.0, you get kind of this lowering property without having to leave the PyTorch ecosystem. And typically we found that like exporting is significantly faster and easier for model developers to do than conversion.
I think there was one more question just next to the person. Did you have a question?
Hi, thank you for the talk. My question is about using federated learning. Which platform you are using?
You mean like which devices like these are running on? These are mobile phones primarily, like iOS and Android.
I was interested to know that are you having a collaboration with Flower or?
We are definitely in talks on like a collaboration and like figuring out how to work jointly here.
Great. We'd love to talk more. Thank you so much. Yeah. Well, honestly, ExecuTorch is doing exactly what the ecosystem needs, and so we obviously want to help proliferate, and accelerate what you're doing there. So it's great. We're actually running out of time, so thank you. I really appreciate both of you finding the time in your day to talk to us. So thank you very much.
Thank you, Nick.
Okay, so we're on the last stretch. And at the end of it, those who are physically with us have a nice cookie, because we'll be going over the road for the Flower After Hours party. But between now and that happening, we have 3 fascinating things to do. One, I'm going to give you a brief update on Flower LLM in a little bit more detail, but then we've got Anna from Vana and a wonderful panel to close things off. And so we're going to skip the break, and I'm going to transition straight to this short talk. Just wait for the screen to come up. Oh, it's not plugged in. That is... Okay, we're talking about AGI, but we forgot to plug in the slides. And a little bit more like this. I think it's fine. Yeah. Okay, so as we talked about before, large language models, foundation models, this is where we start to see AI reach its maximal set of capabilities. And so it's important to understand how we're going to train these models moving forward, particularly in these decentralized settings. And so in the last 12 months, we've seen, as I mentioned earlier, between 100 and 1,000-fold drop in the amount of communications and synchronizations required for training to occur. This has profound repercussions in terms of the algorithmic needs of training these models. And I think today there is mounting evidence in startups, evidence in academics' labs, even evidence in big tech, that perhaps the workhorse of data centers, this distributed data parallelism paradigm of training these models, is going to give way to federated versions that allow us to have these GPUs placed in different locations. And if that ends up taking place, if it does turn out that DDP can be replaced with different federated learning algorithms, not only between GPUs, but even inside data centers, that will radically change how we train these models. It'll also radically change even how we architect these data centers in the first place. And so this is a dramatic change. If it does come to pass, we won't be saying that DDP is being replaced by federated. It's very likely that we're saying that Flower has replaced DDP. Let's dive in to one of these results to give this a bit more color. And so this is a result that we put up around November last year, and it just gives you more context to what we're talking about. Here we demonstrated that you can train a 7 billion parameter LLM. We compared it to DDP. We looked at it when we normalized the actual communication speed. And when we did that, we found that federated learning and variations thereof were able to train that model, train it to convergence, have a very strong model, and yet it would actually only require, you would actually reduce the amount of communication and synchronization required by a factor of 1,000. You can see the details here. You can see that communication time for the Flower photon combination that allows this to be possible is actually has a huge drop in the amount of communication time required. And so this starts to open the door dramatically to different variations of AI infrastructure that now becomes possible. As I mentioned before, we can start to see data centers themselves starting to change. There's no need necessarily, potentially, to have so much network infrastructure between these GPUs. It also opens the door to networking between data centers. We already start to see this emerge, but that type of networks will be far more efficient when they can start to adopt algorithms of this kind. It starts to also make it possible to democratize networks of robots and cars and other devices that fundamentally need to be trained in a distributed way. If you think about when you want to train a foundation model for embodied AI, you really don't want to centralize this, particularly because the data involved is so dynamic. The world's a dynamic place, and you don't want to have to copy all the data from a car into one place to train a perception model. We see these things being possible in only a few of the companies right now, but once we've started to make these breakthroughs in distributed training, they can become much more commonplace. This last one here I want to point out is that we can start to see a lot more collaboration between individuals. In the room right now, we have a dramatically, powerful local machine that's able to stand up the largest, best open source model around, at least currently, DeepSeek, and it runs on a single computer. You don't have to network multiple computers together. You can have a single computer and it just runs. When you have that possible, combined with the breakthroughs in distributed training I'm talking about, suddenly individuals can start to work together towards serious types of models. Similarly, we can have companies, this last example here, we can have large Fortune 500 companies that are currently outside of the AI game, working together, sharing resources, potentially individual companies might not have enough resources to stand up one of these huge models, but by working together and also leveraging the data they uniquely have, so like folks like McDonald's, Starbucks, these are not tiny companies by any means, but they're not training models in this sort of giant fashion right now, but they can soon start to work together, use the data that they uniquely have. We would hope they'll do this so safely in order to build models that have unique capabilities. And again, all of this is possible through this breakthrough in distributed, decentralized training. So, in order to make this possible, we have radically added to the Flower ecosystem and platform in a number of ways. And so we've done a lot of research and collaboration with folks at the University of Cambridge, and we've developed the missing components of a stack that you would need to be able to build systems of this kind. What's important is that these components are open source. They have been peer-reviewed. So, for example, key parts of the stack, such as really interesting ways of coming up with embeddings that you use when you're training federated models in order to have low memory, in order to have high perplexity, or better perplexity, is only possible through some of the designs that we've come up with and have had it peer reviewed. And so, for example, this embeddings work as an oral at iClear and was actually ranked 28th out of 11,000 submissions to iClear. People felt it was that impactful, that interesting, and so in a few months' time, you'll be able to see it done there. Similarly, the Photon system, the system that orchestrates a lot of this work and sits on top of Flower, again, this was a collaborative work, and it was published to be appeared in MLSys. And so my point here is that this framework is ready to build these next-generation AI infrastructure, the open sourceness and the peer-reviewedness as systems that you can then start to build with a great degree of certainty. So let me just start to tell you a little bit about what are the main milestones that we've reached in the last 12 months that are going to really be able to start to make these systems become more stronger and impactful. So there's this issue of SOTA. It's no good training these models if they lag behind what's state of the art. If I can train a decentralized LLM, but it's never able to be as powerful and as accurate as the ones trained centrally, then interest in that type of model might start to wane. So as achieving SOTA was something we definitely wanted to see be possible. To see where we are with this, you can see a number of existing decentralized models that have been trained over the last 12 months. They range in size between 1 and 15 billion parameters. And what this figure shows us is how far behind the centralized versions they happen to be. And so you can see, for example, in some cases, models are 25% behind. This is on downstream tasks. In other cases, they're 5% behind. But the point here is that they're lagging. And so we're very interested in being able to achieve SOTA, and I'm glad to announce that we've been able to do it through the use of depth embeddings, through the use of a new optimizer that we'll be announcing later in the year, through the use of a important networking stack, and using Photon. We can now train, we believe, of an arbitrary size SOTA-level models as long as we have enough data and compute. Our demonstrator for this is called Flower LLM 1.7b. And you can see here, it might be a little bit hard to see on the screen here, but if I zoom in a bit, you can see that it narrowly matches the SOTA level of performance for that particular model size, which we align to be the small model coming from Hugging Face. So this is a big breakthrough because this is a SOTA-capable model that was trained decentrally. And so you'll not be able to find this with any other type of model sizes out there that have been trained in this fashion before. If I show you this illustrative, convergence figure, I can start to point out that what we find when we put this recipe together of these various components and we start to train in this decentralized fashion, that initially the centralized version wins. And so as we train further and further and the system starts to tune, we can find convergence eventually that matches, or in some cases slightly beats, in some of the downstream tasks that of a centralized model. This is exactly what you want to see possible. And if I showed you the loss curves of other types of decentralized models, they wouldn't look quite as nice as this one. We believe that these techniques should hold up, in our estimation, up to 100 billion parameters, and so that we're looking for partners to work with to demonstrate that this is actually the case. And so that is Flower LLM 1.7b. This is the world's first SOTA LLM, meaning that it's a LLM that's achieved a SOTA level of performance, and it's unique in the fact that we actually trained this in a decentralized method in Vana. So what's next? I mean, if we can train SOTA models in this fashion, if it's so important in the way that I'm talking about, well, then we really need to start to achieve milestone 2, which is critical mass. And so I'm delighted to announce that we've managed to achieve a lot of what you'd want to see in terms of critical mass being achieved and planned in this direction. I can actually outline this in terms of 3 numbers that go from 1, 2, and 3. So what are these numbers? Well, the first is that we have our first government adoption. I'll explain in a minute. The second is that not only do we train foundation models now, we're actually having other organizations work with us to train their own foundation models. In some case, they don't need very much help from us at all in order for them to train their foundation models. And finally, 3, let me explain that in a second, because that actually doesn't stand for 3, but it stands for 1.3 million users that we're going to have access to in a partnership I'm about to describe in a few seconds. And so, one by one, we've actually had our first breakthrough in terms of governmental relations, of working with a government, working with members of governmental organizations who need this type of facility. And so I'd like to call out Sprint D as an important German-based government organization. Actually has given Flower money and a set of goals that we plan to be able to achieve. We're going to achieve these goals, and then we're going to have these things adopted all throughout Germany, because this is what the type of thing that you need when you're building foundation models. You need the ability to integrate all the data of a country. You need the ability for a country to build its own models in its own, with its own resources. And so we're delighted to be working with Sprint D on this aspiration. So they are our first country-level partnership that this technology has achieved. 2, the foundation models. We have been working with a number of organizations. Eden represents one of them. The other is based in the States. They're both interested in building AI-based foundation models and using federated-like methods. And so they've been using different parts of the Flower stack and having, dramatic success in building these models. They come from, UCL, Moorfields, Charlotte, North Carolina, and Stanford. They're independent groups. We give them, the amount of support they need to train their models, but largely they're building it on our open source efforts. And I can't be more enthused about the types of models they're building independent of us right now. Now 3, that is very exciting to us too. I'm going to end with 3. 1.3 million users at Vana. We actually have Anna, who is the creator of Vana, in the house right now. She's also the CEO of Open Data Labs. She'll be speaking next and probably to expand about where this 1.3 million comes from and where, importantly, it's going to next. But Flower is going to work very closely with Vana in the next 12 months. And this is towards a model that I mentioned earlier in the keynote, but that will change the face of AI. That's because it's going to be the world's first decentralized, user-owned foundation model. We're calling this Collective One, and that's because Vana is a specialist, perhaps the best organization in the world in helping people form DAOs that allow users to get their own data under their own control and then decide how they want to use it. And you can just imagine how important that is in terms of ecosystem building for the types of things that Flower and everyone in this room really wants to see happen. What we need to do now is, given that we can build models of this kind, we need to find sources of data. I cannot imagine a better partner to work with to provide us with this type of data, that we can then start to build a foundation model where every person who contributes data naturally owns a piece of it. And there's a very clear pathway of where that data came from and them opting in, and then that model being able to be used for downstream tasks they care about. This is going to change the way AI is done. And so we're delighted to be doing this in the next 12 months with Vana. So I'm sure Anna is going to tell you more about this, but just to give you a sense, we're currently aiming for a 7 billion parameter model. We'll be working, moving through the different DAOs that are part of the Vana sort of ecosystem. What's important here is to know that the types of information these DAOs have are completely unlike the ones that you see in foundation models and LLMs today. Those types of LLMs, these conventional types of models, they contain data solely from the web, solely scraped off the internet. Some of those some of the practices in collecting this data is somewhat questionable. In this setting, actually, our model will come from a variety of different sources, Reddit, LinkedIn, GPS data, IoT data, but the key thing is that every single piece of data will be associated with an individual who said, yes, I'm happy with this piece of data to be used for this model, and then we'll see just how far this model can fly when we start to give it access to data that it could be otherwise impossible for it to access. And so, to close, LLMs, foundation models, this is where we see just how far AI can go. They won't go very far, much longer, unless they're being trained in a decentralized manner, and Flower has the perfect set of technologies and stack in order to build these new emergent forms of training. We are delighted to be working with Vana, with Collective One, which we think can be a blueprint for many foundation models that are built in the future. We're delighted to see things like Flower LM 1.7 demonstrating that SOTA is extremely achievable and must now be the norm moving forward for all decentralized models. And finally, and most important to me, I'm so happy to see the ecosystem of users expanding rapidly, including countries, including people with important types of societally relevant model building tasks, such as how do we detect different types of eye medical data, working with Flower to build these types of foundation models the world desperately needs. And so thank you very much for listening. I'm happy to hand over to Anna in a few minutes, but any one or two questions? I think we can have Anna come up to the stage then. So as I mentioned before, Anna is the CEO of Open Data Labs. She is the creator of Vana, and she's a fierce proponent of the need to allow people to take control of their data, no matter how it's going to be used, whether it's AI or other types of downstream tasks. When she started to talk to us about what we could do together, she had a wonderful set of ideas, and we're happy that our technology has been able to start to fulfill some of the dreams that she's expressed to me for quite a while now. So I can think of no one else better to give the next talk. So thank you, Anna.
Hey, nice to meet you all. Excited to dive into kind of what a user-owned foundation model is, what it means for a user to own it. But maybe just first a quick intro on me. So I got into decentralization and kind of federated approaches through mining Ethereum pretty early on. So I was obsessed with central banks. Like I had a picture of Janet Yellen in my high school bedroom, and then worked at the Fed in high school, and then got to MIT and learned about decentralized central banks, which were kind of these cryptocurrency networks that let you run compute from devices all over the world in order to do something that usually would have to be done in a centralized way. So I'd go get GPUs from dumpsters that labs were getting rid of and just set them in my dorm room to mine. And what that got me interested is kind of this idea of being able to have a large group of people collectively contribute to something that's just secured by like cryptography. I then went on to do research at CSAIL, which is MIT's AI lab, focused on natural language processing and kind of how do you best embed text. This was when I think a lot of the embeddings were not quite there. 2017, the attention is all you need paper had come out, but generative models weren't quite there yet. And the problem I always ran into was that the data I wanted to work with wasn't available. It lived in the gardens of kind of the walled gardens of big tech companies. And I'd be like, oh, I wish I could train on this or that. But it wasn't really available because it lived inside of those silos. So what we're doing at Vana is really using the power of individual data rights to take data out of those walled gardens. To start on kind of the importance of foundation models, I think there are two aspects. One is that they're becoming this new source of truth, right? So whoever kind of controls the data that goes into a foundation model is kind of controlling what information people believe. I think one example, if people remember with Google Bard, you could ask a while ago a picture of a medieval British king, and it would show you like an Indian woman, right? And I think a lot of people were like, oh, it's this crazy wokeness of the 2020s. But if there weren't another source of truth, people would just start believing that this is what had happened in history, right? And so whatever information is in AI is really important. And then the other piece is economic power, right? If you have the best foundation model, that generates a huge amount of revenue, right? It can do work that a lot of knowledge workers do today. You can look at like OpenAI's $3.7 billion in revenue as kind of a reference there. Typically, foundation models are trained on public data. So if you've posted on Reddit, you might have already helped contribute to AI models. But yeah, I guess for GPT-3, which is one of the ones where they were still being really transparent about exactly what data it's trained on, 60% of the data just comes from Common Crawl, right? So that's scraping the whole public internet and then kind of taking all of that information and using that to train the AI model. But that represents a really small percent of the overall data in the world, right? So if you look at kind of all internet data versus public internet data is less than 0.1%. And that's because most internet data requires permissions or sign in to access. Just as a person, if you think about where you spend your time, like it's probably in Google Docs and messages and email, that's not publicly available to scrape. And one of the issues that we're running into is kind of this data wall, right? Where state-of-the-art models are trained on 15 trillion tokens, right? And that's actually about the same amount of data that's available on the whole public internet. So then the question becomes, like, if we want to continue to build better and better state-of-the-art models, where do we actually get that data? Companies have realized this and have realized that that makes their data very valuable. So they've actually kind of locked down access to their data. Reddit, for example, and Stack Overflow, they changed their API terms to make it harder for developers to access. And what that also allows them to do is to charge more money for access to data. And so we're kind of in this situation where the places where the data lives is getting continuously more locked down so that those companies can earn from the data that they've collected. Something that a lot of people don't realize is that users legally own all of their data. So in the same way that when you park your car in a parking lot, the parking lot doesn't own your car, right? You can always go get it back. They can't like randomly take your wheels from you. It's yours. When you put your data in a platform, it's exactly the same kind of legal rights. So all of your data sitting inside of a platform, you can always go and take back. That's true for Alexa, 23andMe, Instagram, Google, even Tesla. That data is always available to the individual user. Sometimes it's inconvenient to get because they don't make it that convenient, but there's kind of regulations where they have to give it to you within 30 days. Something that could be a fun exercise if you have an Instagram account is going and exporting your data, because they give you not just like the images and your messages and everything you've generated, but actually also the AI labels that they've generated of you. So one AI label that they had generated of me was stressed but not depressed. And it's like actually hilarious. Like it's like a list of 300 things and you're like, oh my gosh. Like, so yeah, that's a fun exercise, but all that data is yours. So what we're doing with Vana is really unlocking this data from walled gardens through the user, right? So we're in this situation where each company has kind of a stronghold on their data set, but every user can export their data from across different platforms and pool it together to be able to create larger data sets. So how it works is that users export their private data from these different platforms. It's always possible due to data regulation. Actually, with the Reddit data DAO, which has 140,000 users in it, Reddit actually came in and was asking, hey, is this allowed? And they actually tried to shut it down. But because of individual data rights, where the users have access to their own data, it was able to stay up. And then users pool their data into verified pools, and they're able to make decisions over how the collective data set is used, right? So if you just have like only my data, it's not that useful for training an AI model because it's not enough data. So basically these data DAOs, DAO stands for Decentralized Autonomous Organization, but you can kind of think of it as a labor union for data, where people are able to take collective action over this overall data set. And that's enforced at like a cryptographic level. So yeah, there's a bunch of different kind of available data across all the different data DAOs. Nick showed some of them. So there are about 50 people full-time just building data DAOs on Vana. So each of these teams is kind of led by their own leader. The Tesla data DAO is one of the first venture-backed ones, so they're collecting Tesla data. There's also, Telegram, which has message data, Spotify, a bunch of music data. And so, I can share a URL where you can go explore the data DAOs if you want to contribute to them too. And if you want to start a data DAO, you don't need anybody's permission because you are using individual data rights, right? So you don't need to ask Spotify if you can start the Spotify data DAO because individual users have that right. I think it can be good to kind of look at high-level benchmarks of like how much data is there really in these different platforms. So if you compare Llama 3 training data of like 15 trillion tokens with 100 million users who contribute data exports from 5 different platforms, you can have 30 times as much training data than any single centralized company has, right? So it's really a huge amount of data. Obviously 100 million people, that is an undertaking, right? We're 1% of the way there, but we're not there yet. But you really can sort of have a much bigger data set than any single company. Users also have a lot of compute. So actually, if you look at, I don't know, are people familiar with like the Ethereum mining process? Maybe to some extent, just that it uses GPUs. Okay, cool. So like if you look, I mean, now it doesn't use GPUs anymore, but back when they were still using GPUs, if you add up all of the compute that they were contributing, it's actually 50 times more than the estimated compute to train GPT-4, right? And obviously, there are kind of efficiency questions of can you use this compute as efficiently as possible, but even if you take a 10x hit in efficiency, you still have 5 times more compute, right? And so I think this is an important kind of benchmark to keep in mind as well. And then once you have those kind of model weights where you've trained the best foundation model with all users contributing data, you can have collective governance and ownership. So users get paid when the model is used or paid proportionally to how much their data improved the model. The collective can set usage rates so they can decide who's allowed to access the model, what sort of controls should be in place. And you can also have national models that represent kind of different cultures and ideologies. So I think a lot of people assume that foundation models tend towards monopolies, and it can only be built by kind of these single companies because it takes so much research, data, and compute. And it's tempting to say, okay, we're just going to take the open source models and try to make them a little bit better. But we actually kind of, as a collective group of like users and researchers, actually have the most data than any single company, right? And so if you can solve that coordination problem, you really can train the best AI model. So following on kind of the Vana Flower partnership, really what we're doing is combining Vana's focus on data and really aggregating all this data into these different data unions and Flower's expertise as this leading federated training framework, right? You need to be able to train a model in some way across all these different data DAOs. I think too, like, I remember when I first saw that Flower had achieved, it was just the 1 billion parameter model in a distributed way. But I was like, that's amazing. Like, I think a lot of people assumed that wouldn't be possible, right? Even a year ago or maybe a year and a half ago, people were like, oh, maybe you can do fine tuning, but the foundation model stuff is going to be really hard. But they've really proven this out in a very impressive way. So yeah, the first user-owned foundation model, which we've named Collective One, is important for a few different reasons. So the first is that it's the first of its kind to be going beyond this web scrape data. That's pretty much all of what people use today for the leading LLMs, but instead you're able to access this user-contributed private data that even the centralized companies don't train on. So I think often people might assume, oh, Facebook could train on Facebook messages, right? It's sitting in their servers, but they actually aren't able to do that. My co-founder, he used to work at Appen, which is the big company that sells data to big tech. And there were cases where some of the big tech companies were buying message data from their own platforms because they didn't have the legal right to train on it. So you actually do have a lot more data available in this way. Second is user ownership and control, right? So you have these foundation models that are increasingly playing a large economic role in society and giving users true control over both getting paid as they help to kind of contribute to the AI model and as it gets used, and also deciding what should be allowed or not allowed for the model. And this is really breaking through the data wall that currently kind of limits the largest AI companies. Because of the new ChatGPT Studio Ghibli thing, I just generated some of these to see how it looks. So yeah, this is just a Studio Ghibli interlude. Okay, and then the end goal. So I actually think this is a really important point where I think that often the open source community today takes the approach of almost how do we catch up to the best benchmark that the big labs have, right? And the best goal in mind is how do we get as good as them? But really the question should actually be how can we be 10 times, 100 times better than any kind of centralized company can necessarily create? So the reason why this Collective One model is so important is that it really offers this path towards 100 million users contributing data and kind of creating this pool of training data that's larger than any single company. And I think that that's very important in this context of AI playing a larger and larger economic role in society. In terms of how kind of training Collective One works, basically users contribute data to these different data DAOs on Vana. There are 1.3 million users who've already done this, so you have a whole bunch of different data DAOs already there. And the data remains in secure compute that's controlled by the DAOs. So each of these kind of unions is basically controlling their data pool. And they can then grant access to say, I want to contribute to Collective One. And then Flower's federated framework runs inside that secure compute environment to actually run the training and then passes back those weight updates. And you can scale this process to millions of contributing users. Kind of going into a little bit more of the detail. So when a user contributes data to a data DAO, they're encrypting their data with a key that's controlled by the DAO. What that allows for is when the DAO approves code to run on their data, they're able to say, okay, this code is allowed to run this federated training code, and then that code gets run in the secure environment, but only the output leaves. Something I'll mention too is that the data is verified. So one of the issues you have with any sort of group of people pooling their data is that, say all of us are pooling our WhatsApp messages. Someone who wants to take more ownership of the data set could try to pretend to be 100 people and contribute a bunch of data that's not actually good. So there's something called proof of contribution, which runs on Vana, where every data point that's going into a DAO actually has to be verified for that specific data DAO's requirements. And that also involves kind of valuing the data set relative to each other. So for Reddit, for example, it was based on the square root of your karma. If you have more karma, your data is kind of proportionally more valuable. For the 23andMe one, they treat everybody's data equally. And then, for each DAO, you kind of have the secure compute environment, which can decrypt the data and run that federated training. And then the weight updates are combined across DAOs. I wanted to talk about some future research areas as well. So one is federated inference, right? So once you have, suppose Collective 5 is better than GPT-7, right? Suppose you're kind of out there and you have an extremely powerful AI model. Then the question is how do you ensure an extreme level of control? So Vana is relying on trusted execution environments for this code. If you have billions of dollars worth of model weights in there, you kind of want more security than that. So actually being able to split the model weights across different compute environments and then run federated inference, there are kind of like some scalability issues here and performance issues. The other is data quality evaluation. So right now, the data quality evaluation happens just at the data DAO level, where as it comes into the data DAO scoring it, and then Collective One can kind of access that data. I think in an ideal case, having actually like model influence functions where you're measuring at an individual level each user's data contribution and how much it's helped. So improved privacy frameworks I'll mention as well. So for these model weights, sort of keeping it in a secure environment and then making sure that inference is someone's not running very strategic inference calls to kind of like try to recreate the data. So that's kind of the security requirement today, but I think having better and better PII and kind of privacy frameworks to manage that. For full edge compute, so not just training in the data DAO secure environment, but actually being able to train on end user devices. I think this is much further out, but I think is kind of good to keep in mind. And then I'll also mention health specific data because I think that that's one place where things are really constrained. And it actually allows me to also talk about kind of the unique regulatory framework of Vana, where the user is acting as their own data processor. If you kind of have worked with data regulation, what that means is that the user is their own data processor and data controller. I think a good analogy is if you've like used Bitcoin or Ethereum, Bitcoin isn't acting as your bank. You are your own bank because you're kind of controlling the private key. And in the same way, Vana does that for data. So it actually turns the user into this data processor, which allows you to work with really private data, medical records, kind of other patient contributed medical information. So if you want to learn more, here are some details on kind of the partnership, the Flower docs, and the Vana docs. Also, if you have data requests or ideas, there are always people kind of looking to start a new data DAO and focus on a new data set. So just send that. Literally just email me what data you want, and we'll find someone who can start a DAO to try to get it for you. And yeah, happy to take any questions or anything that might be top of mind.
So we have a panel coming up right next, and so perhaps we can take a few questions while we set up for the panel. I think that would work. So while we take a few questions, maybe Patrick first. We can set up for the panel. Okay, sorry.
Thanks for the interesting talk. So I've got two quick questions. First, what if users steal the data and they contribute to the system, because there's no verification mechanism to check the ownership of the data, one. And then who runs the DAO? It seems to me that the data is revealed to whoever runs the DAO, unless a TE is running that. Thanks.
Yeah, so on the first question, from an ownership perspective, that's checked in proof of contribution, and the data sets do it different ways. So with Reddit, for example, they require that you put a code in your bio to basically prove that it's actually your data. And then in other cases, like there's one that's doing exports of ChatGPT, and that checks proof of ownership by having, when you get the export, you get an email, and you basically have to forward that email to show that it's actually your data that controls the account. But it depends per data set. Some, if you're familiar with any like ZK technology, some are using ZK-TLS. The Amazon one is generating a ZK-proof client side. So it depends, and I can actually send you some links to how different like data DAOs are doing it, because that check is really important. If an account were so if somebody had hacked your Spotify account and they had full control of it, they could contribute, right? So that doesn't protect against that, but it does protect against, are you actually the controller of this account? And then on the compute side, I think this is always this question, right? Of like, you can have like, yeah, where do you work with data that is unencrypted, right? And so the guarantee that a TE provides is that nobody can actually get inside of that environment and see the data. And so there's a network of different TEEs that are running these operations. It's more constrained what you're able to do in them, but that does provide kind of a strong guarantee. And then the other thing I'll mention is at the individual level, in some cases, people are just running things client-side on an individual user's data to then submit a proof to kind of show data quality.
Let's just take one more. I think, Patrick, you had your hand up. So.
So great talk, first of all. I had a question about the attribution of revenue associated with data itself. So it sounded like you were doing some kind of data quality at the outset in terms of establishing what the value was of that data. But for different downstream tasks, I would assume that that can vary a little bit. So how configurable is that, and how do you actually attribute that after the fact?
Yeah, so it's done at the smart contract level, and I abstracted a lot of the blockchain stuff away for this group, but I'm also happy to dive into that too. There's actually, so the Reddit model, there's an ex-Google Brain ML engineer who trained a model that honestly is mostly just good at shitposting because it's on Reddit data. But the way that works is that he created, so you have these data set specific tokens which govern the data sets. They kind of represent ownership of the data set. You can also create AI model specific tokens if you want. It's not required. And then you can require that that is burned every time you are running inference on that AI model. And so then everyone who's holding that kind of proportionally, their ownership goes up. But it's pretty flexible. And if you know Solidity or Viper, which are two programming languages for these smart contracts, you can use those. But we also have some templates to make it easy.
Thank you very much.
I think we can transition into the panel now because most of these questions are really going to surface as we explore. So could our panel members now come up? Oh, let's thank Anna again for that great talk. It's really inspirational. Could the members of our panel please come up to the front here? Thanks, you can grab a seat. Yeah.
Yeah. One more.
Yeah. 30 minutes. Sorry? 30 minutes.
Oh, cool. 30.
Okay. Okay, I think we can get going here. This is a very informal panel. We haven't had any prep work, and even the topic has been fluctuating a bit. Originally, I imagined it was going to be about open source AI. It would be a fascinating thing to talk about. I think we can dive into that a little bit. But then some of the topics that have been sort of surfaced early on today kind of stood on top of that. And so I loosely was thinking in my head, this can be the future of AI, sort of a panel. Where do we want it to go? But before we start, let's just introduce every person here. And in particular, I wanted to introduce Gabriele Manzini. So he is the architect and lead author of the EU AI Act. He is an MIT research affiliate and fellow. And so he can add another very fascinating dimension to this discussion, that of regulation and sort of like in a broader policy perspective to this discussion. So he is joined here by Anna, who we just heard from, the co-creator of the creator of Vana and CEO of Open Data Labs. We have Mark Surman, president of Mozilla, and then we have Daniel Beutel. He is the co-creator of Flower and the CEO of Flower Labs. And so we now know all of our panelists here, and you can see how there's really a rich mixture of topics that we can sort of explore. We'll take questions from the audience too, so don't be shy. But just to start with, I want to give Gabriele a chance to sort of dive in, because you haven't had opportunity to speak thus far. And so I was wondering if you could maybe tell us where you see AI regulation today. How do you think it's going? And how do you think it relates to some of the themes that have been discussed thus far?
Yeah, that's a great question to start with, and of course also quite complex. Certainly the picture is somewhat easy when it comes to the EU, because we have the EU AI Act. This has been a process I was involved in since the beginning, and it took quite some years, but I would say not too many years considering the complexity of the process. If you compare, for instance, that GDPR, often talked about, and today we are still dealing with the consequences of the GDPR and trying to understand a bit how AI is impacted by GDPR. It took about 4 years to negotiate. And actually GDPR came after the EU already had had for about 10 years what was called the Data Protection Directive, which was the precursors of the GDPR. So in fact, we already had in the EU some structures, some thinking around privacy that had informed then the GDPR.
And so when it comes to AI, the Commission, the Parliament, the Council concluded negotiations in 3 years, which, to my mind, was certainly, very fast compared to, the experience of GDPR, because we started from scratch. So I think that's certainly now, stick on the ground. That's and I've been traveling a bit around the world, and everywhere people are just want to understand more. What's the AI Act? What's the impact? They just want to know, because governments around the world are facing the same questions. But I see somehow a sort of a lot of doubts around it. So there are jurisdictions where they just simply copy-paste. This happens, for instance, in Brazil or in certain countries in the US, although none of these jurisdictions actually finalized. But then there are also pushbacks in those same countries where, are we sure we want to copy-paste? And in other jurisdictions, then there's completely different approaches. Like, for instance, recently Japan, actually they really didn't really look into that as a model, I would say. But certainly it's a topic of discussion, which deserves to be discussed, and I think that's probably the merit of the UA Act, to have really force a conversation about what does it mean to have trustworthy AI, how do we want AI to be in the next 5, 10, 12 years, 15 years, 20 years. But then when it comes to actually the impact, I think a lot of questions are still open.
And not to put you on the spot, but there's some interesting themes emerging that we've been discussing so far. I imagine there might be sort of newer sort of themes for what you've seen. People talking about decentralized, people talking about how users can kind of grab their data and train on it. What do you think about these ideas from a policy and regulatory perspective? I imagine they might one might imagine that they might make things more complicated, but perhaps you see how they might simplify other things. Any reflections on that?
Yeah, I'm not an expert in sort of decentralized AI. Of course, I'm a lawyer as a background. I definitely see there are lots of benefits in that. I mean, first of all, the fact that you actually can have these models being run more decentralized manner. So in a way, there's more control on the data for the inference, for the training. I mean, that's certainly something that only goes in the direction of more privacy. So, and certainly this is a topic that I think everyone agrees on. That makes a lot of sense. When I think about, indeed, also decentralized AI also means that actually you don't necessarily have access to the data, right? That, for instance, thinking about the AI Act, there is a provision there that says that, for instance, authorities may need to have access to the data. So which means that, in a way, on the one hand, decentralized AI allows training of models without necessarily centralizing all the data sets, but you still may have to secure somehow the access or make sure that you do have an access at a later point if that is needed to demonstrate that the model is in conformity with the law. Sure. So I think these things will keep coming back and forth, in my view, that you have, as new technology comes in, maybe certain provisions may become, some of them will be better enforced, and other probably will become more of an obstacle in some sense.
I see. And perhaps opening up to the rest of you, I mean, one question would be, each of you have a sort of, I think, an idea of what you want AI to become. Do you want to perhaps outline where you might want to see AI go? And then if there's anything from a policy or regulatory, what would be one thing you'd like to see change in that space that could help accelerate where you want AI to go? And maybe starting with Daniel.
Sure, I'm happy to take this. So from a regulatory standpoint, I think when I look at this, I always look at it from two perspectives. On the one hand, as an individual living in the EU, there's obviously I'm happy about the rights that GDPR, for example, grants me, and I think many of the ideas are very good and are deserve to be supported. As as a founder, there's also you can also some of the regulatory frameworks they also pose some challenges. Some of those challenges are actually good that they're posed, but then there's also some challenges that just that just don't make sense. It just increase the bureaucracy quite a bit. You have to do more paperwork, and you would ideally it doesn't help anyone really. What I find the most interesting, I think, and that's I think the part where also we all as a community interested in decentralized AI can come together and can support that, is I feel like a lot of the political discussions, not all of them, but many of the political discussions are very dominated by that old assumption that in order to do AI, you need to centralize all the data. And then some of the regulatory proposals and some of the public funding initiatives and a lot of these things, they actually start from this misunderstanding that, in order to train a model, you just have to have access to the data, which is just not true anymore. So I think this is a challenge for all of us as a community to just talk more about this and actually convince the necessary stakeholders, not just convince, but just educate, basically, and show them that you can build incredible AI systems, state-of-the-art AI systems, as we've seen today, without having access to the raw training data.
Yeah, I think from a data rights perspective, giving users more and more kind of guarantees around being able to easily access their data, right? So for example, being able to have a user get API access from their data. Right now, it can be kind of a cumbersome process to go and export it. I think it is really important that there's kind of a good dialogue between AI researchers and policymakers because the technology is moving so quickly, right? The way we train AI models 4 years ago is completely different from how we train them today, which is very different from how we'll train them in 2 years. So I think just keeping that open dialogue is important. Maybe one thing I'd mention on the privacy side is that I think the user perspective of privacy, I've seen it shift a lot recently, where it's gone from this maybe ideological or preference question of I don't want my data out there to much more of an economic question of like my job is at risk if somebody takes the data I've produced and trains an AI model to then do that work. And so I think that's really raised the stakes, and there are sort of policy implications of that as well.
So many things in this, and what an interesting group. I mean, I guess maybe I'll pick up on that. It wasn't the same 4 years ago, it's then now, and then 2 years and 10 years. And I think that's such a challenge because 3 years is fast. And I mean, I'm a fan of the EU AI Act. We've got to kind of work out the open source questions that got put in at the end. But, other than that, and like things move so fast. And we're trying to figure out how to build this balance between, the public and what society needs and what private actors, need in a fast-moving environment. Somehow there's got to be more adaptivity in the system. And I know that's not yours to solve, but I think really how we think about policymaking and balancing private and public goods is a really big nut to crack right now. And I think if I could wish some things for the GDPR and the EU AI Act or regulation in general in that fast-moving environment, I think you saw in California they added delegation of data rights, which you didn't have in the GDPR. Like being able to have innovations like that, be able to spin back in, because that's I don't know if you guys rely on that in any specific way, but to be able to have, if people don't know it, the Californian Privacy Act lets you say, well, I'm going to actually delegate to Vana or somebody else my data rights, and so that they can manage them on my behalf. And I think looking at speed of regulatory innovation itself is not an academic topic, but a very practical topic. And one kind of hack, open source, of course, is a hack on copyright law. I think one kind of a hack on speed of regulation is to look at public funding and industrial policy and look at the intent in a regulatory environment, very different parts of the government typically, but how do we use public funding and industrial policy to start to play with, in a more dynamic way, the intent behind regulation. And so if you look at, so the Airbus for AI or CERN for AI, those types of proposals, making those actually draw back to what's the intent in the AI Act, building an economy around the intent in the AI Act, building an economic zone that is adapted to those sets of balances between the public and the private actors. So I think there's something really to look at. How do we much more quickly and creatively use the tools that we have in the public sector, working with people who are building companies that are aligned with those goals? And I think we're not pushing ourselves hard enough on that yet.
Do you want to come in on that?
Yeah, I think also what Daniel said, I think I would agree also that some of the sort of regulator mindsets in developing regulations is really sort of fixing one problem, which is that of sort of big tech problem. That also has its own narrative about more and more data and more compute, and that's how you in the end in the AI Act you got into this like threshold of compute as sort of one of the benchmark to which after DeepSeek doesn't make a lot of sense any longer. Or in a distributed environment. Yes, this I was going to say, but I'm not competent to say. So and that's a bit explains a bit my frustration with that process, because it's kind of felt like that almost the policymaker felt into the trap of a narrative which was clearly from only certain actors, and that's of course a problem for the EU, because we can't just as you say develop an ecosystem around a really trustworthy AI, which is what we want, if we don't give ourselves the chance and we just keep raising the barrier of regulation higher and higher, that ultimately only certain actors can comply with. And so that's in my view a bit the problem that we need to fix going forward. So at that moment, better to have lighter regulations, so at least you have everyone is on the same. You don't set a threshold so high that only certain actors can reach.
I just want to maybe perhaps you raised a DeepSeek. It's sort of an elephant in the room for many of these discussions. So I was curious, how do any of you feel that DeepSeek has changed this type of discussion now? Meaning the future of AI, maybe how regulation evolves and so forth. It's definitely showing that open source AI is going to be more than competitive and perhaps going to be leading moving forward. So there's also this country aspect to it. So I'm just curious if anyone has thoughts on this.
I mean, it's not open source AI. It's an open weights model, and there's open source pieces. But I think so, and we also don't know really what happened. But I think that the narrative piece of it and the technical innovation we can tell, to me, it had two impacts. One is that the orthodoxy that you get from OpenAI and from Silicon Valley about the fact that it can only be centralized and only expensive and only the people with the most money, that was challenged, which opens the opportunity to then challenge what are the other pieces of orthodoxy that they have, which is that it can only be trained by scraping the web. You can't do performant models without stealing copyrighted materials, all these things. And to me, it's actually opened a really interesting conversation in just a few months, that we don't have to accept the orthodoxy to do state-of-the-art models. And you actually see that here. So when we talk about maybe you guys are the DeepSeek moment for federated learning and DAOs. Like, to be able to show that we can do this stuff a different way, that's actually, to me, the lesson of DeepSeek. And then, there's another part of the orthodoxy that it broke, which is the orthodoxy it can only come from the West Coast of America. And I think that really hopefully opens people's minds in some exciting ways.
I think the one part that you mentioned, I want to double down on that, and I think it's this going from one to N, going from just one place where this kind of innovation can happen and these models can be trained, going to N places. even if n is just equals 2 in that case, but it shows that this is possible also somewhere else. And it's possible with a method that just that doesn't follow the blueprint that came before it. I think that's the exciting part about it. I think there was also quite a bit of noise around the announcement, and I think some of the facts, they got distorted as more and more people start to report on it. I think there's also quite a few misunderstandings. It still required quite a bit of compute to train these models, so it's not something to downplay too much. But I think what I found interesting is that you can find innovation and great hacks in places where you didn't look before, and suddenly you get much, much better results.
I think one of the interesting things about DeepSeek is it really showed the power of high-quality data, where they started with an extremely high-quality data set that was created by like computer science and math PhDs who were just generating these logic data sets. Apparently, their founder was literally helping to generate some of these data sets himself, too. And if you look at the parent company, you can actually see they're hiring people to do this kind of like data curation and really high-quality data. And I think it does challenge this assumption where right now we basically just throw a bunch of relatively low quality data at models and like hope that if we continue to do that with data and compute, it will eventually create AGI. I feel like that's kind of the approach, but it shows like there are actually many other ways to do that, right? And I think that quality is really important from a user perspective because users can contribute really high quality data, right? And rather than kind of going and collecting whatever you can on the public internet, if you have users curate really high quality information, you could use a similar approach to create much better AI.
I think it would be a good time to open up to the audience. There's this question right in the back. I'm just going to run down there and we can see what question we have.
Hi, everyone. I had this question for Anna previously, but I'm happy to pass it out to the panel. It's because of the data right for me is that I have a consent to give you data, but anytime I want, I can have a chance to give it back. How it works in the AI world with the challenging, if you train based on my data, what's the way out then?
Yeah, so when you contribute your data to a data DAO, you are kind of giving them access to be able to make decisions on your data, and then you're taking that ownership of the data set. In some cases, data DAOs can give you the opposite, so you can basically give back that ownership and then have them remove your data. But if they've trained an AI model on your data today, then that AI model would still have learned information from your data. And that's similar to kind of all the situations with all the different big tech companies, right? Where even if you're deleting, it's actually kind of a case with 23andMe, which I've been talking about recently, where they actually have trained things on that data. And so even if you go delete your data, there's still some derivative of it in there. One of the things that I think could solve this down the line is federated inference. So if you imagine that every user has trained a small portion of the model weights on only their data, then you can kind of use them like Legos, right, and take them in and out. But that is an open research question today.
I think we had a question in the corner there.
Hello, thank you so much for the insightful discussion. My question is to Gabriel. Thanks again for opening with the contrast between GDPR and EU AI Act, which makes it super easy to ask my question, which is, where do these two regulations align? Where do they differ and in a way contradict? I'm particularly referring to Article 35, which talks about data processing for high-risk applications and the risk-based categorization in the EU AI Act. Thank you.
Sorry, could you just repeat?
Where does EU AI Act and the GDPR align? And where do they even contradict?
Yeah, that's a big question. The reality was that when I started working on the AI Act, there was no discussion around touching the GDPR. As you may know, the GDPR is considered to be almost as a crown jewel of the EU legislation. And so actually, President von der Leyen, when she announced the AI Act in her speech to the Parliament, she said, well, we have set global standards with the GDPR. We need to do the same with AI. So the approach was very much the same. So there was no question around okay, we have to now to have specific legislation on AI, which of course, creates certain challenges around, different type of challenges around privacy, or maybe different also opportunities. So we may want to perhaps address some of those challenges by actually looking just at GDPR. In reality, today, after all the process, I think the AI Act, as I said before, has some merits. But, if you just want to look at the actual practical implications of how to solve certain of the challenges around AI, which is, for instance, fairness, discrimination in decision-making. The GDPR already has quite important tools that can be used. So I see that, potentially we could have even imagined a situation where just leveraging the GDPR and making its enforcement stronger could have already been a good first step in preventing some of the challenges of AI. But the AI Act comes at a stage where, indeed, we sort of, we take for granted GDPR, we don't touch it, and we just wanted to add a layer of, let's say, how can I call it, oversight to the actual development of the system that processes personal data. So GDPR applies to the system as well while it processes personal data, and to the impact the system may have, to the extent it does an automated decision-making, for instance. But the GDPR does not touch, if you want, the training of the system. And so the AI Act comes at an earlier stage to basically try to impose on developers the way to think about these automated systems in such a way that they actually do not lead to certain risks. Or you try to mitigate the risk ahead of time. But, you can tackle the same question either upfront or afterwards by strengthening, if you want, remedies afterwards. But that's why ultimately, from my perspective, also considering the political reality that we couldn't change GDPR, I think it was clear that, we should just leave it as it is, but we limit intervention of the AI Act on a certain specific area and do this quite surgically. So that was the initial intention. But ultimately, things turn out to be quite different. And also, actually, we see today almost overlaps between GDPR and AI Act, which actually, it's not, in my view, really a good thing going forward. But the logic ultimately is very much aligned, to really focus, with the exception of the part of general purpose AI models, I would say, to really focus on sort of trying to prevent risk on sensitive areas that impact people's lives, so where you process personal data.
We have a question just in the front, and then we'll go to the back.
Yeah, maybe a very short one. On the data privacy or privacy in general, is the common opinion that TEEs are the solution for basically securing data in use, or because of the trade-off of performance and then privacy or data security?
So in some cases, yes. So if you are just running compute on your own data, then you don't need a TE because it can just be in an environment that you control, right? So if you're familiar with Solid Project or Urbit, they've taken a similar kind of federated approach. But then the question becomes if the four of us all put our data together, we can't use any of our compute environments because we would have to trust each other. So that's where the TE is used. If you have full kind of federated training and federated inference working, where you could go across, each of us trains our full piece and then each of us runs inference across our full pieces, then you wouldn't need that TE. But in terms of what's required to actually build a state-of-the-art model today, you do need to rely on that. And there are pretty good kind of security guarantees around that. There's kind of, SGX and TDX, which are two of the different kinds of TEs. But it is the case where if you had model weights that are worth $5 billion, that's not a good enough security guarantee. But if it's an individual data set, it's quite a good guarantee.
Cool, thank you.
In the back.
Yeah, this is something to do with the cultural relativism of being of data sharing. As you know, being able to share data is culturally relative, right? Some countries are more willing to share their data. Some countries are less willing to share their data. Would you think that would be the difference why most of the AI companies are going towards countries that are less sensitive in sharing data or respecting copyrights than countries like the EU, where we really don't see a lot of AI companies being formed here?
Anyone?
Well, I think there's a lot of reasons for it. I think the current generation of AI systems just requires massive amounts of compute, and that requires massive amounts of resources. So in order to start out in that area, you already need to have some kind of a background. Even if you start out as a startup, you need to have the right, you need to have access to investors who are willing to fund that journey. I think, from my experience, I've seen how this works in different countries. As Flower Labs, we went through Y Combinator, so we've experienced the US network firsthand. And I can say that just in terms of just as a startup founder and as looking for investment and a network and things like that, the Silicon Valley ecosystem is unparalleled. And I knew that beforehand, but I didn't know how big the difference between the Silicon Valley network and other areas around the globe are. There's a great startup culture in the UK, in London. There's great startup culture in Berlin. But really, the ecosystem that we see, that I've seen in the Bay Area, is just unparalleled. And I think that's a big reason why a lot of this movement is happening there.
Anyone else want to weigh in, or we can take one more question? Well, unless Marky, you look very tempted.
I'm torn because I want to say something kind of political. So I mean the wealth flows back to Rome, and so I think that's true. And the ecosystem is there because the money is there, and so the money keeps going there. And so I do think also we have to kind of look at where the money is and what are the things that counterbalance that and get the money in the right places, or fragment where the money is. And I think that is a key piece where you can start with smaller resources. And there's a cultural piece as well, but I think the kind of things we're talking about now are things that can make smaller things actually grow with less resources to start. So I think that is one piece. But then the other place, I think the data thing is a piece of it, but it is actually also kind of approach and power. China is the other place that has jumped forward, and that's because there's an incredible centralized intent about where to take the economy. And so that's where I think in Canada or in Europe, we actually are too shy to take the centralized intent and say, that's when I talk about industrial policy needing to express what's in the AI Act. Like, we could have a centralized intent around distributed, democratic, technical systems and building an economy with them, and we are wimpy about it. And so I think that's actually part of the piece, is to kind of have the forthrightness, and we have done this in other eras with democracy and to build socialism and social democratic systems. So I think there is a question of like forcefulness and political will to build an alternative.
Very interesting. One last question.
Yeah, the topic of economy and money leads into my question perfectly, actually, which is, especially in these use-your-own models, you're training them with TEEs, which solves a lot of the trust problems, but how do you solve, like, TEEs are, at the end of the day, they're still computers, still hooked up to the power grid, still consuming resources that come out of someone's wallet, right? Who's that wallet when you're talking about such a decentralized governance framework, right? Because when we're talking, this is a problem that's not new in FL. It comes up a lot in cross-silo, for example, where you're having to coordinate institutions who are pulling resources together, and you devise governance frameworks for that. How do you apply that to somewhere like DAOs, where you don't have such a clear owner, right? Who owns the DAO? It's already a collective system, so who's actually funding it in this scenario?
Yeah, so in the same way that Bitcoin and Ethereum, who's funding an Ethereum node, it works the same way for Vana, actually. So it's all managed by the network. So you can run a TE and then you earn based on the kind of compute that you're providing. Right now, that list of TEs is kind of whitelisted for security reasons, but it is a distributed network of people actually running this. And you have some redundancies where if one of them drops off, you can have it in another TE instead. But I do think that is one of the centralization points, right? Where at the end of the day, wherever those model weights are, you can pull the plug, right? And so you kind of have to think about when you're designing this resilient system, both where can the compute run on the unencrypted data, and then also where do you store the encrypted data? And Vana is storage agnostic, actually. So there are a bunch of different storage providers. You can use IPFS, which is decentralized storage. You can also, as a DAO, opt to use a centralized storage option or use both. Or you can have the individuals all store data on their own storage accounts, but then you run into issues if they don't have kind of availability of their data.
And I just want to add one thing. In the same question sometimes comes up with local AI. So I think in the end, it all comes down whether you provide something valuable to the user or not. We've seen this transition with the rise of personal computing and the internet. And the same question applies. Why would I spend money on a computer? And why would I plug it in at home and pay for electricity? But if you build something that actually is better for the user, gives the user more value in whatever way that is, I think users will adopt it, and they will love to adopt it.
Okay, so with that, thank you very much, panelists. It's been a fantastic panel. Okay, so for the in-person folks, our next session will be over the road in the Big Chill bar over there. There's an after hours. I encourage you all to attend and network and sort of workshop all these interesting ideas. For the people online, we have a special bonus content for you that will be played based on other talks, other posters, other technical material that's been gathered through the community. And so thank you very much for day one, and I'm looking forward to what day two brings us. Thank you.
Welcome everyone again. With that, we had just a great session of the panel talk with a lot of cool speakers. We've had so many good presentations over the last couple of hours, and we will be back tomorrow on site and also online here in all the streaming services. So definitely stay tuned for more. There's still much more to come. And if you want to connect with us, you can always put your questions and comments down here in the chat, wherever you are tuning in from. But also feel free to reach out to us in Slack, on social media. Check out flower.ai, our website, for more information. And as Nick was just saying, there will be some videos running for you to see. There will be some online presentations, some extra material that you can listen to, watch, see what people are working on when it comes to Flower. And yeah, so as I was saying, there's definitely more to come and much more that you can enjoy. So with that, I think we will wrap up this online live stream. And it's been a pleasure talking with you, interacting with you in the chat. I hope to do so tomorrow as well. Stay tuned for more, and we'll be back very soon with more material, more Flower, and more federated AI. Thank you.
Hello, everyone. I am AWS Senior Solution Architect Ray, and I'm very happy to be invited to join today's sharing hosted by Flower Lab, which is Flower Summit 2025. Today's my topic is federated learning, Flower on Amazon SageMaker AI. I will also sharing a story in Taiwan, which is an insurance customer. In Taiwan, we co-work with partner Nitron and the customer Xinguang Insurance. We have some demo and prototyping in the fintech space, which is a government's conference. And you can find the detailed information in the reference link here. During the process, we encountered 3 challenges our facing consideration. One is in Taiwan, a lot of financial customer and insurance customer have concern to directly upload their data to the cloud. So we need to prepare training data, which not directly upload it. We're using some tool to generate the data. After we have the training data, we need to consider how we can conduct the further learning on the Amazon SageMaker AI, which is Amazon machine learning framework. And the last but not least is the executive level and the manager have concern like Flower is very powerful and SageMaker AI also have a lot of feature. But how to make sure they already follow the best practice and there is nothing missing. So we're using the mechanism called well architect review, which is using the customer lens questionnaire to interview customer to make sure they already follow the best practice. So we start from the SDB. SDB is a Python library which we can using it to generate the training data. In the SDB, we are hosting it in the on-premise environment, and they have some different approach to generate data. And both approach need to provide the original private data. And the SDB can generate data with the statistical approach or deep learning approach we call GAN. And in our story, we're using Gaussian mixture model to mock the data distribution and generate the bulk data. And during the process, the customer manager and the executive level also ask some question like how federated learning can training the model together without sharing the private data. We're using the architecture and the flow diagram like below, which is the data parallelism diagram. In the data parallelism part, we have the parameter and have data in different rack. Like a federated learning, we have the data in different BU or company. And each rack can train their own parameter and get their gradient with their local data. And after the gradient is calculated, they can send to the server side and aggregate it together. And we can update the gradient to the parameter to all of the, and scale out to all of the different racks. So federated learning can do the similar approach. We training the data by ourselves, the local data, and we update the gradient, not update the data. After the gradient is aggregate, we can update the parameter to finish the cycle. After we mitigate customer concern about how federated learning is really work, we start to introduce Amazon SageMaker AI, which is AWS machine learning framework. Amazon SageMaker AI, with this tool, you can build a model, train a model, deploy the model, and monitor the model performance on it. So you can imagine that machine learning end-to-end framework and end-to-end challenge can be mitigated and resolved with SageMaker built-in feature. So we can using SageMaker AI in federated learning too. But how we using SageMaker feature to handling the federated learning problem? So we start from the right-hand side. We have a SageMaker notebook, and the notebook is where we run in the Flower server. And we also, if the Flower server start, we can run in the training job, which we run in the Flower client here. And the Flower client can read the private data set and train the model and update the gradient to the server side. And the server side will aggregate it. And either communication is through the VPC query. So, like what I mentioned, Amazon SageMaker Notebook is very important. That we can using the SageMaker Notebook as a Jupyter Notebook on the EC2, and this notebook can be used to prepare and process data, writing your training code, and you can even deploy your model from the SageMaker Notebook. After your Flower server is start, you can find the Flower server log in the console, Jupyter console. And the Flower server log will waiting for the client to start communication and update the gradient. And then we can start the SageMaker model training, which we run in the Flower client here. Like most of the people know, the Flower support multiple machine learning framework like SageMaker model training support. So we can choose the machine learning framework which support both by SageMaker model training and the Flower framework, which can minimize your effort to writing the training code. And during the training, we can consider using the management Spot training job, which we can use in Spot instant and saving up to 90% of your SageMaker training job cost. But there is some trade-off. During the Spot instant running, there is some process like bidding. So we will provide a price. When other people provide higher price, your Spot instant will be recycling. And so you need to persistent the checkpoint during each round of process to make sure next time you get the Spot instant, you can resume your training job. And then for the Amazon SageMaker model deployment, you have two parts need to focus. One thing is you need to run in the machine learning framework container in the SageMaker deployment. And then you can pull the model in the S3 and the deployment to the SageMaker. And how to consider it as an end-to-end federated learning ops workflow look like. You can, like what I mentioned, it always start from the server side, and the server can start a Flower server and send a notification to client, and the client side will can trigger the training with training data, and after the gradient and aggregate it, after the whole process is finished, it can get the model and register the model to the SageMaker model registry. Yes. And the last but not least part is the how we can review our workload is following the federated learning best practice, including Flower and the SageMaker AI. We're using the customer lens architect review to review that. And you can scan the QR code, which include a JSON config file. You can upload a JSON config file to the your AWS console, and you will get the questionnaire in console, and you can interview by yourself or ask help from the AWS solution architect. Interview all of the questions will make sure you already follow the best practice. And this is the takeaway of my sharing. We chose the Flower framework because it's framework agnostic, like SageMaker. And you can prepare data and writing the training code with SageMaker Notebook. And when SageMaker model training, you can consider Spot instant. And you can follow in the federated learning ops guideline, which we mentioned above. And the last part is the customer lens architect review can help you to review your workload and follow the best practice. Okay, this is the end of today my sharing. Thanks for your time.
Hi everyone, my name is Nicholas Konze. I'm a medical doctor and GP in training, and I'm also a graduate of the Master of Science Applied Digital Health course from Oxford University, where I graduated in 2023. And today I want to talk about federated analytics in a primary care network in my position of head of data science at the DocPort Primary Care Network. And I want to talk about a decentralized research approach to primary care data. Just to give you a very brief overview, our mission is to empower healthcare professionals with innovative technology and actionable data insights to deliver state-of-the-art primary care. And our network consists of around 20 GP practices in the area of North Rhine-Westphalia with roughly 180,000 patient encounters per year. And we've been moving from a brick and mortar business to a rather data-driven approach during the recent month and year, and want to bring innovation to primary care in Germany. Just to give you a very brief overview over the primary care landscape, we have roughly 45,000 GPs, mostly working as self-employed doctors in single practices, so kind of isolated from each other. And at the same time, we see that 1/3 of GPs are aged 60 and above. This means we do see a skills shortage in this area of the health system. And together with an aging population and more economic pressure on the healthcare system, it's a steadily increasing workload, a rather declining quality of care, and more venture capital-backed companies entering the market, trying to win the fight for data. We all know that primary care data contains valuable information about examination results and lab values, about symptoms, complaints, about family history, socioeconomic status. But while some of this data is shared, for example, for reimbursement reasons, most of the data stays unused within the silo of the practice. And here with DocPort Analytics, we are starting our endeavor to enable general practitioners to make use of their local data insights. We have instruments for measuring or for visualizing accounting and controlling statistics, showing key business figures, appointment utilization, revenue statistics, and also looking at quality of care indicators. We are doing this for chronic disease like diabetes, COPD, asthma, and on a patient level, we are looking at risk factors, pre-existing conditions, medication for the individual patient, trying to support the doctors to adhere to national guidelines. But there is one very big challenge remaining, and that is that primary care data is spread across the silos. As I said earlier, we have roughly 45,000 isolated providers and more than 100 different practice management systems. So the database structure differs from practice to practice, from country to country. And we are in a unique position at our network that all practices are using the same database infrastructure and also network infrastructure, IT security. That makes it easier for us to look at data across practices. And then obviously what comes to mind when we're talking about decentralized data, we have been starting to work with Flower as a partner for federated analytics as the most basic use case in our scenario where we are working with limited budget and time resources. Federated analytics was the first approach that we took to leverage more insights into the data. And here we have a team of researchers creating study requests, for example, for quality indicators for chronic disease. Then over the Flower server, this is sent into the respective practice or practices. We have Docker containers running our client and then accessing the Postgres SQL database from the respective practice. And then very importantly, at this point, we use a business analytics tool to visualize the data that we want to centralize or to aggregate using Metabase. We show this to the GPs. Every number that is going to be shared is displayed. Like in this case, statistics about the number of patients being seen, the number of diabetic patients from the last year, and then also the mean H1C value, so an important lab value for long-term outcome of diabetes type 2. And only if the individual practices or the doctor confirm to participate in the study, so confirm to share their individual statistic results, this data is then over the client server infrastructure being shared with the server and securely aggregated for further analysis and statistical evaluation. So by this, we're using federated analytics to enable the GP network to leverage data insights across practices. And by now, we're using this mainly for preparation of studies, cooperations with industry and research, but also for benchmarking to highlight differences between the practices and the care processes. There are obvious advantages that you all know that come with federation of research. We have secure encryption installed and also privacy-enhancing measures like secure aggregation. We avoid the centralization of any private patient data, and this is right now being checked by a law firm whether it adheres to the strict legal framework in Germany. But we can see that the statistics and insights are very granular regarding quality indicators or benchmarking purposes, very powerful. And then obviously the next step could be or will be to use the pre-existing infrastructure for federated learning like prediction models or large language model fine-tuning. From the numbers of the participating practices, so practices that have manually agreed to participate in our baseline calculations, we see that in the 30 practices that are participating, we have calculated roughly 75,000 patients with at least one encounter per year, 210,000 encounters in total. And in the practice database systems, we see roughly 0.5 million patient records that could potentially be used for long-term analysis or for the training of risk prediction models, for example, for early disease prediction, or also for the prediction of long-term outcomes of chronic disease. We want to look further into some of the fields that I mentioned on this slide. As you can imagine, there's endless opportunities looking into diabetes, COPD, asthma, but also into psychiatric disorders like depression, and the character of longitudinal healthcare provision associated with GP practices makes the potential impact of these research and AI applications so powerful and so promising. To take this further, we are partnering with public and private institutions like the Institute for Artificial Intelligence in Medicine of the University Clinic in Essen, but also talking to medical associations and to other GP networks to take this idea further and to enlarge and to grow our network of participating practices. In a nutshell, data science in our primary care network using the federated infrastructure of the Flower network allowed us to do benchmarking and disease statistics next to the local insights. But from now on, as soon as we have the funding and the personal resources, we will look into federated learning and more precisely into a first risk model for early detection of chronic kidney disease, but also into fine-tuning of large language models for named entity recognition. And we would obviously then like to partner with more institutions for cross-practice studies. As I like to end, smart GP practices are the base for quality-based primary care, and quality-based primary care is the base for a healthy healthcare system. And so I am grateful for your attention. Thank you. Let's connect. And I'm also
Hi everyone, my name is Sana Ayrumlu and I am currently a machine learning specialist at the Backdoor Institute, and I will present our work named FL for Help, which aims to enable private and personalized modeling of clinical data sets. This library is built upon on the foundation of FL and Flower, and it leverages many of its key functionality. Before diving in, I'd like to acknowledge my collaborators, particularly the ones in the Backdoor Institute, which are the main contributors to this library. I also want to recognize our external collaborators from University of Waterloo, University of Toronto, and Mount Sinai Hospital. So what is FL for Health? In FL for Health, our mission is to simplify federated learning research and deployment, making it more robust and reproducible with a strong focus on healthcare and clinical models. To achieve this, we follow three main design principles. First, FL for Health is an open source platform with fairly straightforward and modular components. Second of all, it enables through federated learning, training, and evaluation in clinical institutions. And lastly, we design in a way to minimize the need for extensive component definitions, making it easier to integrate with the state-of-the-art models. Our key framework assumption is that we are performing horizontal cross-silo federated learning. This means that we assume that feature spaces are aligned or can be aligned for training, and the clients primarily collaborate each other by expanding the dataset size. Second, we are working with a small to medium number of clients, each client with substantial computing power and reasonably large compute resource, and they have reliable partitions in the training process. Lastly, personalization and privacy are key considerations. Different hospitals use varied device settings, introducing heterogeneity as a common challenge. Additionally, since clinical data is highly sensitive due to healthcare regulations, ensuring privacy in training is top priority. In today's talk, I will focus on some of the highlights that we added during the last year. While I won't deep dive into the specific of each component, I would like to let you know that my colleague David gave an insightful presentation on this topic at the last year's Flower Summit. So for those who are interested in a deeper dive, I recommend checking this out. In the first series of addition, our goal is to address some of the key challenges in federated learning and offer solutions through our library. I'll highlight three of these challenges and the corresponding solutions we implemented. The first challenge is improving communication efficiency in federated learning. We observed that traditional methods like FedAverage usually exchange the whole model, and this can lead to some kind of communicational overhead. The first solution that we provide for such a problem is sparse parameter exchange. So instead of transferring the entire model, we only exchange parts of it. And our hypothesis is that weights that experience the most significant magnitude change during local training contribute to the most of the domain shift across clients. With this in mind, we implemented two main methods two criteria to select the weights and just share those one. The first one is that we want to share the weights that show the largest magnitude change after local training. And the second one, we choose the weights that undergo the most significant relative change. While FL for Health supports these two methods, we also have this flexibility to add any custom criteria for weight selection. Another solution to address this challenge is to adapt the FedPM method, which presented at last Flower AI Summit. This approach takes a kind of a different direction compared to the previous method that I mentioned. And the key idea is to sparsify random networks using a binary mask to achieve the best local performance. FedPM proposes freezing the model weights at their initial random variables. And next, the clients collaborate to train a stochastic binary mask, aiming to find the optimal sparse network within the original model and share them with server for Bayesian aggregation. By only exchanging this binary mask, we reduce the communication cost a lot, and also such a collaborative process results in better pruning compared to the local training. One other challenge in federated learning is the model selection and checkpointing for deployment. Such a practice in federated learning is more complex than traditional machine learning due to multiple rounds of training and existence of various clients and servers. Following the traditional ML approach to tackle this, for server side, we introduce a global checkpointing method, which for each aggregation round, we evaluate combined validation performance across all clients and select the best model. On the client side, while we adopt the same approach, meaning that after local training, each client saves the model with the best validation performance on their local data in each federation round, we also implement an early swapping module, meaning that we basically track the performance of local training, and we stop training if it is overfitting. While this approach might lead to have different numbers of training steps for each client, we can ensure that we always share the best local model with server for each iteration round. Another challenge we face is to ensure a good generalization, especially when models are distributed to also other institutions for deployment. To address this, we implement a generalization adjustment mechanism to ensure fairness and improve generalization across clients. This adjustment happens during the aggregation phase, where we modify the representation of client parameters. Specifically, if the global model underperforms compared to a client local model, we increase the contribution of that client's weight in the aggregation. On the other hand, if the global model outperforms the local model, it indicates that the necessary information has already captured and no adjustment is needed. This adaptive weighting mechanism helps the global model generalize better to the newly introduced clients. Another set of additions to the FL4Health library is the integration with other libraries to facilitate the training of wide range of models. The first major addition is the integration with NNUnit, one of the largest and most widely adopted platform for segmentation in medical imaging. As we know, medical imaging datasets are highly diverse and often require manual design and optimization solutions. However, NNUnit automates the configuration and optimization of models for a given training set, eliminating the need to manually address parameters, training strategies, or layer configurations. NNUnit is seamlessly integrated into FL4Health, enabling the state-of-the-art federated medical imaging segmentation. This integration tackles NNUnit's high computational and memory demands and optimizes FL4Health for large-scale experiments and better generalizability. Some of the key components of this integration include the support for NNUnit's deep supervision, mixed precision training, and robust multi-process handling. Additionally, such an integration introduces new clients, server, metrics, and utility functions, and makes it easier for medical researchers with limited software engineering expertise to use NNUnit in federated learning setting. Another integration we are aiming to fully support in FL4Health is the integration with Hugging Face. While we started some preliminary efforts, there is still work to be done to fully integrate it. This integration goes beyond just using Hugging Face models. It's about leveraging the utilities they offer to enable decentralized and distributed local model training in federated context. To achieve this, we start by providing multi-GPU support in high-performance computing environments, enabling each client to use multi-GPUs with different sharding variants. This means we are working on incorporating various levels of sharding techniques to incorporate more to perform a more efficient training. Such features will support addition of advanced federated learning methods to the library and allow for newer training techniques such as prompt tuning, supervised fine-tuning, and reinforcement learning with human feedback in a federated setup. Lastly, I'd like to introduce our user-friendly platform, the Florist API. This API is designed to make managing federated learning training in healthcare seamless and accessible. It serves as a front-end platform tailored to clinicians. And you can see that in here, I put a picture of the dashboard of the API. And also you can find a barcode if you want to scan and access to the source code of this API. This API on the backend is powered by FL4Health library, providing capabilities for logging, training matrices, and storing a model result, which ensures that both the development and deployment process are smooth and efficient. All of these integrations would not be possible without the invaluable collaborations we had with various groups, which I like to acknowledge them. We worked with Haider Lab at Mount Sinai Hospital, whose motivation helped drive the integration of NNUnit in our platform. We have collaboration with Shihi's privacy group. We also teamed up with Gemini's consortium to evaluate federated learning method on their dataset. And lastly, we have some research going on with Cross's research lab to explore federated mixture of expert methods for time series prediction. Thank you all so much for your attention. Please feel free to reach out to me via email if you have any question about the library or would like to discuss anything further.
Hey everyone, I'm Michael, Head of AI at T-Rise. Today I'm excited to show you how you can bring greater verifiability, transparency, and monetization to your Flower deployments using the RiseMind library. At T-Rise, we work with financial institutions every day, helping them make their processes more efficient by digitizing their assets on distributed ledgers. Distributed ledgers are an incredibly powerful tool because they provide a fair, verifiable, and trustless system. But we didn't stop there. We wanted to take this a step further and enhance their business intelligence capabilities. Many financial institutions have sizable private datasets, but sharing this data could undermine their competitive edge. That's where federated learning comes in. It's a game changer, enabling them to unify their fragmented datasets without ever having to compromise the privacy of their data. And that's why we built RiseMind, to meet the high standards demanded by these institutions. The goal is to provide them with the tools they need to collaborate with each other in a positive sum game, creating a collective intelligence that's directly applicable to their unique business models. RiseMind is the product of over a year of research from the T-Rise labs at École de Technologie Supérieure, a Canadian university. We're incredibly proud of this collaboration, and we're just getting started. The lab has played an instrumental role in the development of this library and enables us to bring the academics solutions to productions. Now let's take a closer look at how RiseMind can make your Flower deployments even more powerful. First off, we give institutions full control over who can participate in the training process. By leveraging a smart contract, institutions can vote to accept or reject trainers, creating a cryptographically secure and fair process. This ensures that only trusted participants are involved, effectively creating a whitelist of public keys that the aggregator can use to accept or reject trainers. Next, we have authenticity verification. Each trainer signs model updates using their own private key before sending it to the aggregator, who can verify the provenance against the whitelist. This ensures that every update can be traced back to the specific trainer who produced it. Plus, we store the trainer's contribution on the blockchain, providing a verifiable, transparent record of each trainer's update. Now, I believe the most exciting aspect of RiseMind is the monetization feature. This creates a powerful incentive for trainers to integrate and deploy federated learning into their businesses. There are many ways to incentivize trainers, but my preferred method uses game theory to measure each trainer's marginal contribution. By aggregating multiple candidate global models, each excluding a different set of trainers, we can calculate the marginal contribution of each trainer. Using Flower's federated evaluation, we can easily distribute the evaluation of the candidate models to online trainers. This results in a fast parallelized computation of contribution, which reflects the data heterogeneity of the network. A lot of stuff is being worked on by our AI team, with two of my favorites being multi-server federated learning to improve decentralization, and using zero-knowledge proof to prove proper aggregation and inference of models while keeping the weights private. Now, let's jump into some code for our demo of RiseMind.
Hello, my name is Mikhail, and today I'll demo RiseMind library by walking you through an example based on the Flower C410 Quick Start. By adding a few wrappers from our library to your existing code, you'll get a client and server that use blockchain for authentication, security, and transparent payment distribution to trainers. First, the prerequisites. Whether you're an aggregator server or a trainer evaluator client, you'll need a private key. This key secures your account and grants access to blockchain contracts, ensuring only authorized participants can join and access their compensation. On the server, it lets you deploy contracts, start training grounds, and distribute rewards. Generate your private key using our mnemonic generator, which provides 12 random words to copy into your configuration file as your private key. For aggregator servers, visit risenet.io/deployer to enable contract deployment, and also ensure you have sufficient gas from our faucet. Now, if you check the configuration file, you need to set your blockchain network URL. In this demo, since we are using the RiseNet test, we will set the URL accordingly. And also you need to set your mnemonic variable. And that's it. You're ready to go. In this demo, trainers are compensated using the Shapley value method to accurately assess individual contributions. By wrapping your existing code with our signing client responsible for secure blockchain connection and our Shapley value client, your client will provide necessary metrics during training and evaluation to the server for proper compensation calculation. The server integration is similar as well. Begin with your existing federated learning strategy, for example here FedAprid, and load the configurations. Wrap that with our Shapley value strategy for servers and if account strategy, and your federated learning process on RiseNet's blockchain is ready. Now, let's run the system. For this demo, Flower runs in debug mode, so you can see all the detailed logs. You'll notice the Web3 model contract address, which we'll save for later inspection. Each training round identifies non-contributing free riders who receive no compensation, while contributing clients' blockchain addresses and rewards are clearly displayed and updated automatically. If we check the contract address, we can verify these transactions with our Blockchain Explorer, which shows transparent reward distribution. This demo highlights how our aggregator server interacts with the smart contracts to mint tokens and distribute them among trainers, ensuring every participant sees their earned rewards. For example, if we check the address of one of these clients, we can see all the rewards that have been sent to their addresses. Deploying a federated learning model with the RiseNet blockchain and the RiseMind library is both simple and very powerful. Thank you for joining me. I hope you found this demo insightful.
I hope this gets you thinking in new ways to improve your federated learning deployments with Flower. If so, feel free to reach out whether you're an academic or a professional, and we will get you started using our library. Thanks, everyone.
Hi everyone, my name is Xuefeng Xu. I'm a PhD student at the University of Warwick. Today I'm going to talk about FedPS, which is a tool designed for data processing in federated learning. In the first part of the talk, I will explain why data processing is necessary and how do we perform data processing in federated learning. Data preprocessing is a very important step that we do before the model training. For example, a real-world tabular dataset might look like this. It has some missing values, so I need to use missing value imputation. It contains some categorical data, so I need to use feature encoding to transform them into numerical values. It has some features, they have very different ranges, so I need to use feature scaling to transform them into similar ranges. Moreover, there are some complicated transformations, and some of the methods even use machine learning models. What is federated learning? It's the setting that there are many clients who are the data owners, and the server who is a coordinator, and the task is to train a machine learning model. However, the clients never send their local data to the server. Instead, they use this data to train a local model and send the model updates to the server. Here, I will give you two examples to show how to perform data processing in federated learning. The first one is called Z-score normalization, which is to subtract the mean and divide it by its standard variance, so that the transformed data has zero mean and univariance. In federated learning, the clients just send three elements to the server. The first one is the size of the dataset, the second one is sum of x, and the last one is sum of x squared. The server computes the sum of these three elements and can use simple equation to compute the mean and the variance. The second example is called feature binning, which is, for example, I have three bins and I want to put the data into one of the bin, and I want to ensure that the number of data examples in each bin are equal. So here I need to use quantiles. However, if I want to compute the exact quantile, the communication cost is very high, which means the client needs to send all of its datasets to the server. So the solution is to use quantile sketch, which is to compute the approximate quantiles with some error guarantee to reduce the communication cost. Here is the framework for federated data processing. So first, the client needs to compute the local statistics and send it to the server. The server performs aggregation and compute the processing parameters. Finally, send the parameters back to the clients to perform local processing. During the aggregation step, there are some simple stats such as mean and variance. There's some statistics. For example, the quantiles require high communication costs. We can use the sketching techniques. And also, there are some methods use federated machine learning models. For example, the k-means, k-nearest neighbors, and Bayes regression. The Python code of FedPS is public available on GitHub. It supports all processing methods in scikit-learn. It's very simple to use. Just set up the communication channel, specify which is the client, which is the server, and the rest is exactly the same as scikit-learn. In the second part, I will talk about a specific processing method called power transform. I will explain why ordinary method is not robust, and I will also present a solution to numerical instability. What is power transform? It can transform any data into a Gaussian distribution. It is a parametric method which uses a parameter called lambda. One of the power transform methods is called box-Cox transformation. And we can use maximal likelihood estimation to get the optimal lambda. And here's a log likelihood function. What I want to mention here is the red part, and this can cause numerical instability issues. What do I mean by numerical instability is the following. If I use certain version of SciPy and I want to compute the optimal lambda for this dataset, I will get a runtime warning. It says overflow encountered. And this is because maximal likelihood estimation is sensitive to outliers. In fact, there is a simple recipe to compute adversarial datasets with skewed distribution and small variance. For example, this dataset, the optimal lambda is 357, and after apply the transformation, I can get a quite big number. Moreover, if I replace the last element to 9.9999, the optimal lambda is even bigger, and the transform data is a very, very big number. The solution is called log space computation. So our goal is to compute the log of the variance of the transform data. The ordinary method is linear space computation, which is to apply the transformation, compute the variance, then compute the log of the variance. So the log space computation is that because our objective is to compute the log of the variance, we can doing every computation in the log space. So with this technique, we can compute the optimal lambda for the dataset that shown in the last slide. This solution has been integrated into SciPy box-Cox with log space computation and other considerations to better enhance the numerical stability. The following modules are box-Cox log likelihood function, the maximal likelihood estimation, and the box-Cox transformation function and its inverse. To sum up, FedPS is a tool designed for data processing in federated learning. It supports all processing methods in scikit-learn. It's very comprehensive, flexible, and robust. So that concludes my talk. Thank you very much for your attention.
So hello everyone, my name is Rob, and this work together with my supervisors Crystals, Yuki, and Max. We studied differential privacy in decentralized inference applications. This work got published both at AIII and at the ICLEAR workshop. At both conferences it received like an oral and a spotlight workshop, or a spotlight talk. So the setting of the talk is the COVID pandemic, which in 2021 had devastating consequences. And to remedy this, one of the options was contact tracing apps, which is the idea that everybody installs an app which can track your, can send messages to your contacts about your virus scores. In studies, they were shown to be effective. However, in practice, they were not used for privacy reasons. Therefore, we study one attack in these contact tracing applications and propose like an algorithm that has differential privacy against this attack scenario. And the attack scenario is the following: an attacker A in the purple phone has a score X and wants to figure out the score of the victim. Well, if they today have a known score X, which are being presented in the attack model, and tomorrow they have a new score, which is a function of only the victim, as it's a deterministic function, they can figure out the score of the victim. And this happens despite any cryptographic protocols in order to, of course, do all the proper Bluetooth hashing. A common defense is, for example, require that at least a sufficient number of other contacts have happened before the first score is revealed, but then the attacker can have co-attackers with known scores. The algorithm is a statistics update on a graph where every day every person is assigned a score and there are being messages being sent between users. So high-level statistics update, of course, the details are in the paper, and I'm happy to mention them later. But at a high level, this algorithm proceeds as every day, every person can take a test and receive messages from the people they were contacted by, and they will send their updated virus scores to the people they contacted. This application already happens decentralized. There's no central server doing these calculations. But now we also desire differential privacy for this update function. Differential privacy is widely used in industry, and it, for example, in industry applications, and it goes by the definition that for any adjacent data sets, the predictions that are being made, for example, in our case, the predictions that are being made for a COVID score should be epsilon delta close. I mean, their probability distributions. In our case, we can achieve this because we know, a contribution of our paper is to show that this statistical update has a bounded sensitivity, and as such, we can add noise according to the Gaussian mechanism. We go even one step further and we say now that we know about bounded sensitivity, we might as well train a neural network that has the same sensitivity. And this goes under the theme of neural augmentation, which is common, for example, in MRI reconstruction, and coding applications, like coding theory applications. In this case, the neural network, and this is also a new insight from us, should be Lipschitz, because the moment it has a bounded, is an upper bounded Lipschitz constant, we know the sensitivity of the predictions made by the neural network as well. This method is being tested on a big simulator of agents that run around according to population statistics and job statistics, occupation statistics. This is a widely used simulator published by common in literature, and we see that for the target epsilon parameter of epsilon equals 1 differential privacy, the peak infection rate, so the number of people having the virus, the worst day in the pandemic, is significantly lower than methods that we compare with. So the conclusion, we present Lipschitz neural network as providing as a novel view for algorithms with bounded sensitivity. Neural network or neural augmentations then increases sensitivity, but the better predictions compare favorably to the additional noise required for to achieve the same differential privacy bounds. Future work are decentralized reinforcement learning. Know that the application is already decentralized, but one might be interested in decentralized reinforcement learning and also situations of partial adoption, and of course federated learning of either the policy or the neural augmentation. This was a very quick summary. I'll be very happy to meet and talk more at the poster or reach me via email. or the flower Slack. Thank you.
Imagine you have to train a machine learning model and you have a deadline tomorrow. So you decide to use multiple devices, let's say multiple GPUs, to accelerate your training. So you parallelize your stochastic gradient descent on these different devices. You run it at night, you go home, sleep, and hoping that in the morning you'll come and the experiments will be finished. But then you come in the morning and see that they are not finished. The problem is that one of the devices is not working. Maybe someone accidentally turned it off at night. So the main problem was that you needed to synchronize these devices because you were doing something like fat averaging, let's say, and every time if you have a device which is not working, you cannot do it simply. You need to synchronize. So do you wish you had a method which was asynchronous SGD? Asynchronous SGD would solve this problem. So since you have a deadline tomorrow, you want this method to be as fast as possible. That is, you want this method to be have the optimal time complexity. And Ringmaster SGD is the first method that is asynchronous and has optimal time complexity. Let's formalize the setup. So we have different devices, in this case, 3 devices. And as I said, these devices can be GPUs. So we assume that each device can compute a stochastic gradient of our loss function. And this gradient is an unbiased estimator of the true loss function. So that is, all of the devices have the same data distribution. Now, since these devices are heterogeneous, they have different power. So whenever you ask a device to compute a gradient, it will take different tau I time to finish its computations. So since you have devices which are slower, so these taus can be also infinity, so synchronized approaches are not going to be good here. So you want asynchronous SGT. Let's look at asynchronous SGT. How does it look like? So you want to update your current point every time you receive a gradient. That is, you don't care about the slow devices, if they finish their computations or not. You don't care about them. You simply update whenever you receive a gradient. But the problem with this approach is that this is no longer ASGD. You cannot write it this way. And the reason is, let's see it in this slide. So let's say you start your training, you ask all of the devices to compute a gradient. Let's say the first one finished its computations, it sends you the gradient, you do an update, you send the current updated point back to the worker starts gradient calculation at this new point, and then let's say the second one finishes its gradient computations. It sends you the gradient, you do an update. Now note that you're updating your point x1 with a gradient at point x0. So you have a delay, we call this delay delta. And the delay is the difference between the current point and the point that you are updating your gradient from. So then you send this new point to the server does this, compute this at this new point. So in general, you can write the asynchronous SGD updates this way. So it looks like looks a lot like SGD, but the only difference is that you're updating with an old point with this delta k, and this delta k can be big. So if it's 0, then it's simple SGD. If it can be big and as big as the total number of iterations. Imagine you have a worker which was not working at all in the whole round of iterations, and then at the end, the final step, it decides to send a gradient with at x0, so delay would be exactly the number of iterations you do. Now, this algorithm was first introduced in this paper, and they called it hog-wild. I don't know exactly why it's called hog-wild, but I'm assuming that the method itself sounds wild, and it does these crazy wild updates. And to see why these updates are bad actually, and let's see why they are bad. And let's see why in this simple example we have this x squared plus 5y squared function, and we have a contour plot here, and we want to find a minimizer. Let's say we do gradient descent, but starting from some point x0. Now let's say we are at point x5, and we receive a gradient at x0 that is with delay 5. So what happens if you do an update with delay of 5? You'll go to this point. And at this point, the loss function is almost the same as the one that you are started with at x0. So that is, you did 6 iterations, but you basically did nothing because you didn't decrease your loss function. And this looks terrible. Now, this is because the hog wild is very wild, and it's wild and greedy. It tries to use all of the workers every time. So we say, how about we just tame it? We make it less wild, because this wild behavior is not It's not really beneficial. So how do we tame it? The key idea is to reduce the delay. So what happens, let's say, if we, instead of 5 delay, if we had 3 delay, we would do this type of update. And this update doesn't look that bad. Though now the main question is, how can we reduce the delay? So the most naive idea of reducing the delay is to simply remove the cause of these delays. Why there are big delays? There are big delays because we have slow workers. Why don't we just simply remove them? And it turns out, if you do this removing devices carefully, I mean, if you do using this formula, then you also have optimal time complexity. So what is this formula? This formula depends on the variance of your gradient estimator, the epsilon accuracy you want to achieve, and the tau I times. So here we assume tau i's are non-decreasing. So you choose this first fastest M star workers, and you'll get the optimal time complexity. Now the problem here is that you don't know this tau i's. And you don't, on top of that, these tau i's can be dynamic. They can change over time. So maybe some devices are fast in the beginning, but then over the next iterations, they can become slow or vice versa. So we want an algorithm which dynamically chooses these fast devices every time, let's say. So how do we do it? Very simple. Let's say we have, every time we receive a gradient from some worker, some delay delta k, we simply check the delay. If the delay is smaller than some threshold r, if it is, then we update our point using a similar HGD type update. If not, we simply ignore it. We don't do anything with this gradient, but we send our current point xk to the worker, then send us the gradient, the delayed gradient, hoping that in the future it will compute the gradient fast enough so it will be smaller than the threshold. Now the only question is, how can we choose this r? Now if r is 1, what happens? You ignore all of the other gradient except the fastest one. So you will apply one gradient and then you will ignore the rest, because for the other ones the delay would be bigger than 1. So in this case, we call this method hero SGD. So you have one hero, fastest worker, and it will be only the worker used. You will not use the other workers. On the other hand, if you go all the way r to infinity, you'll use all the workers. So you'll get hog wild. Now the sweet spot is somewhere in the middle. You want r to be this, and this is the optimal r, which depends on, again, variance and the epsilon accuracy you want to achieve. Okay, let's show some theoretical results. So this is the iteration complexity of the algorithm. Depends on r, and if r is bigger, then that means the delays are big, and this is and the iteration complexity increases. And this is intuitive because the bigger are the delays, the worse updates you are doing, and you need more iteration to recover that bad updates. But we don't really care about iteration complexity. We care about the time complexity. So let's see the time complexity. And this is almost the same as the formula I showed you before, except there is 1 over epsilon divided by 1 epsilon, this. Now, what is this? So we have a harmonic mean of this tau i's again. So this is a non-decreasing function because tau i's, we assume they are sorted non-decreasingly. And we have another term which is decreasing with m. So this introduces some trade-off. On the other hand, you want to use as much devices as possible, but you don't want to use more because you will increase this harmonic mean time, basically. And it turns out this is the optimal time complexity. And in practice, our method is also the fastest. We compare to 2 other different methods. So delay adaptive SGD. In delay adaptive SGD, they dealt with big delays by simply reducing the step size. If there is a big delay, they reduce the step size. And for Renala, it is a semi-asynchronous method. So it does the mini batch. It's basically mini batch SGD, but mini batch collection is done asynchronously. And our method is fully asynchronous, and it's the fastest. All right, to conclude, so next time if you want to train like some machine learning model and you want to do it as fast as possible, and especially if you have a deadline, try using Ringmaster SGD. If you have any questions, you can find me almost anywhere.
Hello, hi, my name is Andrea Isoni, and the Chief AI Officer of AI Technologies, a company specialized in developing bespoke AI solution for clients. The reason why I'm here is because I want to share just an idea, okay? An idea on how distributed AI merging with blockchain technology can manage workload and tasks probably more efficiently than using just localized or any AI solution we experience today. Okay. Now, what's the status today? How we experience it, AI solution or blockchain solution? The typical user experience for the vast majority of the population is to have a centralized data centers when the operations are made and also where the data is stored. Yeah. And then you have user, let's say ChatGPT or any other solution, widespread or less widespread, in which they have an interface, probably contributing to the proprietary data and interacting with these data centers proprietary data that this company has. And the other side, you have the blockchain. Now, obviously there are many blockchain solutions, but the user experience usually has a wallet or some sort of interface interaction, which is usually a little bit clunky, question mark. And the problem with that is the blockchain needs to have a very tech-savvy user base, as in the interface is usually not user-friendly, and the use cases are usually not very clear what problem they are solved overall. Yeah. On the other side, in the AI experience we got today as a users, we usually have a problem with proprietary data of the company we can use it, not use it, or even our data become proprietary data of the company we are using. There is a problem on localization on computation in the data centers, which saying like that doesn't seem as a problem, but it is in terms of cybersecurity, because that is a point of contact of vulnerability when we share our data, the sensitivity of our data, or things like that. So the localization brings us a problem of sharing data in a localized way that hence enhances the cybersecurity exposure. As you can see, both technologies, AI and blockchain, have problems. Yeah, if you can find a way to merge these two together to minimize their common their respective issues, we have a better solution overall. And therefore, that's what we see today in the market, to be honest, as you can see from these few examples. One is, for example, the crypto trading analyst bot. If you go on X, the social network, you will see an account called AIXBT. I believe now has like 500,000 followers. Yeah, and all it does is analyzing from a large language model in real time all the information about all the crypto available and human analysts on the crypto available, digest it and provide it for any user that follow the account insights and suggestions based on all the information you can find. Again, it's a bot. It's based on a large language model and a blockchain called Virtuals that allows the distribution of building the solution with different data and different developers that contribute to this bot. Okay. Now you have other example like BitTensor, Macrocosmos SI, or ASI. It's not written here. That all they do is a platform to share both data and computational resources to build better models. As an example, you see in the slide, ES is folding for genomics or simulation of proteins, for example. So there is a community that either provide computational resources or specialized data. They put it together in a decentralized way to build and train a better model. Then they have resources purely for decentralized GPU and sharing of GPU for rendering in graphics design or things like that, like the render network. Or you have a solution purely for the AI community to share and train model in a decentralized way, like Flower AI. Yeah. Now, as you can see in this example, there are common traits I would like to highlight. First is somehow, somewhere, the early adopters, especially in the blockchain technology, are community driven. There is a community or early adopter that are tech savvy that bring the solution forward. Yeah. And the other aspect I want to highlight is that all these solutions rely on some sort of privacy build technology to allow the data sharing in a way that is both secure and computationally not too much expensive, okay? Now, if you see that, and you're old enough to remember, that sounds something that we may already experience it in the past in terms of the battle between Encarta, which was an encyclopedia owned by Microsoft, and Wikipedia. We are about in the late 90s, early 2000, and Microsoft had a proprietary, again, paid service, encyclopedia called Encarta, and then it was starting to emerge an encyclopedia, obviously now the most famous one, called Wikipedia, which was distributed, and as a large pool of community-driven early adopters. And when I say early adopter, I'm not saying just that, but early adopter of the internet. Few people in the late 90s use the internet or understand what the internet is. So these are tech-savvy adopter of the day, Now internet is not something tech-savvy, but back then was, And so as you can see, is something that we kind of experience with news technology today. We have big corporation on AI, that have centralized data centers, centralized data, all of that, compared to something that is emerging with communities, again, or early adopter or tech-savvy adopter in the blockchain and AI community that may challenge this. Now, just to close on this, I'm not saying I know who wins. In fact, it could be that this solution, both the proprietary centralized model and the decentralized blockchain model, could have different use cases, but definitely something to bear in mind. If you combine a decentralized AI solution and a decentralized blockchain, you may have something that could challenge the AI centralized solutions we experience today. And with that, I thank you for your time. I hope you learned something today.
Hello, my name is Ashkan, and I'm a postdoctoral researcher here at the Norwegian University of Science and Technology, and I would like to share our work on detecting clinically significant prostate cancer using federated learning. So let me share the screen. The title of this study is Federated Learning for Prostate Cancer Detection in Bioparametric MRI. And this work has been presented at the SBI Medical Imaging Conference in 2024. And here at the Flower AI Summit in 2025, we are basically showcasing our previous work. So prostate cancer is a global problem, and data shows that it is the second most prevalent cancer in male population, as well as the first cancer-related cause of cancer-related death in male population. But it has been shown that efficient management of diagnosis and treatment process can have a huge impact on the individual and societal, as well as the economical aspects of the prostate cancer diagnosis process. So here you see a typical pathway of the prostate cancer diagnostics, that it starts with PSA and digital rectal examination testing, and it would follows by MRI scans, and based on the decision of a radiologist, it can go through biopsy and the rest of the process. So pre-biopsy multiparametric MRI scan is usually recommended by international guidelines because it helps to reduce unnecessary number of biopsies, as well as increasing the performance of detecting clinically significant prostate cancer. But we have some challenges here, which basically is the finite resources, which are the radiologists. And also at the same time, since we have an aging population and the number of active surveillance cases are increasing, these limited resources would be more and more overwhelmed. So what is the solution here is to use AI in order to rescue the prostate cancer detection process. This has been already done in a well-known international grand challenge called PKI, and the results of this grand challenge has shown that artificial intelligence can help to train a model in order to reach a performance as good as the performance of the radiologist, for detecting clinically significant prostate cancer. So in this work, we also focus on this issue. But typically, the proposed model in the PKI Grand Challenge were centralized deep learning-based model, which they need a large and a diverse set of data in order to provide a good performance, which is not typically available in a single institution. Thus, the institutes require to share their patient data in order to improve the performance, but this would raise privacy concerns and would not be a proper solution. To solve this problem, we are using federated learning, which basically gives us the opportunity to have the decentralized model training without the requirements of sharing data, and the participating clients only share their model parameters, and this would be aggregated at the server and would be sent back to the clients. So we hypothesize that the federated learning can allow us to reach the performance similar to the centralized model training while achieving a certain amount of privacy, because we do not share the data. So in this work, we are trying to solve the problem of detecting a clinically significant prostate cancer on biparametric MRI data. And for the local model training at the clients, we are using an unit, while the input data for each client would be the T2-weighted ADC, IB value, diffusion-weighted MR images, and the expected output for the trained model is a pixel-wise segmented lesion map with which that shows the likelihood of harboring clinically significant prostate cancer. To implement the federated learning part, we use Flower federated learning, and in order to evaluate the models, we use the recommendation from the PKI Grand Challenge, which is using area under the RC curves for patient level evaluation and average precision for lesion level evaluation. And overall, we use PKI score, which is the average of these two metrics, for evaluate each models. The dataset that we've been using in this work is the PKI Public Training and Development dataset that involves 1,500 cases from 3 different institutes. And we also use an in-house test set from our institution, including almost 200 cases. So here you see the distribution of the train validation and test sets for our 3 clients. And in order to have a sense of comparison between FL and a centralized model, we designed a centralized experiment in a way that each of these data, training, validation, and test, for the centralized model are the aggregated version of the all corresponding data from all the participating clients. So here you see a brief summary of the architecture, which is a federated learning model with 3 clients that we are using in this study. And we trained 8 different models, 3 of which are the local models, and each model would be trained locally in isolation at each client until they reach convergence, which here we use 1,000 epochs. For the centralized baseline model and the federated learning baseline model, we also trained the models for 1,000 epoch for centralized, and for the federated baseline for 1 epoch locally and 1,000 federated rounds. And then we have 3 optimized federated learning models, which we optimize the combination of a local epoch and federated rounds in the first one, the aggregation strategies by trying different aggregation strategies at the server side, and also in the final model, we optimize these 2 parameters at the same time. And then we assess the performance of these trained model on internal and external test sets. And also it's better to mention that each of these models would be were trained 5 times over 5 different polls, and the final evaluation result is from the ensembled version from these 5 different models. So here in this very crowded table, you can see the PKI score. evaluated on different test sets. And just to make it easier to follow, you can see that the FL baseline can improve the performance compared to all of the local models consistently. And this would basically incentivize the clients in order to join the federation. You can also see that the federated baseline can reach the performance close to the centralized model without requirement of sharing the data. And you see that for fine-tuning the federated configuration, we can improve the performance compared to the FL baseline. However, this improvement is marginal, but it is consistent. So here you see qualitative performance of the federated model compared to the local, centralized, and the ground truth delineation of the clinically significant prostate cancer. And you see that the tuned federated learning can generalize the model best in order to detect the lesions in different unseen test cases. So as a take-home message, we can say that the federated learning baseline can outperform the local models, and it can reach the performance as good as the centralized baseline model. Also, by fine-tuning the federated configuration, we can further refine the performance. However, we had some limitation, which basically this study was a simulation study and it's not a real-world implementation. We also did not consider optimizing the hyperparameter of the optimization-based aggregation strategies that we used in the server sides. And we did not also consider the privacy preserving models like differential privacy or homomorphic encryption approaches. So thank you so much for listening, and you can find the complete version of the conference paper on the QR code that you see, and also the description of our project and the rest of the information. Thank you.
Hello, I hope you're enjoying the Flower AI Summit. I'm going to present a demo on how to scale Flower AI simulations to multi-node cluster in a simple manner, like in a way that you just submit your simulation as a job and you don't need to manually configure the nodes with dependencies and all that. So if you're a researcher and when you're running local simulations, you don't want to be limited to the resource on your local machine, this is an interesting approach. So I'm Aline. If you're into GPUs, AI scaling, decentralized AI, let you connect the QR code to connect to my LinkedIn profile. All the necessary code is on this repository. And first I'm going to set up a Ray cluster locally and then submit the Flower simulation as a Ray job to this local Ray cluster so that we get intuition. And then everyone can also replicate by themselves. And then we're going to spin up a real Ray cluster using the IO Cloud. And then you're going to see in the real scenario how it works. So I'm going to dedicate the full screen for the code. So I'm saying goodbye, and I also passed the fake AI video test. So yes, let's go to the code. For this demo, we're going to scale the quick start PyTorch simulation example based on the original Flower repo. Instead of running locally, we're going to submit as a Ray job. So I'm assuming you're familiar with running local Flower AI simulations. And we are going to show the difference, how it would be submitting to a Ray cluster. One thing to consider is the Ray version used in the application is to match the one of the Ray cluster, and Flower requires Ray 2.31. So that's the Ray cluster that needs to run on. So when running on the IoT Ray cluster that we are going to spin up at the end of the demo, we use a fork of Flower that match the IoT Ray cluster and also includes some useful changes for a production Ray cluster. And this change might eventually also merge to the main Flower release if it makes sense. Then let's go for the execution. So running locally, one would execute this command or with other parameters. And with the Ray job submission, the command goes after this dash and we configure the runtime environment and other parameters on the Ray job submit. So if we look at the dependence on the pipe project, we are just migrated to the requirements so that we can send at the job submission time. Here, like we are passing the working directory as the local, so it will upload the current folder. That means the current folder of the application. Then it's going to run this command, and it's going to prepare the runtime based on the requirements. So I'm going to start array node, head node. It started, and now I can submit a job to the array cluster which is running. If it was a remote array cluster, then you would pass the address. So job submitted. We can also check the result on the dashboard. Let's have a look on the dashboard. Here is the job submitted, and then we can check. It's preparing the runtime. Here we can see the configurations, and so it will be available to check logs and more details. Let me refresh. Then we also have the other types of logs, and you can see all the jobs submitted. So let's go back to the terminal. Yes, we just submitted as a great job. Congrats. And I show that I still don't have Flower installed in this environment. There might be some case that we want to wrap the call and add some custom code to prepare some other aspects. We're not going to the details in this demo, but I do have a section here and this optional intermediate script that you can use to wrap up some code that you want to execute within the context. If you want to use a conda-based environment, you also have the requirements here based on the original pipe project. Now let's run on a real array cluster. So I'm going to spin up array cluster. So we select the 8100 and then the array app. Going to deploy. So let me rename this cluster. Let's view this cluster. Let's open the Visual Studio. Now we have a cluster running. We are sitting on this Visual Studio code on the cluster itself. Let's just configure this header to make the life easier, and then we're going to submit using this option, and then it's submitting to the head node. Let's have a look. That's the array dashboard. We can see the log setting up the runtime environment, and it's going to be executing. Yes, congrats, one more. We see the GPU is starting to work, but it's very fast. The model actually is very small. So this quick start PyTorch. I hope you enjoyed the demo. It's just a starting point. There is a lot of things to do to really optimize the resource, to ensure correct allocation and check the latency for communication. So this is, I would say, is a starting point, and I'm curious to see how it evolves within the community. And about IONET and IoT Foundation, I have some information here and contact information. Feel free to reach out and also get to know the research areas and explore possibilities of partnerships. That's how the IO Cloud works. It gets the underutilized supply of GPUs and to create the array clusters that we've just seen, and how it's the architecture. I'll just go forward